Hello and welcome to our course. I am Anita and you have come across our Excel Masterclass. Why is it worth watching? Well, because by watching it, you will learn everything you need for your job or for your MOS or ICDL certification exams. This course is ideal if you're either a beginner looking for a complete A to Z walkthrough or a more experienced user looking for extra training. What's most important in this lesson is that you will learn how you should think in order to use Excel properly. You won't learn by heart where the various buttons and menus are, so that you will be able to put your skills into practice regardless of the Microsoft Office version in front of you. Apart from familiarizing you with Microsoft Excel, this course will introduce you to most functions and formulas of Microsoft Excel, as well as to ways to create tables and charts. We'll teach you how to format spreadsheets, how to analyze data to reach valuable assumptions, for instance from financial statements, charts, sales invoices, pivot tables, etc. Will make you ready to respond to professional or academic challenges. And last but not least, this course covers the MOS Excel Associate Certification syllabus. So what are you waiting for? Subscribe to our YouTube channel to access more than 46,000 of videos with useful tips and instructions. Hello!
Hello from me too.
Today we will start our course for Excel. It is aimed at beginners and we will gradually be advancing the difficulty. We will start with a brief description of the Excel environment, and continue with how we can open, close, create and save a workbook. We will also learn how to navigate between workbooks.
Things will then get a bit more interesting. We will select cells and insert, edit or delete the data they include. We will continue with learning how to copy and move cell data using the clipboard.
We will end this section by showing how to find, replace and sort the data in our cells. Let's begin. We will start with a brief description of the Excel environment. Microsoft Excel is a spreadsheet application. It is used to monitor...
Shouldn't we begin with how to launch Excel?
Yeah, why not?
If we want to open the Microsoft Excel application, we click the Start menu. If we don't have Excel pinned as it is here, we click on the All Apps button and then on Excel. And here is the Excel home screen.
Of course, to make the rest of the lesson easier to understand, we will need an Excel sheet with some data on it. So, on our screen, we can see the computer sales per month for these three companies. This cell here displays the total of sales for January. At the top of the window, we can see the title bar, displaying the name of the application and the name of the book.
Excel creates books in the same way that Word creates documents.
So, the book we're working on is named Sales.XLSX because Excel saves files with a .xlsx extension.
Earlier Excel versions, such as Excel 2003, used the .xls.
This is the 2021 version, right?
Yes, indeed.
Okay. So, every book is composed of worksheets. This particular workbook contains the sales, chart, and the sheet 3 worksheet.
We can insert more worksheets or remove some of them.
Right underneath the title bar, we can see the ribbon, which is organized in tabs. Each tab contains groups of commands. On the upper left corner, we can find the File tab. Right above it, we can find some more icons. Below the ribbon, we can find the formula bar, this one.
We will see what it's used for in a while. Let's take a look at the workbook. It is composed of columns. We can see column A, B, C, etc.
Older Excel versions offered 256 columns, whereas since the 2007 version there are 16,384 available columns.
Apart from columns, Excel also contains rows. This is the first one, the second one, the third row, etc.
Older Excel versions offered 65,536 rows in total, whereas since its 2007 version, Excel offers 1,048,576 rows.
Wow, that's more than 1,000,000 rows. Too many. Very useful feature for managing large files.
Yes, very useful for large data.
So the areas where columns and rows cross are called cells. For example, this is cell B4, B from the letter of the column and 4 from the number of the line. The B4 cell reference is displayed in here. If we click the cell here, we can see it's cell J17. And this one is cell B9.
Keep in mind that cell references use Latin characters only.
The Excel mouse pointer can take several forms. Its form depends on the area where it is placed in. If we bring it to a column heading, it looks like an arrow.
By clicking here, we can select the entire column.
If we bring the mouse pointer in column G and drag it to the right, holding the left mouse button down, we can select more than one columns. If we bring it on a row number and click it, this row will be selected.
Likewise, if we drag downwards or upwards, holding the left mouse button down, one or more rows will be selected.
When the mouse pointer is placed between two columns, it takes the form of a double arrow. If we click once, we can drag the grid line to the right or to the left and change the column width.
The same applies for the row height. We bring the mouse pointer between the third and the fourth row, and holding the left mouse button down, we drag downwards or upwards.
This is more or less how we can adjust the various columns and rows to the dimensions we want to. Let's take a look at the cells. If we want to select a cell, all we have to do is click on it. So we've just selected cell E12.
We can see there is a function in the formula bar. This formula determines the result in this particular cell.
If we want to click on an icon, the pointer takes this form. It also takes the same form if we want to select another worksheet. We're on the chart worksheet right now, and now on the sales worksheet. So let's select cell I12. If we bring the mouse pointer to its border, it takes the form of a cross. If we hold the left mouse button down and drag to a different position, the contents of the cell will be moved. The mouse pointer will also take another form as soon as we bring it to the bottom right angle of the cell. It will then take the form of a small thin cross. If we bring the mouse pointer to the formula bar, it will take the form of the insertion point.
You can then click inside the formula bar. The mouse pointer is flickering at this point here, so we can correct the formula if we want.
This concludes our brief description of the Excel environment. Let's see how we can create a new workbook. On our screen, we're seeing the Microsoft Excel application, but there isn't any open worksheet. On the right-hand side, we can see several available templates and select the one we want to create. In our case, a blank workbook.
We can also create a workbook based on a template if we want to. We'll have to click the File tab and then click on New. We can choose one of the templates in our screen or search for one of the thousands of ready-made Excel templates available on the web. We will choose one that is available right here, let's say the Sales Report template. We double-click on it and a new workbook has been created named Sales Report 1. It is based on the respective template.
That wasn't so hard, right? It is time to learn how to save a workbook. Our screen is currently displaying the Sales.xls workbook. If we just want to save it, we click the icon at the upper left corner of Excel.
Or select the File tab and then click on Save.
If we want to save it with a different name, we click the Save As option.
File and then Save As. We then click on the Browse button, select the location we want to save it at.
It pops up a dialog box from where we can select the storage location or medium and then type a new name. We can also save the workbook in another file type if we want, among the options that Excel gives us. Finally, we click the Save button.
One of the available file types is the Templates one. Again, we click File, Save As, Browse, Excel Templates, and in the Excel.TX extension. We can select from the type Excel Template. There it is, Excel Template, Excel.TX extension. Be careful though, the moment we change the type to Template, the folder we were in the desktop folder, has changed. Excel automatically navigated to the Templates location. If we want to save the template in this location, all we have to do is click the Save button. Otherwise, we can just select a different location. I wanted to save it on desktop, so I click on desktop and then Save.
So we have learned how we can save our workbooks fast and easy. In this lesson, we will learn how to open workbooks, how to navigate between them, and how to close them.
The first step, of course, is to open the Microsoft Excel application. We click the Start menu, and if it is not pinned, as it is here, we go in the All Apps, and then on Excel. We click on the Open icon and locate from our desktop by clicking the Browse button and then the desktop icon, the client's XLSX, and open it. We want to open one more file, so click on File, Open, again Browse, and open the Sales XLSX file.
If we hover our mouse above the Excel icon of the taskbar, a small window will appear, containing a small preview of all our open files. We can see two open workbooks right now, the clients.xlsx and the sales.xlsx. To navigate between them, we just have to click on the small preview of the sheet we want to go to.
We can of course achieve the same from the ribbon. We go to the View tab click on the Switch Windows icon and switch to the other window, the client's file.
If we want to close the workbook, we click the X icon of the small preview of the sheet we want to close.
To close the other workbook, we can click on the File tab and then click on Close.
Our screen is currently displaying the Microsoft Excel application only. There aren't any open workbooks. We can create one if we want to. As we've already mentioned, from the File tab, we click on New.
If we want to close Microsoft Excel application as well, all we have to do is click the X icon on the top right part of Excel's window.
Yes, this works the same way as in all other Windows applications.
This wasn't so hard, right? We have learned how to open workbooks, how to close them, and how to switch between them. Excel's ribbon is populated with dozens of buttons and options to choose from. Some of them reside in the Quick Access toolbar. Let's see how we can customize them or even add some more buttons to them if we want.
Let's start from the basics. This is the Quick Access toolbar, and this is a ribbon. By right-clicking on the bar itself, we have the option to move it either above the ribbon or below the ribbon.
We can collapse the ribbon either by clicking on the small arrow at its bottom right corner or right-clicking on it and choose to collapse it. To restore it, we can either click on a tab to make it reappear and then click on the pin icon at its bottom right, or you can right-click on it and uncheck the collapse option. If we have the 365 version of Office installed, we can click on the small arrow at the bottom right of the ribbon and choose whether we want to hide it or show the Quick Access toolbar. As you can see, this arrow offers us more choices. We can use it to only show the tabs of the ribbon. This is similar to collapsing the ribbon in the previous versions of Office. We have to click on a tab for it to briefly appear to allow us to make a choice. If we want to make the ribbon appear again, we click on the same arrow and choose to always show the ribbon. We can also activate full screen mode. The whole ribbon is vanished and we have to click on the top of the screen for it to appear again. To reset the ribbon to its default state, we have to click on the arrow icon again and enable the Always Show the Ribbon option.
We have learned how to show and hide them. Now it's time to learn how to add and remove buttons to them.
If we want to add one of the ribbon buttons to the Quick Access toolbar, all we have to do is right-click on it, for example, the Wrap Text button. We right-click on it and choose Add to Quick Access toolbar. Here it is on the Quick Access toolbar. To remove a button from the Quick Access toolbar, we just right-click on it and select Remove from Quick Access toolbar. Easy, right?
What happens if we want to add a button or command in the Quick Access toolbar when it is not shown in the ribbon? In this case, we have to right-click on the Quick Access toolbar and select Customize. The Excel Options window has just opened with the category Quick Access toolbar selected. This means that if we close this window, we can reach it through a different route. We click on the File menu and then on Options and select Quick Access toolbar category. We're back there. In the left part of the window, we can see a drop-down menu on the top. From here, we can select the category of commands we want to browse through in order to select the one we want to add to the Quick Access toolbar.
Here we can find the Popular Commands category, which is selected by default. Other categories are the commands that are not found in the ribbon, all the commands, macros to create a button that will run one of our macros, very useful, and finally the commands grouped by ribbon tab.
We select all the commands. First on the list is the separator. This is useful if we want to group the toolbar buttons. We click on it. In the middle of the window there are two buttons. We click on the Add button to add the separator, and then select the About command from the left and add it as well. On the right there are two more buttons, an up and down arrow. We select the separator we have added to the toolbar and click on the top button to move it to the top of the line or the bottom to move it further down the line.
If we want to remove a command, then from the right of the window we select the command we want to remove. Let's say we want to remove the separator. We click on it, and then from the middle of the window we click on the Remove button.
On the bottom left of the window we have the option to show the Quick Access toolbar below the ribbon. On the bottom right we can reset our changes to the default. We can just reset our Quick Access toolbar customizations or all of them. We can also export or import our customizations. This is very useful if you want to move your customizations from another PC.
If we click on OK, the changes we have made have been applied. We won't do it just yet. First, we have to explain the last visible button, the Modify button. This button is only used when we have added a macro command.
So, we select the macro commands and we can see that we have a macro in our workbook. We select it and add it. The Modify button has been enabled. If we click on it, we can change the icon and the name of our macro button. We change it to bold letters and choose an icon of our liking.
The smiling face will always be my choice, even though it is better to choose something that will remind you of what the macro actually does. We click on OK and OK again, and you can see our new buttons. And if we hover above our macro button, we will see the name we have set to it, bold letters.
This lesson is getting rather long. Let's go to the last topic: how to add or remove buttons from the ribbon. The process is mostly similar. We right-click on the ribbon and select Customize.
The left part of the window is the same as before. We can reach this same window from the Excel options, as we have already seen. On the top right of the window, there is a drop-down that lets us customize the main tabs, the tool tabs, or all the tabs. The tool tabs are those that are shown when we click on specific Excel objects. For example, if we click on a chart, the Chart Design tab will appear.
Let's select the main tabs. We can hide or show any tab we want by clicking on the checkbox beside them. Let's show the Developer tab. We click on the checkbox and then on OK. Here it is, the Developer tab. If we want to hide it, we just go to the Customization window again and uncheck the box. Now it is hidden.
Each tab is divided in groups, and each group has a number of buttons assigned to it. Even though we can hide any tab we want, we cannot remove buttons from the groups of the main tabs. We cannot remove groups also. We can rename them though. We select a group, for example the clipboard group, and click on the button Rename.
We can also add our own tabs and groups on the ribbon. We can add a group to an already existing ribbon by clicking on the New Group button. But let's add a new tab first and add the group to that one. We click on New Tab. A new tab is inserted after the tab we had selected. We can change its position by using the arrow keys on the right.
The tab has a default name and a group has already been added to it with a default name as well. We click on Rename to rename the tab to Test for You. Then we click on the group and click on the Rename button again.
This time, instead of just a name, we have the ability to choose an icon as well. This will be the icon that will be shown in smaller screens when there is no way to show all the icons of the group. You know which one I will choose, right? For name, I will type Excel. Having the group selected, we can add buttons, pretty much the same way we did when we added buttons in the Quick Access toolbar.
We add two random buttons. We can change their position by using the arrows on the right. We add another group and we call that one Charts. So we won't use the smiley face for that one to avoid mix-ups.
Okay, let me see what I can use here. There is a chart.
So we add a few more buttons to it as well. Again, we can change the position of the groups by using the arrow keys to the right. The Reset button helps us reset either the selected tab or all the customizations we have made. The last button lets us import or export our customizations by exporting them to a file or importing them from a file. We click on OK and admire our handiwork. Doesn't seem that great though, we'd better reset them. We go back to either of the customization categories and click on Reset All Customizations.
Great, we are back where we started.
Not exactly, we have learned a lot.
Indeed.
It is now time to learn how to select cells and cell ranges.
And those of you who think you know how, don't leave. There's a good chance you may learn something.
So let's start. If we want to select a cell, all we have to do is click on it. Suppose we want to select cell A10. We bring the mouse pointer on cell A10 and click. The cell has been selected. We can certainly select more than one cell. For example, if we click cell B3 and drag our mouse until cell B10, we won't select just one cell, but an entire cell range. The cell range B3 to B10.
Cell ranges form rectangles. We could have also selected this area here, D3 to H3, or that one, D5 to I12.
If we want to select a column, we bring the mouse pointer to the column header, and as soon as it takes the form of a black arrow, we click once. If we want to select more than one column, we hold the mouse button down and drag to the right or to the left.
If we want to select a row, we bring the mouse pointer on the row number and click. In the same way, in order to select more than one rows, we hold the mouse button down and drag downwards or upwards.
But we can also select many non-adjacent cells. First, we select cell B3 by clicking it. Then, we hold the Control key down and click cell B10. So both cells have been now selected. If we hold the Control button down and click cell B15, we will have selected 3 cells. In the same way, we can select lots of cells. Don't forget to hold the Control key down.
We can of course select cell ranges as well. We keep on holding the Control key down and drag. For example, from D6 to D8. Should we want to deselect all these cells and cell ranges, we click any cell without holding the Control key down.
Suppose we want to select two columns, B and D. We click column B, hold the Control key down, and click the column D heading. Now we have selected both columns.
In the same way, if we click column G, it will be selected. We can deselect it by clicking any empty cell.
The same goes with rows too. We select the third row, hold the Control key down, and select the 7th and the 10th rows.
Notice that when you select a cell range like this one, for example, B3 to C7, the first cell we click appears white. This doesn't mean that this cell is not selected though. It is actually selected. This cell is called active. Regardless, a selected cell range is also marked with a borderline.
If we click the point where columns and rows cross, we can also select the whole worksheet with just one move. So we click this point here, and the entire worksheet has been selected.
We can select many worksheets with a couple of clicks as well. Worksheets are displayed at this point here. The Sales workbook is composed of these three worksheets: Sales, Charts, and Sheet 3. Sales worksheet is currently selected. We bring the mouse pointer on Sheet 3 and holding the Control key down, we click once to select it.
Notice that these two sheets have turned white, whereas the chart worksheet that has been selected is still gray.
We can also select all worksheets contained in a workbook. We right-click on any worksheet and then select all sheets. Now all the sheets have turned white.
So we have learned how to select cells in many different ways.
There are others, of course, but I think these are enough for now. In this video, we will see how to insert, delete, and correct data in cells. We will also learn how to use copy, cut, and paste. So let's get started.
An Excel worksheet allows us to type a text like this, or this one displaying months, or that one displaying company names. We can type numbers as well, as we can see here in a cell, or in an entire cell range. We select the cell C10, where the number 34 is displayed. This is a number that we haven't typed.
If you look carefully, you can see a function appearing in the formula bar. We will explain functions in detail later in another video. However, as you can see here, this function returns number 34, corresponding to the three companies' sales for January.
Notice that texts are always aligned to the left side of the cells, whereas numbers are always aligned to the right side of the cells. A date is displayed in this cell here. Dates are also aligned to the right side of the cells because Excel considers them numbers. So, let's see how we can insert data. We navigate to Sheet 3, clicking on it. Then we're going to type a surname in cell C5. We click on the cell and start typing.
As you can see, the text we have typed in cell C5 occupied space in cell D5 as well, even when you click anywhere else on the worksheet. Ignore this. If we want to type the name Stelios in cell D5, we click cell D5 and start typing regardless of the data that are currently displayed in there. Then we click on another cell. We bring the mouse pointer to the line between the headings of the two columns, and holding the left mouse button down, we drag to the right. Both name and surname are now displayed in their respective cells.
Now let's type the date of birth in cell E5. When we want to type a date, we can use the slash symbol as a separator. Let's go back to the sales worksheet. What we'll have to do is correct some mistakes displayed in this worksheet. For example, there's a Y missing from the word January. It currently says January, where it's supposed to say January. We click on its cell once and then on the formula bar once more. The insertion point is now flickering inside the formula bar. We type Y and press Enter. The mistake has now been corrected.
Then there is a missing A from the word marks. So we click the cell once and then here at this point of the formula bar once more to bring the insertion point in the part of the word we need to correct. We type A and press Enter.
If we want to delete the contents of some of the cells, we have to select them and press the delete key once. As we can see, we've deleted the contents only, not the background color of the cells. We undo once by clicking the Undo button at the top of the window. And the cell contents will be displayed again. Now we're going to show another way for deleting the contents of the cells.
From the Home tab, we locate the Editing group of commands and click the Clear command. There are 6 options to choose from. If we want to delete the contents, we click on Clear Contents. If we click the Clear Formats command, we'll delete the blue background, but not the contents of the cells. We undo again. If we want to delete both the contents and the background, then we click on Clear and then Clear All.
We have now deleted both the contents and the background of the cells. Let's undo once to be able to show how we can copy data. As we can see, the names of the months are displayed here, but not here. So we select the months and click the Copy button. We select this cell as a destination of the copied cells and click Paste. The names of the months have now been copied.
The copied cell range remains copied in memory as it is defined by its animated dashed line border. To remove it from memory, we have to hit the Escape key.
The next thing we're going to show is how to move cells. As you can see, the sum is displayed here, whereas it should be displayed here. So we're going to select the cell, click on Cut, and then click into the cell where we want to paste it. And then of course paste it by clicking this button here.
So we saw how we insert and edit data as well as how we can use copy, cut and paste. This wasn't so hard, right?
And we are back.
We hope you found our previous lessons interesting and learned a lot. It is now time to show you how to manage columns and rows. We will change their width and height and show you how to freeze them. So don't worry, no refrigerator or magic skills are required for this kind of freezing.
And we won't stop there. We will learn how to insert, delete or move around worksheets. We will even show you how to split them. But enough talk. Let's start with the action.
The time has come to learn how to manage Excel's rows and columns. The worksheet appearing on our screen here illustrates 3 company sales for January, March, April and May. As you can see, we have obviously forgotten to insert the sales for February. So, we'll have to insert a new empty column between columns C and D for the February sales. Let's see how.
We're going to select column D by clicking its heading. Then right-click and select Insert. The new column will be inserted on the left of the column we have just selected. Now there's an empty column for February's sales.
Also, suppose we want to insert an empty row between the word companies and the names of the companies. So we're going to select the third row by clicking its heading, then right-click and then insert again. The empty row has now been inserted above the third row. If we changed our mind and want to delete column D, we have to click its heading in order to select it, and then right-click onto it and select the delete command.
Let's do the same for the third row too. We click the heading once to select it and right-click onto it and select delete.
Suppose we don't want to show March sales on column D, but we don't want to delete them either. We can select it by clicking the heading D, right-click onto it and select Hide. So now column D has been hidden, but it's still there, it's not deleted. Whenever we want to display it again, we can select columns C and E, which were previously displayed on both sides of column D, and right-click onto it to select Unhide.
The same works for rows as well. Let's hide row 7. We select it, right-click on it, and hide it. If we want to show it again, we select rows 6 and 8, right-click on them, and select Unhide.
This is how you can always hide and unhide rows and columns without deleting the content. That wasn't so hard, right?
The key component of any Excel file is its sheets. That's why we need to learn how to manage them. We will see in this video how to insert, how to delete, how to copy, and how to move Excel worksheets.
Our screen is currently displaying the sales.xlsx workbook. As we've already mentioned, workbooks are composed of worksheets. This specific workbook is composed of the sales, charts, companies, and sheet 3 worksheets. We right-click any of these 4 worksheets and a new window pops up proposing several options. Insert if you want to insert a new worksheet, the 5th one in the existing workbook, delete if we want to delete a workbook, rename, move or copy, or even select all worksheets. So we're going to select Insert. It pops up a new window where we select a worksheet and click OK. The new worksheet has now been inserted on the left of the worksheet that was already selected.
Alternatively, we can click on this small button here with a plus sign. This will add a sheet to the right of our previously selected sheet.
If we right-click on a sheet and select Rename, we can change its name. We just type the name Report and either press Enter or click on any other cell.
If we want to delete it, all we've got to do is right-click on it and select Delete.
A worksheet can also be moved to a new location. The Sales worksheet, for example, is first right now. If we want to, we can move it to the end. Let's see how. On the Sales worksheet, holding the left mouse button down, we drag the pointer to the end.
If we release the left mouse button now, the Sales worksheet will be moved to the end, exactly where the little black triangle is pointing at. If we release it here, the Sales worksheet will be next to last.
We can also create a copy of the worksheet. We right-click on the Sales worksheet and select Move or Copy. We click Create a Copy and OK. We now have the Sales and the Sales 2 worksheets, which are identical.
In the previous example, we have moved the Sales worksheet and then we copied it. Both actions took place in the same workbook, the Sales XLX workbook. However, copying and moving can actually take place between different workbooks as well. Let's say we want to copy the Sales worksheet to a new workbook. We right-click it and select Move or Copy. From here, we select New Book and click on Create a Copy. This way, the Sales worksheet will be copied to a new workbook. We click OK to see it. So, a new workbook named Book 1 has been created, containing the Sales worksheet only. Let's go back to the Sales XLX workbook.
What we're going to do now is move the Charts worksheet to Book 1 workbook. We right-click on the Charts worksheet and click Move or Copy. We select Book 1 and then OK. Be careful. We won't select Create Copy. We just want to move it to a new location, not copy it. There are two worksheets in Book 1 right now, named Charts and Sales. If we navigate to the Sales workbook, we'll see that the Charts worksheet is not there anymore.
In this workbook, we have 4 sheets. The first one shows the sales for 2022 and the other 3 for 2021, 2020 and 2019 respectively. The first one is formatted exactly the way we want it, but the rest of them aren't. Let's see how grouping them can help us format them faster.
First, we have to group the 3 sheets by selecting them using the Ctrl or Shift key. Then we click on any of the selected sheets and start making the necessary changes. The text of the first row is merged, centered, and with a light blue background. The same background is applied on the Sum row. There is an extra row before the Sum, so we delete it. There is also an empty cell in the Sum row. In this cell, there should be the Sum function, which sums all the sales of the month. Let's use the Fill handle to fill the function from the other cells. Finally, we have to add a border to all our cells. We do that from the border button of the ribbon. That's it. We have finished our changes. Now, let's ungroup the sheets.
To ungroup them, we can either right-click on any of them and select Ungroup Sheets, or simply select one of the sheets which doesn't belong on the group. For example, the Sales 2022 sheet. We have only changed this sheet, but if we navigate to the other sheets, we will realize that the changes were being applied to all of the sheets in the group. So all our sheets are now similar to the first one.
This way we can mass format a lot of sheets all at once. And we're not limited to just formatting. We can even add text or even functions inside the group sheets. Very useful, isn't it? Let's see how we can split a worksheet so that we can see two or more parts of it at the same time. This is very useful when we're dealing with very large worksheets and we want to be able to compare two different numbers or data sets.
We select the 15th row and from the View tab of the ribbon we're going to click the Split command. The workbook has been split in two panes, the top and the bottom. Each of them has its own scroll bars.
Notice how the row numbers change in the top part and in the bottom part. Should we want to remove the split panes, then from the View tab, we click the Split command again, which, as we can see, is already selected.
Then we are going to select the column F to split the worksheet in two vertical panes. Select column F and then from the View tab, we locate the window group and click on Split.
This has split our worksheet in two panes. Notice how the column letters change on the left pane and on the right pane of the worksheet. Again, if we want to remove the two panes, we click on Split again.
In the two previous examples, the first time we had selected a row and the second time we had selected a column. That's why our window was split in two panes, the top and the bottom one, or the left and the right one. However, if we click a cell, for example the F11 cell, let's click it here, and from the View tab of the ribbon and the window command group, we click on Split again, then our worksheet will be divided into four panes. This is the first, the second, the third, and the fourth.
Again, notice how the rows and columns change in every single pane. Should we want to remove the split panes? Then, from the View tab, we click on Split again. So, we have learned how to divide our worksheet whenever we want, quickly and easily. When we try to read very large sheets in Excel, it is very likely that we will not be able to figure out which column or row in our table corresponds to the cell we're in, because the first row and the first column, which usually explain the content of the row and column, no longer appear on our screen.
The worksheet displayed on our screen illustrates names of companies and their sales per month. For example, the cell F6 corresponds to May sales effectuated by the company named InfoQ. If, however, we move further to the bottom and right of the worksheet, we cannot tell which month or company the cell J60, for example, corresponds to. It is simply because the row illustrating the names of the months and the column illustrating the name of the companies aren't displayed. Let's see how we can solve this problem.
We select the cell B2 and then from the View tab we locate the window group and from the Freeze Panes command we click the Freeze Panes option. As a result, if we move to the bottom of the worksheet, the row illustrating the names of the months will still be displayed. And if we move to the right, the column illustrating the names of the companies will be displayed also. This way, we can see that the sales in cell J60 correspond to September and to Lenovo company.
Let's go over it once more in detail. By selecting cell B2, let me get there, we froze everything displayed above it, the first row, and everything displayed on the left of it, column A.
Right, so if we have selected cell A2, the only thing we would freeze would be the first row, right?
Exactly, since there's nothing on its left side.
Which means that if we have selected cell C3, we would freeze the first two rows, the ones lying above it, as well as the two columns A and B, the ones lying on its left side.
Correct. To unfreeze all panes, we go to the View tab, we click on Freeze Panes, and then Unfreeze Panes.
Excel makes our lives easier. It gives us two more freezing options. The option to freeze only the first row. From the View tab, we can locate the window group, and from the Freeze Panes command, we click on the corresponding option, Freeze Top Row. Following the same procedure, we have the option to freeze only the first column. Let's see how we can change a column's width and a row's height in an Excel spreadsheet. As we can see, the contents of the cell C2 are not entirely displayed on our screen. Therefore, we'll have to increase the width of column C. We'll hover the mouse pointer between columns C and D until it takes the form of a double arrow. As soon as we see the double arrow, we click once and, holding the left button down, we drag to the right. We've increased the width of column C.
Now, should we want to increase the height of the second row, we'll hover the mouse pointer between rows 2 and 3. As soon as the double arrow appears, we drag to the bottom, holding the left mouse button down. We have increased the height of the second row.
The width of column C can also be adjusted automatically. Let's see how. We hover the mouse pointer again between column C and D, and as soon as we can see the double arrow, we double click. The column will be automatically adjusted to the optimal width.
Also notice that as we increase or decrease the width of a column, there are two numbers appearing above the double arrow. The first number is the number of characters you can type if our font is Calibri and the size is 11 points. The second, in parentheses, is the column width in pixels.
There is one more way to change the width of a column. We go to the Home tab, select the Cells group of commands, and then click Format. It drops down a list of options, and we click Column Width. In here, we can type a specific width in characters. For example, we type number 10 and click OK. The column width will then be adjusted to 10 characters.
The same applies to rows. So let's select the second row and from the format command, click row height. In here we can set the row height to 55 and click OK. The row height has now been increased.
So we have learned how to change the width of a column at the height of a row, something that will help us a lot in making our sheets more readable.
Excel may have a lot of exciting features, but it can do nothing without data. Most of the times, data are imported from another source. The most common type of file these other sources export data into is a text file. So let's see how we can import a lot of data from a simple text file. In the first sheet of our workbook, called Cars, we have just a few cells populated. These cells are 5 records of used cars. The second sheet is completely empty. This is a sheet that is supposed to contain data for car parts.
The whole book is a small sample of what a used car dealership may need. Let's populate the sheets with data. We will start with the second sheet. We go to the Data tab of the ribbon. The first group of buttons is called Get and Transform Data. Here we will find what we need. In this group, we have a lot of buttons and options that will allow us to import data from a lot of different types of sources. From web pages, from databases, from Azure or other online services, and of course from text files. All these commands add the data in Excel's Power Query, and then we can import them in any part of our sheets we wish. Power Query is a powerful Excel tool that shares a lot of the functionality found in database applications. We will focus only in importing data from text files in this video and will ignore the rest of the Power Query's functionality for now.
In the earlier versions of Office, there were different tools to import data which didn't use Power Query. In specific cases, the old way is faster and more efficient to use. This is why Excel gives us the ability to enable these legacy import methods. If you want to experiment with the old ways, you will have to enable them first. To enable the text file legacy import method, you have to go to the File tab, click on Options, and then navigate to the Data Options category. At the bottom, we enable the Legacy Data Import Wizard for text. The new import method can be found in the Get Data drop-down menu of the Data tab. Here it is. We will only show you how the new method works.
It is time to import the data. We want to import the data in the beginning of the sheet. We click on cell A1, and then from the Data tab of the ribbon, we click on the button From Text/CSV. A new window will appear asking us to locate our text file. We find it and select our file and click on Import.
The window that appears is a part of the Power Query interface. It automatically detected text encoding, the delimiter, and the data type of each column. If the automatic detection did not go that well, we have the option to change the encoding and the delimiter. We can also disable the data type detection if we want to define the data types ourselves.
It is now time to import the data to our sheet. In Power Query terminology, this procedure is called loading. The left button does just that. If we just click on it, our data will be loaded on a new sheet, which is not something we want. So we click on the small arrow and select the second option.
A new window appears and asks us how our data should be displayed and where to be placed. We want them to be shown as a table. We could automatically generate a pivot report or a pivot chart for the data, but this is not something we want now. We could also just create a connection to the data, which means that the data will be included in our workbook, but they will not be shown anywhere other except inside of Power Query. We choose the first option, called Table. Next, we choose to place the data on an existing sheet, not a new one, and double check that they will appear in the correct cell. We click on OK, and the data are here.
Now it is time to add the data in our first sheet. There we already have some data. The file containing the data for this sheet is a text file with a CSV extension. Even though these files are text files, they have a structure that allows them to be opened using Excel. So, if we double-click on the file, Excel opens and shows us the new rows of data. There are a lot of ways to import them into our original sheet. If we use the Power Query method we have just previously used, we will run into some issues. First, the data don't have a heading row, which means we will have to add it before importing.
Then we will have to import the already existing data in Power Query in order to be able to append the new data to the old one. This adds a lot of steps, making the process less efficient. We could use the legacy method, which bypasses Power Query altogether and can import data without their headings. But in this case, there is an even easier solution. We select all the data from the CSV Excel sheet and copy them. We then go to our original workbook in cell A7 and just click on Paste. The new data are here. They have been added to the original table following its formatting.
Power Query is very powerful, but if you don't plan to use its feature set in your workbook, be open in using other, faster ways to import data in your sheets.
Most of the times, the Excel sheets you will need to work on will be very large, so finding a cell that contains a specific number or text will not be easy. However, the Find and Replace tools provided by Excel can help us a lot. Let's see how.
From the Home tab, we navigate to the Edit group and click the Find and Select command. Then we click on Find. It pops up a new dialog box where we're going to type the number 90, for example. Then we click the Find Next button and the number has been found. It's this one here.
We'll click the Find Next button once more and you can see there isn't any other instance of number 90 in the worksheet, since the first number remains selected. We click on the Close button to close the window.
The next feature we're going to see is how we can replace a word with another one. Let's say we want to replace the word sum with the word total. From the Home tab, we navigate to the Edit group of commands and click Find and Select. Then, we click the Replace option and type the word sum in the Find What field. We type the text total in the Replace With field. And then we click Find Next. The word sum has been found.
In order to replace it with the text total, we click the Replace button once. Excel immediately finds the next display of the word. If we want to replace this one also, we click on Replace once more. Then, if we want to close the window, we click the Close button.
Find and Replace are the Excel tools that you will probably use more than any other.
They have saved me countless times.
There are various types of Excel views. Let's see them. Our screen is displaying a worksheet illustrating sales from the year 2019, as we can see in this yellow cell. They are organized per month: January, February, March, etc. up to December, for certain companies. If we move to the right a little, we'll be able to see sales for the year 2020 in blue and for the year 2021 in green. Excel has three views, which we can see if we go to the View tab of the ribbon. That's Normal, Page Break Preview, and Page Layout View.
There are the custom views as well, but for those we will need a dedicated video.
What we usually work with is the Normal View. Now let's see the Page Break Preview. Our document immediately displays several numbered pages, like these ones here, page 1 and page 3. And if we bring the mouse pointer further down, we'll be able to see page 2 and page 4.
You may also have noticed some blue vertical and horizontal lines. If we change the document zoom, we'll be able to see that this is the first page, this is the second page, this is the third, this is the fourth, and this is the eighth. This means that all data included between these two blue lines will be printed on the first page of the document. These ones will be printed on the second, and so on. We can also observe that the 2019 data, the ones displayed in yellow background, will be partially printed on the first page, and the rest of them on the third one, and one column on the fifth.
If we want all of them to be printed on the first page, we'll have to move the page break, this blue line here, to the right. We'll then hold the left mouse button down and drag to the right. This way, all the 2019 data, the ones in yellow background, will be printed on the first page. So let's do the same with the 2020 data, the ones in the blue background. We'll move the blue line to the left a little. This way, each year's data, 2019, 2020 and 2021, will be printed on a separate page.
Let's take a look at the last view now, the page layout view. In this view, our sheet is divided into pages as before. The difference is that this time there are no blue lines to separate our pages. The pages now look exactly as they would if they were printed on paper. In this view, we do not have the ability to move the page break lines as before, but we have the ability to add or edit headers and footers.
We click on the top of the sheet and see that three different areas are activated to add headers. One at the left of the page, one in the center, and one at the right of the page. Let's type the text Sales on the left side.
Similarly, if we go to the bottom of our sheet, the three corresponding areas of the footer of our sheet will appear. We select the center area of the footer. A new tab has been activated in our ribbon that gives us several options for managing the headers and footers of our sheet. We click on the button with a page number name. This will display in the middle of the footer the page number for each page of our sheet.
While all of this has not been difficult, Understanding all of the features of the various Excel spreadsheets is crucial to understanding how our sheets will be printed.
We have created a very beautiful, detailed and informational worksheet, and now it's time to share it with the world. Most of the times you will be asked to either print or send it as a PDF document. This requires some more work from you.
First, you will have to see how your sheet will look in printed form. This is where the different Worksheets views will come in handy. After that, you will have to set up the page and create headers and footers.
And then it is time to print it. You will learn to navigate through all the different printing options and then print or export your sheets. In some cases, before printing, you may need to take some feedback from your colleagues, so inserting explanatory comments in your cells will be incredibly handy.
As we reach the end of the course, we will talk about general application settings and how to spell check your workbooks. Make sure you check for spelling mistakes before sending it to your boss though.
Before printing a worksheet, we must make sure that it looks correct in printed form. To achieve this, we need to know how to set up our pages. Our screen is currently displaying the 2019 sales for some companies. Let's navigate to the print preview.
To see the print preview, we go to the File tab and click on Print. On the right of our screen, we see the preview. At the bottom left of the preview, we can see the number of pages that will be printed.
We notice that 2 pages are required to print the data. This is because the page orientation is vertical, portrait, and not horizontal, landscape. Therefore, the bottom part of the page is empty. So, if we change the page orientation from portrait to landscape, we will need only 1 page to print all data and not 2. Now, let's go back to normal view. From the Page Layout tab, we locate the Page Setup group and click this icon here to open the dialog box for this specific group. It pops up a new window from where we can select the landscape orientation, and then we go back to Print Preview to see the result. As we can see, all data have now been displayed in 1 page and the page orientation is horizontal instead of vertical.
We can change the page orientation from inside the print preview window if we want by clicking here, Portrait Orientation, and then back to Landscape Orientation. We can also change the orientation from the ribbon. We go back, select the Page Layout tab if it is not already selected, and from this selection button we select the orientation we want, portrait or landscape.
Now let's go to the next sheet. This data correspond to amounts paid for energy, telephone and water supplies. If we navigate to the print preview, we'll be able to see that our data actually cover a very small part of the page. So, if we want to, we can zoom in the data before we print them. Let's see how. From the Page Layout tab, we locate the Page Setup group and click this button here to open the dialog box of this specific group. Then we change the scale percentage from 100% to 200% for example. If we go to the print preview, we can see that our data have now covered a larger part of the page. That's because we've changed the scale.
We can change the setting if we want to from both the print preview and the ribbon. In the print preview, we click on the last group of options that now writes custom scale because we have applied a custom scale of 200%. There we have several options that we will see later. However, if we click on the last one, this one here, the same window that we opened before will open and we will be able to change the scale to any number we want. For example, 250. there is also a scale field on the ribbon. In the Page Layout tab and in the Scale to Fit group of commands, there is this field here, which is called Scale. By changing it, we change the scale on our sheet. We set it back to 200.
Let's go to the next sheet. Once more, our screen is displaying 2019 and 2020 sales for various companies. If we click the print preview, we'll be able to see that this data will be printed on 9 pages. We can set Excel to print all this data on one page only. It goes without saying that in this case, data will be scaled down. Let's see how. From the Page Layout tab, we locate the Page Setup group and click this button here to open the dialog box window for this group. The next thing we do is select Fit Adjust to 1 page wide and 1 page tall. If we click the print preview again, we can see that all data will be printed on 1 page only.
Again, we can also change this setting in the print preview. In the same group of options as before, we have the option to fit a sheet on 1 page, which is exactly what we did from the page configuration window. This is why this option is already selected. We have 2 additional options here. Fit all columns on 1 page and fit all the rows in 1 page. We choose this one. As you can see, all rows are now fitted in 1 page. If we go back to the ribbon, in the Page Layout tab and in the Scale to Fit group of options, we can see 2 option boxes here. One adjusts the print width of our sheet and the other its height. Because we chose all the lines to fit on 1 page, the height of our sheet is 1 page and its width is automatically calculated. Let's reverse these choices. Adjust the width to 1 page and the height to automatic. If we go back to the print preview, we will see that now the option to fit all columns on 1 page is selected, which means that our sheet has now a width of 1 page and the height is calculated automatic. This is why we have 2 pages now of data.
From the print preview, we can also adjust the paper size as well as open the page setup window from the corresponding link. In this window, we can adjust the paper size as well as the print quality.
The paper size can also be changed from the ribbon. We go back to our main view, to the Page Layout tab. We can see an icon that says Size. If we click on it, we select the size we want.
But that's enough for now. We've learned how to configure our page size, orientation and scale. Next, we will see how to create page headers and footers.
A little reminder here, from the View tab of the ribbon, we can switch to the Page Layout view so that our headers and footers appear on our screen.
A header is the top part of a page, and a footer is the bottom part of the page. Headers and footers may display several information, such as the date of creating the worksheet, the name of the worksheet, or the name of the book. Let's see how. From the Page Layout tab, we locate the Page Setup group. By clicking this icon here, we pick up the Header and Footer tab, from where we can set the data that will be printed in the header and footer of the page. There are 2 ways to do so. The first way is to use the drop-down box. As we can see here, this box allows us to determine the data that will be displayed in the header
And this one allows us to set the data that will be displayed in the footer. This is the first way. The second way is using the custom header and custom footer buttons. So, we're going to use the first way for the header. Selecting this option here, we can select to print the name of the worksheet, which is Cornelius. Can you tell us the name?
Large amounts.
Large amounts. Great.
Let me remind you, the name of the worksheet is displayed right here.
Yes, but it comes with all dates. We can also select to print the name of the workbook, headers, and footers.
As we have already mentioned, the name of the workbook is displayed at this point here, at the top of the worksheet.
We decide to show the name of the book, and it is displayed at the center of the header. As for the footer, we're going to follow the second way, using the custom footer button. So, in this area here, we can type some text on the left-hand side of the footer, at the center, or on the right-hand side of it. Let's say you want to display your name on the left-hand side of the footer, and the name of the workbook at the center of it. If we click anywhere in the central area of the footer, we can see that the insertion point is flickering at this point here. Then we'll have to use one of these buttons provided here. So if we click this button, the number of the current page will be inserted here. As for the date and time, we'll have to use these two buttons here. If we want to display the name of the workbook, we'll have to use this button. And for the name of the worksheet, we'll use this one here. We click it.
We would expect the name of the worksheet, large amounts, to be displayed at this point here, but it doesn't. The word tab appears enclosed in brackets instead. Excel will replace this text dynamically and show the name of our sheet. So even if we change the name of the sheet, the footer will be refreshed automatically. If we click on the OK button, we will see the name of the sheet appear in the center of the footer. Here we can see what's selected to be shown on the header, and here the footer.
So if we click the Print Preview button, we'll be able to see the name of the workbook displayed at the center of the header. Our name will be displayed on the left-hand side of the footer, and the name of the worksheet will be printed at the center of it. Our screen is now displaying the worksheet as it will be printed. This is the left margin, this is the bottom margin, the right one, and the top one. Should we want to adjust margins, we'll have to navigate to the Page Layout dialog box again. We then pick up the Margins tab, and from this point here, we adjust the top margin at 3 inches, for example, the left and right ones at 2.4 inches, and the bottom one at 3 inches. So the margins have changed as shown in the page layout view, but also in the print preview.
When we are in the page layout view, which we are now, we can edit the headers and footers from the ribbon. Let's click on the left part of the header. A new tab on the ribbon has been activated and gives us the same options we saw before. Page numbers, number of pages, date, time, file path, file name, sheet name, and a picture in case we want to put, for example, a logo in our header. With this button here, we can quickly go to the footer. And with this one, we go back to the header.
So that's it. We've learned how to insert headers and footers in our sheets and how to change the margins of our pages.
In this lesson, we will look at some more options on the Page Layout tab that will help us set up our sheets for printing. Our screen is displaying 2019 and 2020 sales organized by company and month. If we navigate to the print preview, we can see that all this data will be printed in 6 pages. We're looking at the first page now.
As you can see, companies, months, and year will be printed in the first page. So this value here corresponds to Mercedes sales on May 2019. Let's go to the next page. We can see that neither months nor year is displayed. We cannot see them. We can only guess them. The fifth page in particular displays neither company names, nor months, nor year.
Well, let's see how we can fix this problem. From the Page Layout tab, we locate the Page Setup group and click this button here to open the dialog box. We then navigate to the Sheet tab. The field here allows us to select the rows that will be repeated at the top of each page. The one here allows us to select the columns that will be repeated on the left of it. So if we click this button here, we can select the rows we're interested in. The first, the second, and the third one. We're going to click this button here to select columns. Let's select the first column.
If we want to see the result, we navigate to the print preview. So the first page has now displayed data the way we want them. Company names on the left-hand side, months and year on the top. The second page will also display company names and months and year. The same goes for the rest of the pages. This way, repeating certain rows to the top and certain columns to the left of each page, we will be able to know, without any guessing, which company, month, and year correspond to a certain sale value.
Excel helps us insert our data by displaying column headings A, B, C, D, and so on, row headings 1, 2, 3, and so on, as well as grid lines. However, if we navigate to the print preview, we'll be able to see that neither column headings, nor row headings, nor grid lines are displayed. Now, let's see how we can change it. From the Page Layout tab, we navigate to the Page Setup dialog box again, and we then pick up the Sheet tab and check grid lines and row and column heading checkboxes. Then, if we click the print preview, we'll be able to see that column and row headings as well as grid lines have now been displayed on our worksheet.
Alternatively, we can make the same adjustment from the ribbon. In the Page Layout tab and the Command Group Sheet Options, we can see 4 checkboxes. 2 are for grid rows and 2 are for column and row headings. With these 2, we hide or show the grid lines either for the normal view of the worksheet, here, or for the print preview. With the other 2, we hide or show the headings either for the normal view or the print preview. Now everything is activated. Clicking here hides the grid lines in normal view, but because print remains selected, the grid line continues to appear when we print the sheet. Let's do the opposite for the headings. They appear in normal view, but we will hide them in print preview. If we go back to print preview, we will see that the headings are hidden.
In this lesson, we have seen how to print specific rows and columns on each page, as well as how to show the grid lines and headings during printing. We will continue our lessons and learn about print areas. There are many times when we don't need to print the entire worksheet, but only a certain area of it. Let's select, for example, this area here, and from the Page Layout tab, click Print Area. Then we click Set Print Area. Now if we navigate to the Print Preview, we'll be able to see that only this area will be printed.
In case we have changed our mind to want to print the entire worksheet, we have to clear this print area first. So we are going back to the Page Layout tab, we select the Print Area and Clear Print Area. If we navigate to the Print Preview now, we will be able to see that Excel will print the entire worksheet.
Next, we will explain some more print options. Our screen is currently displaying the Large Amounts worksheet. If we hold the Control key down and click the Students worksheet, we'll select both these two worksheets. You may observe that the selected worksheets are displayed in white background with bold, underlined font, whereas the non-selected ones are displayed in gray background with normal font. We click the File tab and then the Print command. There we have the following options. This point here allows us to select the printer we want to print to. And this area here allows us to select the pages we want to print. If we want to print specific pages, we click this point here and define the number of these pages. We have selected to print the first, the second, and the third page. We can also select the entire workbook, that's all 5 worksheets if we want to. We can also select to print the selected worksheets only. Let me remind you that we've already selected the Large Amounts and Students worksheets. Then we set the number of copies to 2, for example. If we select Collated, our worksheets will be printed in the following way. All pages will be printed once, and then all of them will be printed once again. If we select Uncollated, the first page will be printed twice, the second one will be printed twice, and the third one will also be printed twice, because we've set the number of copies to 2. This concludes our lesson in printing. We've learned how to define and delete a print area and reviewed all the other print options that Excel gives us.
When we plan to share a document with someone else, it is better to make sure that there are no information inside it that shouldn't be shared. This could be personal notes or comments from our colleagues. This is why Microsoft offers us with a tool to simplify the process. We go to the File menu and select Info.
There we will find the button Check for Issues. If we click on it, 3 options appear. The third one is to check for features that are not supported in the previous version of Excel, which could be very useful if we plan to share our workbook with someone who we know is using a very old version of Excel. If we click on it, our report will tell us of the issues it found. For the current sheet, there are some minor design issues, which means we can safely ignore them.
If we click on the Copy to New Sheet button, a new sheet will be created containing the same report. If we go back to the File, Info, we can also check for accessibility issues, which is the second option. The accessibility pane opens with a report of all accessibility issues it found. The issue it found is that the name of the second sheet is using the default name, which can make navigation through the workbook more difficult for people with disabilities.
This is the sheet with a compatibility report. We don't need it, so we can delete it. The accessibility pane is now showing that there are no accessibility issues on our workbook. Great! If we go back to the File Info and the Check for Issues button, there is one more option, the first one.
We have kept the best for last. This option inspects the document for data that exists in the workbook and are not visible, which means we may have forgotten to remove them. It also searches for personal information and comments. When we click the Inspect Document option, the Document Inspector window appears. Here we can choose what we want it to search for. We make sure that everything is selected and click on Inspect. And it instantly gives us the inspection results.
It found that we have left comments and some personal information in the workbook. We remove all of them by clicking the buttons that appeared in the report. Scrolling down, you can see that we had hidden worksheets, rows and columns. These could contain sensitive data that are not for sharing. If we are sure they need to be deleted, we remove all of them also.
We can click on Reinspect, just make sure we have cleared everything out. Our workbook is now ready to be shared.
There is the option to add hyperlinks to cells, cell areas, charts, or any kind of object in your sheets. This can make your workbook more interactive. In the current sheet, we can see that the Dell company is shown in a blue underlined color. This is because it is a hyperlink to Dell's home site.
If we hover our mouse to the cell, we can see the link that is pointed to it. If we want to go to that link, all we have to do is click the cell. If we just want to select the cell without navigating to the link, then we have to click and hold the mouse button on the cell for a while until it is selected. It needs milliseconds. Suppose we want to add the link to HP's site as well. We click on the cell and go to the Insert tab of the ribbon. There we click on the Link button. The first option on the left is Existing File or Web Page. We can either select one file or one of our recent browsed pages or recent access files. We know the address of the site, so we just type it in the appropriate field. At the top of the window, we can change the text of the cell if we want. We don't. If we click the button on the right, labeled Screen Tip, we can type a text to be displayed when we hover the mouse over the cell. This will replace the web address we will otherwise see as Screen Tip. Let's add here HP main site. We click on OK.
Now, if we hover over Dell's cell, we can see the web address, but if we hover over HP's cell, we see the screen tip we have just added.
There are other kinds of links we can insert to our cells. Let's say we want to add a link to our other sheet called Charts. We will add this link to cell More Charts. We click on the cell, we choose the Insert tab and the Link button and select Place in this document from the categories on the left. Then, at the box on the right, we select the Sheets charts. We can set a specific cell we want to jump to if we want, but for this example, cell A1 is what we want. So we click on OK.
Now, when you click on the cell, it will send us automatically to the Charts sheet to cell A1. In this sheet, we have already included one cell with the text Email me for support, the one right here. We want to add a link to that cell that will open the default mail client of the user and let them write an email that will be sent to our mail address. This can help a lot if you plan to sell your workbooks and want to offer some kind of support to the end users.
We select the cell and click on Insert Link. We select the email address from the left of the window. We type our email address. We type a subject. It's better to type something very descriptive here. It will help you differentiate the different support requests if you have had a lot of different workbooks for sale. For example, support request for the workbook with the 3 charts. And we click OK.
The moment we click on that cell, our default mail client launches. We can then add a description of the issue we have and set it.
And this concludes this lesson. Remember not to add too many hyperlinks because it can be frustrating to have your browser open with every accidental click on the cells. Next, we're going to see how to insert symbols, such as this one here, images, and comments. We double-click cell C9, and we can see that the insertion point flickers next to the text. This is where our symbol will be inserted. So from the Insert tab, we click Symbol, and this pops up a new window from where we can select a font, for example, Arial, and then we select the symbol of our choice. Then we click the Insert button. The symbol has been displayed where the insertion point was. Then we click Close.
The Symbols window also displays the symbols we have used recently so that we do not have to search for them every time. If we want to add the same symbol to the cell below, we double-click on the cell, go to Insert Symbol, and as you can see, the symbol we have used previously has appeared in this list. All you have to do is select it and click on Insert, and then Close.
Our next example will be how to insert an image stored in our PC. So from the Insert tab, we click Pictures and then this device. At this point, we're going to select the storage location, and as soon as we find the image, we select it and click Insert. So our image has now been displayed on the worksheet.
Let me resize it to show it better.
It's quite big.
Yes. There. In the options that appear when you click on the Insert and Pictures button, there are 2 more image sources. The Online Pictures option. Here you can search for images through Microsoft Bing search engine or log into our OneDrive account and use images from there. But the most interesting option is the option that allows us to use Microsoft stock images. They are divided into these categories and can be used in all Office applications. Let's choose this gentleman here. We select him and click on Insert. And there he is.
Very interesting indeed. So our next example is how to insert a comment in a cell. So we select, for example, cell E5, and from the Review tab, we click New Comment. We can now type our comment at this point where the insertion point is flickering. The name displayed in here is the name of the user of the application. As soon as we type our text, all we have to do is click anywhere on the worksheet. The comment is now displayed in the form of a little red triangle. If we hover the mouse pointer on it, we can read the comment. And if we want to delete it, we right-click on the cell and select Delete Comment. Let's undo this for a moment. If we want to change the text, we select Edit Comment. From the Home tab and the Clear command, we can delete the comments. We can click the Clear Comments option here. So, we have learned how to insert symbols and images that will help us a lot in making our sheets more elegant. We have also learned about the comments that can help us when our sheets will be used by more people. In this lesson, we have put together some interesting Excel features that do not justify a video on their own. We will look at the properties of our workbook, we will explore a couple of useful Excel settings, we will talk about spell checking, but also for the Excel help system.
Our screen is currently displaying the Sales Workbook. From the File tab, we select Info, Properties, and Advanced Properties. This dialog window allows us to change some properties of the worksheet. We can type a title, a subject, an author, and etc.
Now, let's take a look at the settings. Suppose that we click on Options. There we can change the username. It has now been set to Test for You. And I'm gonna change it to Anita and click OK.
We can access Excel spell checking from the Review tab. Then we click the spelling button from the Proofing command group. The first word with a spelling mistake located by Excel is the word literature. Excel proposes the following solutions. We select the correct one and we click Change. This way, the word literature, which was spelled incorrectly, will be replaced by the correct one. If we click the Change All button, every time Excel locates the word literature with this spelling, it will replace it with a selected word. The next word with a spelling mistake is the word mathematics. So we're going to select the correct spelling of the word mathematics and click Change. The word has now been replaced with the correct one.
Excel will automatically move to the next word with a spelling mistake. If we want to leave it as it is, we click the Ignore Once button. If we want Excel to ignore the word SUME always, we click the Ignore All button. We can also click the Add to Dictionary option if we want to. Therefore, the next time Excel locates this word, it will not consider it as a mistake. We're going to select Ignore Once. As soon as the spelling check is completed, Excel will display this dialog box.
The next feature we are going to explain is the Microsoft Excel Help. We click on the Help tab and in the icon with the same name. It pops up a new pane and we type the keyword in this area here. Suppose we need help about the sum function. We type the word sum and press the Enter key. Then several results will be displayed in the result area. We're going to select the one related to the function. Another way of receiving help from Excel is the following one. We navigate, for example, to the Format Cells dialog box. Home, Format Cells. And here we can see there is a question mark on the title bar of the window. If we click on this question mark, a page appears in our browser showing a help topic for this dialog box.
Finally, another way to get help is the search box in the title bar of the application. We type sum again. We see that it gives us many options. Either simply enter the function in the cell we're in, or some other sum-related actions, or open the help as we did before.
Now we're going to discuss a very useful feature of Excel. Suppose we want to know the sum of numbers included within this cell range. We could certainly use a formula or a function. Instead, all we have to do is look at the status bar. Excel returns the sum. That's 61.
In addition to the sum, if we right-click, we can see the minimum, the lowest value, which corresponds to 10, as we can very easily see for ourselves. But if we select a very large area, Excel quickly displays the new minimum value.
With a right-click, we can choose to show us the maximum value if we want, which for the selected cell area is 1495, or the average of the selected area, or the count.
And somewhere here, this lesson ends. We have learned many interesting features of Excel, don't you agree?
You should feel more at ease with Excel by now. You know how to create basic Excel sheets, but there's something missing. They're very plain and simple, aren't they? So it's time to put some style into our work.
To do that, we will need to know how to format our cells. From a simple change in the font face or size of the cells up to customizing their borders and shading. We will also learn how to align and wrap the text in our cells. And to make our sheets more structured, we will show you how to merge your cells when it is needed.
We will continue with cell number formatting, which will immediately make your sheets more user-friendly and readable. And we will end this section learning how to copy the formatting of one cell to another.
That's a lot of work. We'd better get on with it.
Next, we're going to see how to format data appearing on a worksheet, apply borders, shading, etc. We're going to select the revenue and expenses cell, and from the Home tab, we locate the cells group and click the Format command. Then we click the Format Cells options, and this pops up the Format Cell dialog box. We pick up the Font tab and select the font we prefer, for example, Verdana. (12 and bold. We can also select a font color, for example, blue. And effects. That's subscript, superscript, let's keep it for the moment. Then we click OK. And here's the result.
Then we select the revenue cell and go to the Format Cells option. We click on the Fill tab to select a background color, let's say green. Here is the result. Notice this, in normal view, the grid lines are displayed. If we switch to the Print Preview by clicking first on the Files tab and then on Print, we can see that the grid lines won't be printed. We can print them if we want, but we're going to see how on another video.
For the time being though, we're going to apply borders to the cell that we want to print. So we're going to select this area here and navigate to the Format Cells option again. Then we navigate to the Borders tab, we select the style, we select the color, but we won't click OK yet.
If we select Outline, the style and the color we've selected will be displayed in this area here. Now we can click OK to see the result. So, here it is.
We can apply a different color on every side of the border. Let's see how. We select the area we want to format and navigate to the Format Cells option. On the Border tab, we select a style and a color. We won't click the Outline button though, but these icons here. From this icon here, we can change the top border. A blue line will then be displayed. We select another style and another color. We select the bottom border. Then we select another style again and another color. And we click on the left border line. Finally, we select another style and one more color, and we click on the right border line. Then we click on OK, and here is the result. All these formatting options are available in the ribbon as well. Here in the font section, we can change the font, the size of the font, the color of the font, the fill color of the cell, the borders, set it to bold, italic, underline, and we can easily change the size of the cell, increase it or decrease it if we want.
We have learned about font formatting, cell filling and their outlines, which is enough for now. Cell formatting in Excel is a big subject and will require more than one videos. Let's find out how to merge, align and rotate cell content. Let's take cell B3, which displays the text Sales. We would most probably want to display this at the center of the B3 to E3 cell range that corresponds to sales appearing just underneath it. So we'll have to select this area here, and from the Home tab we locate the Cells group, we click Format and then Format Cells. We select Alignment, then Merge Cells and align text horizontally at the center. We click OK and the four cells B3, C3, D3 and E3 will be merged into one cell. Also, the text will be displayed at the center of the cell. This feature is very common when using Excel, that's why there's a button on the ribbon producing the same result. Let's undo our last action and see how we can use this button. We select the B3 to E3 cell range again and simply click this button here. This way, cells have been merged and the text has been centered.
A small interruption. There are other ways to get to the Format Cells window with fewer clicks. The first is to right-click on a cell area of cells. For example, I select cell A1, right-click on it, and in the list of options that appear, I select Format Cells. The other way is to click on these small arrows at the bottom right of the command groups on the main tab. Here, here, here. Clicking on the Font Group arrow opens Format Cells on the Font tab. Clicking on the Alignment Group arrow opens the Format Cells window on the Alignment tab. Respectively, the Number Group arrow opens the Format Cells on the Number tab.
The next thing we're going to see is how to align cell text. Let's take a cell B4, which displays number 2018. Because of its considerable height and width, we can align 2018 to a different position. For the moment, it is aligned to the bottom and right. Let's try to align it to the top left. Having selected the cell, we navigate to the Format Cell options, and from the Alignment tab, we set horizontal alignment to the left, vertical alignment to the top, and click OK. Our text has been aligned to the top left. Now let's take 2019 and align it horizontally and vertically at the center. We select the cell, we navigate to the Format Cells command and select horizontal alignment at the center and vertical alignment at the center again and click OK. The text has now been aligned horizontally and vertically at the center.
Another small interruption, Excel allows us to change the alignment of cell contents in an even easier way, with these 6 buttons in the Alignment command group. In the top triad, we choose the vertical alignment, and in the lower triad, the horizontal alignment. So we can change the 2019 alignment to left and bottom with just 2 clicks. Left and bottom.
Good to know. As for the 2020, we're going to rotate it. We select the text 2020 and go to Format Cells and to the Alignment tab. We bring the mouse pointer to the red rhombus here and holding the left mouse button down, we drag upwards or downwards. We've just selected the 45-degree rotation, as we can see in here. We could also set the degrees we want by using the arrows or this text field. Now we're at minus 38 degrees. So we click OK and the text will be displayed like this. Then we're going to display the text 2021 vertically. We select the cell, we navigate to Format Cells, click this point here and then OK. We can also increase the row height a little and 2021 is written vertically.
There is a button on the ribbon for rotation as well. It allows us to rotate the contents to the 5 most popular settings. It's this button here. Counterclockwise, which means 45 degrees. Clockwise, which means minus 45 degrees. Vertical text. Rotate text up. Rotate text down. The last button displays the cell formatting window.
Then we navigate to the Courses worksheet. We select cell D5 that displays the text Price per hour. Now we're going to see how we can wrap this text. We navigate to Format Cells and from the Alignment tab we select Wrap Text and click OK. It seems like nothing has changed. However, if we decrease the column width and increase the row height, the text will take this form. In this case, we say that the text has been wrapped. There is also a dedicated button in the ribbon for wrapping text. It is now pressed since our cell is wrapped. If we click it, the wrapping is disabled. If we click it once again, the wrapping is back on.
But there is also another way to wrap text, so that we don't need to navigate to the Format Cells window over and over again. We can use the Alt key.
We're going to select the cell, type our text, and at the point where we want to change row, we hold the left Alt key down and press Enter. The insertion point will then move underneath. We type the next word, and holding the left Alt key down, we press Enter, and then start typing again the last word. As soon as we've completed typing the text, we just press Enter. Our text will then be wrapped again, just as in cell D5.
Of course, in this case, our text will remain wrapped even if the width of the column increases. While in the D cell, if we increase the width of the column, the text is not wrapped anymore.
So we have learned how to align, rotate, and also wrap the contents of the cell. Formatting cells is quite a time-consuming process, but Excel has a tool that can help us drastically reduce the time we spend formatting. It allows us to copy and reuse a formatting we've used in the past. Let's see how. As we've already mentioned, we can change the background color shading of a specific area. So let's select the Months area, and from the Home tab, navigate to Format Cells and click the Fill tab. We select the color of our choice and then click OK. Suppose that we want to display the companies using the formatting that is used on the above table. We're going to click on one of them and then click the Format Painter button. We click on the first company and holding the left mouse button down, we drag to the last company. If we release the mouse button, the area will be formatted and will look like the area of the above companies. Let's do the same with the Values area. We click anywhere on the Values area and then click the Format Painter. Then we click the cell that displays the value 5 and holding the left mouse button down, we drag downwards to the right down to the cell that displays the value 21. If we release the mouse button, we can see that our area has been formatted and looks like the area here. In order to remove the background color from a certain area, we'll have to select it first and then from the Format Cells option, pick up the Fill tab and select No Color. If we click OK, we can see that the background color has been removed.
Alternatively, you can use the Fill Color button in the Font command group of the ribbon. Let's undo the change. The cells are selected, and now we click on the small arrow next to the Fill Color button and select No Fill. The shading of the cells has been removed, but the border lines haven't.
If we want to remove both the background color shading and the borders, we select this area here. From the Editing group, we select Clear and then Clear Formats. We've removed both shading and borders from the selected area.
Alternatively, let's undo. We can remove the borders using the Border button of the Font command group. We click the arrow next to the Border button on the Font command group, and a list of options is displayed. We click on No Border, and the borders have disappeared.
So today, in addition to learning how to use the Format Painter, we have also learned how to remove the fill and the borders of the cells. Let's continue with formatting. We will learn how to format numbers in Excel. Our screen is currently displaying several numbers. The number displayed in the cell has 2 decimal places and is preceded by the dollar symbol. The number displayed in this cell here has 4 decimal places and a comma, which is the thousand separator. It's $1,230. Let's see how we can reduce the number of decimal places. We select the cells, and from the Home tab, we navigate to the Format Cells option. Then we pick up the Number tab and the Number category. Here we can select the number of decimal places. Let's select 2. We can see the result in here. Then we can use the thousand separator if we want to. If we deselect it and click OK, this area will display numbers with 2 decimal places without the thousand separator.
We can also use the currency symbol, which is the dollar symbol, if we want to. Let's see how. Having selected this cell area, we navigate to the Format Cells, pick up the Number tab, and then Currency. Here we can select the symbol we want. We select the dollar symbol. From here, we can set the number of decimal places. We're going to leave them as they are, 2. Then we click OK. Numbers are now displayed with 2 decimal places and are preceded by the dollar symbol.
Next, we're going to navigate to the Percentages worksheet. This worksheet displays the sales increase percentage between 2020 and 2021 for each company. We could display these numbers as percentages. Let's see how. We select the cell area and navigate to the Format Cells option. If we click the Number tab and then Percentage, we can apply the percentage format, which can be previewed in the sample area here. We're going to leave the 2 decimal places as they are and click OK. Numbers will then be displayed in percentage format.
Then we navigate to the Alignment worksheet to format the date appearing in cell C13. Select the cell and navigate to the Format Cells option. From the Number tab, we select the Date category, and then we select a type, the way we want to display our date. If we click here, the result would be like this. If we click here, the result would be like this, displaying the month and the day. We can also display the month written in full like here. In this area here, we can actually preview the date as it will be displayed on our document if we click OK. We click on OK, resize the cell, and here is our date. Number formatting can also change from this area of the ribbon. We can set the type of the number. We can set, if we want, the currency, set it as percentage, enable or disable the thousand separator, and increase or decrease the decimal places.
Formatting numbers is a huge subject in Excel. We have only learned the basics of formatting numbers as percentages, currencies, and dates.
The ability of Excel to format its data based on specific conditions is one of its most used features. In earlier versions of Excel, the process was rather hard, but now things have gotten a lot easier.
Microsoft has divided their easy-to-apply conditional formatting rules to 5 distinct categories: To use them, we have to go to the Home tab of the ribbon and to the Styles group of commands. There, we click on the Conditional Formatting drop-down command.
Here you can see the 5 rule categories. Highlight cell rules, top-bottom rules, data bars, color scales, and icon sets.
Let's start to see which rules each category contains. We select the values in the Amount column and navigate to the first Conditional Formatting category. We select the Greater Than rule. A new window appears, which gives us two options. In the left box, we have to fill the value, which all the other selected cells will be compared to. If the value in the cells is greater than, but not equal, to the value we type inside this box, then they will be formatted with the style we will select in the right drop-down menu. There is already a value inserted in the text box and the cell rate is already formatted accordingly to help us preview the results. Instead of just typing a value, we can select a cell which contains the required one. For example, we want to format all sales that are greater than Mr. Rand's sales in December. We could just type 110, but instead we will select the cell C13.
Now it's time to select the formatting. There are 6 predefined styles, these ones here. If none of them suits our needs, we can create our own custom format. We will do just that. We click on Custom Format.
The familiar Format Cell window will appear. We choose a blue and bold font and set the background fill to yellow. We click on OK and we can preview what the results will be if we click on OK again. We're happy with the results, so we click on OK.
Let's go back to the rules list. We have talked about greater than, less than, between, and equal to work in exactly the same way. The less than rule will format only those cells that are less than the comparison value. The between rule will format the cells between two values. And the equal to rule will format the cells that are equal to the comparison value we will set.
You could rightfully think that these rules are only valid for numbers. Well, they aren't. Let's select all the months and navigate to the greater than rule. Conditional formatting, highlight cell rules, and greater than. We select A9 as the comparison value, the month August. We can see in the automatic preview that all the months which are alphabetically after the word August are highlighted. So these comparison rules work for text as well. We don't want to format our months for now, so we click on Cancel.
We keep the months selected and go back to our rules. The next rule is the rule Text that contains. Its function is self-explanatory. It formats all the text that contain the text we will enter on the left box. So if we type the word Ember, the months September, November and December will be highlighted.
Keep in mind that although this rule is called text that contains, it works with numbers as well. Let's see that in action. We select the amount column and click on the same rule. We type the number 2 as the text to check, and both of the cells that contain the number 2 are highlighted. So for this rule, Excel treats the numbers as text.
Now we have a rule designed specifically for dates. We select the date cells of the second table. It is the next rule of the same category, a date occurring.
In the new window that appeared, we have two drop-down menus. The one on the right is the familiar one with the styles selection, and the one on the left contains 10 date comparison options. If we navigate through these different options, we can see the highlighted dates changing. There is no date for yesterday, but there is one for today. This is the last week, and this is the last month. We pick this one and choose one of the default styles.
The last one from this group of rules is the duplicate values. We select the amount column, navigate to the rule, and click on it. The right drop-down menu remains the same. It is the one we use to choose the styling of the cells that are either duplicates or unique, as it is shown from our two options on the left drop-down menu. The duplicate highlights all values that exist more than once in the selected area. Values 120, 170, and 100. If we choose to highlight the unique values, then the rest of the column is highlighted.
Very useful features, but we're not done yet. At the bottom of every conditional formatting category, we have the option More Rules. If we click on it, a window will appear. With the help of this window, we can customize our conditional formatting rules even further, but this is something for another lesson.
Before we continue, we should do a bit of house cleaning. We have applied a lot of rules, and it is better to clear them and begin again with an empty canvas. To do so, we go back to our familiar conditional formatting drop-down menu and then click on Clear Rules. We have four options here. One is to clear all the rules only from the cells we have selected. The other is to clear them from the entire sheet. The third is to clear them from the table we have selected. And the last one, which is now disabled, would only be valid if we had selected a pivot table. We want to clear the rules from the whole sheet, so we click on the second option. All the conditional formatting rules have been cleared.
The second category of conditional formatting rules are as exciting as the first one. The top-bottom rules category. The first one is called Top 10 Items. If we click on it, then on the right of the window, we still have the styling drop-down menu, and on the left we have the number 10, which we can change if we want. So, even if the rule is called Top 10 Items, we can change it to highlight the top 3 items, for example. All the cells that contain the top 3 values are highlighted. Since the value 170 exists in 2 cells, the formatted cells turned out to be 4 and not 3. So this rule doesn't format the top 3 cells, but the cells with the top 3 values.
The other rules in the group work similarly. But first, let me clear the rules from this table. As previously, I go to Clear Rules and clear rules from this table only. The top 10% formats the cells that contain the top 10% of the values. Of course, we can change the number 10 and choose to highlight the top 1%, for example. The bottom 10 items and the bottom 10% rules stylize the bottom part of our values instead of the top.
And that leaves us with the last two, the above and below average. Clicking on them shows us a window that contains only the familiar styles drop-down. We can see that all the cells that have a value above the average value of the cell range are highlighted.
A quick tip: the average of a selected cell range is shown down here along with the count and the sum of the same cell range. So any cell containing a value greater than 137.5 will be highlighted. The below average rule would highlight any cell containing a value less than 137.5.
We know that this is turning out to be a long lesson, but we're almost at the end. Even though we have 3 rule categories left, they all have similar functionality. They are all used to visually depict the value of each cell in comparison to each other. If we choose, for example, the first category, data bars, we have 12 options. Hovering our mouse over each one, we can see what each of them does. It shows the value as data bars. The cell with the maximum value has a full data bar, while the other ones have smaller data bars according to their values, like a mini chart. The different options show the same result with a different gradient or solid fill.
The next category uses a color scale to depict the difference in cell values. For example, the first option, which is called green, yellow, red, shows the cells with the greatest value in green, the ones with the lowest in red, the one with the average in yellow, and the cells in between are shown in a gradient of the aforementioned colors depending on their distance of the max, average or mean values. The different options just use different sets of colors.
And then there are the icon sets. Depending on the value of the cells, the icons change accordingly. It is easier to explain this if we select the 5 ratings icon set. According to the value of the cell, a different icon is shown. The max value has the full signal icon, while the lowest value has the no signal icon. The ones in between have the icon that best represents their value in comparison to the max and the mean values. The rest of the icon sets function similarly.
If we click on the conditional formatting drop-down once more, we can see 2 more options we haven't talked about yet. The New Rule option and the Manage Rule options. The New Rule option opens the window we have seen appear when we clicked on the More Rules option that appeared at the bottom of each group of rules. We will talk about the functionality of this window in a more advanced lesson.
And if we click one last time on the conditional formatting drop-down and select the last option of the list, we will see a window appear which shows us all the rules we use. From the drop-down menu at the top of the window, we can choose to display the rules of current selection, of current worksheet, of the current table, or of any other table in our sheet, and a lot more, which we will include in the more advanced lesson on custom conditional formatting.
Having learned our way around Excel sheets, column, rows and cells, it is now time to start using Excel and get a small taste of its vast potential. We will begin with creating some simple formulas and dust off our math skills for the order of operations.
We will also get to know one of the most helpful features of Excel, the fill handle. It will help us fill our cells with ease.
But since no one is perfect, we may find ourselves staring in once of Excel errors messages. So, how to correct our mistakes can be very handy.
We will then dig a little deeper in Excel and learn about absolute and relative cell references. Don't worry, it sounds harder than it actually is.
Right then, let's go get it.
Let's learn how we can sort data in Excel.
There's a list of data that has already been displayed on our screen, this one here, with a header row, this one. As we can see, our list of data has been sorted by ID in ascending order.
Ascending order means starting from the smallest number, that's 1, to the largest number, that's 7. Descending order is exactly the opposite, from the largest to the smallest.
Suppose we want to sort our list by surname in ascending order. We click anywhere in the surname field, and then from the Home tab, we navigate to the Editing group and click Sort and Filter. It drops down a list of options and we select Sort A to Z. Our data has been sorted in ascending order.
If we want to sort data by ID in descending order, we click once anywhere in the ID column, and then from the same command, we select Sort from largest to smallest.
Let's go to the next sheet. We can see the same data, but it is in the form of an Excel table. We will learn more about tables in another video. Here we will see an additional way of sorting data that tables give us. You can see that in the header cell, there is a small button with an arrow pointing down. This is the filter button. We will deal with the filters in another video, but for now, we can see one function of these small arrow buttons. Clicking on the arrow in the surname column opens a menu of options. The first two options are the sort options for this column. Let's sort in ascending order as before.
If we click on the arrow of the ID column, we will see that the sorting options are there as well. We click on Sort from largest to smallest. So we chose to sort in descending order.
And just like that, we have learned how to sort data in Excel. Very useful. Next, we're going to talk about the fill handle. If we bring the mouse pointer to the bottom right angle of the active cell, it takes the form of a small, thin cross. This cross is called fill handle. Now, let's see how it can be used. Our worksheet displays a list of revenues and expenses, which are organized per month. So, in this column here, we're gonna calculate the result of the revenues minus the expenses. We have to type the equal sign first in cell E5, where we're now, and then type the reference of the cell displaying the value 1000, which is C5. So we're gonna type C5, then we're gonna type the subtraction symbol, and finally the reference of cell D5, which contains the value 400. If we press Enter, Excel will return the result 600. In the formula bar, we can see the formula which returns this result.
In the same way, we are going to type equals first in cell E6, then C6 instead of 1010, minus and D6 instead of 405. If we press Enter, Excel will return number 605. In the next cell, E7, we're going to type equals first, and then C7 minus D7. Then, in the next one, we're going to type equals C8 minus D8. If we press Enter, Excel will return the result. In the same way, we can calculate the result for the rest of the months as well. This is the correct way of calculating, but it's quite tedious. Now, let's see a quicker one.
Take a look at this. In cell E5, we've typed the formula equals C5 minus D5. Then we've typed the formula equals C6 minus D6 in cell E6. In the next cell, we've typed the formula equals C7 minus D7, and in cell E8, we've typed equals C8 minus D8. Let's keep these formulas here to remember them. If we look carefully, we'll be able to see that the only difference in column C is the number 5 changes to 6, 6 changes to 7, and 7 changes to 8. And the same goes with column D too.
Let's see how we can use the fill handle. First, we will delete the contents of these cells. We are going to select them and press delete. Now select the first cell and we bring the mouse pointer to the fill handle right here. Then, holding the left mouse button down, we drag downwards. We want to calculate the result up to here, the month December. Therefore, we release the left mouse button when we reach the month December, cell E16. We notice that Excel returns the correct results.
Let's take a moment to verify them. If we click cell E6, we'll be able to see that it displays the correct formula equals C6 minus D6. That's the one we've previously typed ourselves. Then if we click cell E7, the formula displayed in the formula bar is equals C7 minus D7, which is correct. Finally, clicking the cell E8, the formula displayed in the formula bar is equals C8 minus D8. That's the one we would have typed ourselves too. So the fill handle is used to replicate a formula from one cell to others by simply dragging the mouse pointer as soon as it takes the form of a black thin cross.
The fill handle can be dragged downwards, as we have already seen, or to the right. Let's see how. We are going to use this worksheet here to calculate the result of the revenues minus the expenses for January, February, March, etc. But not vertically. This time it will be horizontally.
For the first cell, we'll have to make the calculations ourselves. We select it, type equals, and then we type D4 instead of 1000 and minus D5, which corresponds to 400. We press enter to display the result, which is 600. Then we select the cell, we bring the mouse pointer to the handle, and as soon as it takes the form of a black thin cross, holding the left mouse button down, we drag right until the last month and release the mouse button. Excel will return the results. Let's take a moment to verify them. In this cell here, the E6, we should type equals E4 minus E5. Let's check if it's actually displayed in the formula bar. Yes, indeed, it's the correct formula.
Now, let's see how else you can use the fill handle. Number 1 is displayed a lot of times in column A. You could certainly type number 1 and fill the column. But let's see how we can use the fill handle to do it quickly. We type number 1 in a cell and then bring the mouse pointer to the fill handle, and holding the left mouse button down, we drag downwards. In this way, number 1 has been copied to all of the cells.
Now, let's take column C. There's a sequence of numbering here. 2, 4, 6, 8, 10, etc. Should we want to display this kind of numbering, all we have to do is type the first two numbers, 2 and 4. Then select those two cells and drag the fill handle downwards. The result is again the correct one.
We can use the fill handle for the days of the week as well. We can see here in column E we have typed the days of the week. but in column F, we have just typed Monday. We bring the mouse pointer to the fill handle and holding the left mouse button down, we drag downwards. The rest of the days of the week will then be displayed. The same goes for months. Here we have a list of all the months, and here we have typed the month January. We go to the fill handle and holding the left mouse button down, we drag downwards. Here is the result. Let me resize the columns to see it better.
Great. So if we want to copy some text to many cells, we only have to type it once. We then go to the fill handle and holding the left mouse button down, we drag downwards. And we're done.
The fill handle will help you save a lot of time and become much more efficient. So it is very important that you know how to use it. Being able to create formulas is one of the most important functionalities of Excel. To be precise, this is one of the reasons why people use Excel. So let's see how they work.
Let's select cell E10. Let's type there 8 plus 2. By pressing enter, although we'd expect to see the number 10 as the result of the operation, Excel just displayed the text 8 plus 2. In Excel, if we want to perform a mathematical operation, we should first use the equal sign and then type the numbers. So, let's go to cell E11 and type equals first and then 8 plus 2. As soon as we press enter, Excel will return the result of the operation, which is 10. The only difference between cells E10 and E11, as we can see, is the equal sign. As we can see in cell E10, we haven't typed the equal sign before the operation 8 plus 2. This is why Excel considers this as plain text. In cell E11, on the other hand, as we can see in the formula bar, we've typed the equal sign first and then the operation 8 plus 2. That's why Excel returns the result of the operation, which is 10.
Let's see another example. We go to sheet 1. Suppose we have inserted our revenue in cell D5, 1000, and our expenses, 500, in cell D6. Now let's go to cell D8 and perform the subtraction and display the balance. As we have already mentioned, we have to start with an equals sign. Then we type the revenue, that's 1000, minus the expenses, that's 500. And press enter or click on the green arrow on the formula bar. Excel has now displayed the result. That's 500, which is correct. As you can also see in the formula bar, we have typed equals first. Then the revenue amount, minus, and then the expenses amount. These two examples may have produced a correct result, but we shouldn't use Excel like that.
You're right. Let's see the correct way to do this. We're going to calculate the result once more. We have the revenue amount and the expenses amount here as well. And we're going to calculate the result in cell H8, using a different method this time. As we've already mentioned, we're going to start with the equal sign, but we're not going to continue with the number 1000, which corresponds to the revenue. We're going to enter the cell reference. Since number 1000 is displayed in cell H5, we're going to type H5. Then we'll type minus, And instead of typing 500, which is the number corresponding to expenses, we're going to type the reference of the cell that displays number 500, which is 86. Finally, we press enter. The result is 500 again.
But as you can see in the formula bar, we have typed the cell references, not the cell values. Now let's see the reason why the second way is more correct than the first one. Let me remind you that in the first method we have used cell values, while in the second we have used cell references. Suppose we have made a mistake with the expenses, which should be 800 instead of 500. We will have to correct the revenue. We click on cell D6 and then type the number 800 and press enter. As you can see, the amount of the result hasn't changed. It remains 500, which is obviously incorrect. Now let's do the same in the second example. We select cell H6 and change the expenses to 800. But as soon as we press enter, we see that the amount of the result has changed into 200, which is the correct result. This is so because we have used H6, which is the cell reference, not the cell value itself.
We have learned about formulas and how important it is to use cell references. Things are becoming more and more interesting, but at the same time, more difficult, so pay attention. Excel performs mathematical operations in a specific order. Let's see what this order is. What we're going to explain are the basic operations only: multiplication, division, addition, and subtraction. But our examples will also include operations in parentheses. The order of performing operations is as follows. Excel performs operations in parentheses first, then multiplications and divisions, and finally additions and subtractions.
Let's see the first example. According to what we have said, Excel will execute the operation in parentheses first. 4 plus 8, and then it will perform the division. So the result will be like this. 4 plus 8 equals 12, divided by 2, which equals 6. In the second example, however, Excel will perform the division of 8 by 2 first, and then the addition. So the operation will be 4 plus 8 by 2, which equals 4. And the final result will be 8. As you can see, the result of the first example is 6, and the result of the second example is 8, even if operations involve the same numbers. The only difference is the parentheses.
Let's see another example. We'll have to calculate the average of numbers 4, 2, and 6. The correct way is the first one. Calculating the addition of the three numbers first, and then dividing the result by 3. So, 4 plus 2 equals 6, plus 6 equals 12, divided by 3 equals 4. In the second way, since the division precedes the addition, the operation will be 4 plus 2 plus 6 divided by 3, that equals 2. So the result will be 8.
So keep in mind the order of the operations in Excel if you want to have the correct results. The order of operations is more of a math lesson than it is an Excel lesson, but is the source of many miscalculations in Excel.
Let's see some common mistakes in formulas and how we can correct them. Let's start from cell E5 that displays number 1000. It's certainly wrong. 1000 is not the correct result when subtracting 400 from 1000. Cell E5 should display the number 600. Number 1000 corresponds to the cell C5, while number 400 corresponds to the cell D5. Therefore, this cell here should display the formula equals C5 minus D5. But, as we can see, the formula bar displays D1. To correct this mistake, we're gonna click here. We can see the insertion point flickering in the formula bar, so we're gonna delete 1 using the backspace key and then type 5 and press enter. The formula has been corrected.
The next mistake we can see is in cell E11. 1500 minus 500 equals 1000. So the cell E11 should display number 1000. Instead of 1000, it displays this error message. Name. We select the cell and you can see that we have typed equals C11 minus DDDD11. That's a lot of D's. This is not a valid cell name. Therefore, in this point here, we should type D11. We delete the extra D's and type D11 and press enter. The formula has now been corrected and the correct result is shown.
Now, let's go to the next sheet and see some more error indications. The hash marks. When there are hash marks displayed in cells, it means this cell contains a number or a date which is too long to fit in. Therefore, we bring the mouse pointer here, hover it until it takes the form of a double arrow, and drag to the right. The date has now been fully displayed.
Let's go to the next error message, the division by 0, which is shown here with this div divided by 0. If we look at the formula bar, we'll see that we have tried to divide 5 by 0. This is wrong. We can correct the error if, for example, we divide by 1. We click on it, change 0 to 1 and press enter. So the error message has disappeared.
The following error is the value error. The idea is to subtract the expenses from the revenue. Revenue appears in cell C3 and expenses appear in cell C4. If we click on cell F5 and look carefully at the formula bar, we'll be able to see that we are mistakenly trying to subtract B4 from C3. B4 corresponds to the text expenses, whereas C3 corresponds to number 1000. What we actually want to do, though, is subtract C4 from 1000. Therefore, we'll have to bring the mouse pointer in here to correct the error. We type C4, press enter, and the error has disappeared.
Now we're going to explain two more errors. The first one is the circular reference. In the Excel status bar, down here, we can see the message that there is a circular reference in cell C6. If we click cell C6, the formula bar will show that we are trying to subtract C6 from C3. This means that we are using the C6 reference inside the cell C6. But this is wrong. We change C6 to C4 and the error is gone.
The last error message will appear like this. Suppose we delete the fourth row by mistake. Because the fourth row is used in this cell, the message ref, which means invalid cell reference error, will be displayed on our screen. If we click this cell, we'll be able to see that we're trying to subtract something from cell C3. This something was cell C4, which no longer exists. Therefore, we have to correct the error by undoing the row deletion.
We have learned how to recognize and correct some of the most common mistakes in Excel, something that will help us save a lot of time. Since version 2013 of Office, Microsoft added one more very useful feature to Excel, the Quick Analysis tool. In our sheet, we have the fuel cost of the employees of a company for each month of 2022.
To use Quick Analysis, the first thing we have to do is select our data. In our case, cell range A2 up to M8. A small icon appears at the bottom right next to the selected range. If we click this icon, 5 categories of options appear. Let's see them one by one.
The first one is Formatting. It gives us 5 conditional formatting options and one option to clear all conditional formatting. Just hovering over each option shows us a preview in our selected range of the expected result. Each one applies a different type of conditional formatting style. The options are data bars, color scales, icon set, greater than, and top 10%. We select this one.
The next category, called Charts, gives us a very fast way to create a chart based on the selected data. Again, we have 5 available chart types to choose from, and hovering our mouse over each option shows a preview of the result. The available charts are clustered column chart, clustered bar chart, stacked column chart, stacked bar chart, and line chart. There is one more option that opens the familiar chart window from which we can choose whichever chart we want. For now, we select the line chart.
Next category is the Totals category. This gives us 10 options. 5 of them are the Totals row at the bottom of the selected range, and 5 of them a Totals column at the right of the selected range. The available Totals options are Sum, Average, Count, Percentage of Total, and Running Total. The same are for the column total. As you can see, hovering the mouse over each option shows us a preview of the result. We add a new row with a sum total.
Next category is the Tables category. The first option lets us create a table from the selected range. There are 4 other different types of pivot tables. Hovering the mouse button over them is showing us a preview of the result, just as before. The last option opens a window that lets us select from a list of recommended pivot tables. We will talk about pivot tables in another video, so for now we ignore these options.
And we have reached the last and more impressive category, the ability to add Sparklines. Sparklines are mini charts enclosed in a single cell that give us a bird's eye view of our data in a graphical representation. There are 3 different types of Sparkline charts. We can see a preview of each Sparkline option just by hovering over them. Let's select the column Sparkline chart.
Really impressive. The Quick Analysis tool is not the only way to add sparklines though. We can also insert them using the Insert tab. Keeping the cell range selected, we click on the Insert tab. There we can find the Sparklines group of commands. We can see all three sparkline types here as well. We have already added a column sparkline chart, and since there are no negative values in our data, adding a win-loss chart will not help us visualize our data. So let's choose a line sparkline chart. A window appears, the data range, the source data from which the chart will be created is already selected, but we can change it if we want to. Next, we have to select the location to place the sparklines. The location range must have the same height or width in cells as our selected range, depending on where we want to place the sparklines. We want to place them next to the bar sparkline chart, so we have to make sure the range has the same height as our data range. We click on OK and the line charts are ready.
Using the Quick Analysis tool is a very fast way to manipulate our data, but each of the options it gives us can be achieved by their own respective tabs and commands, giving us much more customization freedom. Nothing beats the Quick Analysis in efficiency though.
Next, we will talk about the defined names of specific cells or cell areas. Excel gives us the opportunity to name a cell or a cell area so that we can refer to it using its name and not its reference. For instance, the cell B1 is named Shipping, and the name appears at the name box here. The cell area from cell D4 to cell D12 displays the quantity of each product. We select the cell area from cell D4 to cell D12, and we notice that the cell area is named Quantity.
Let's learn how we can name a cell. For instance, let's name cell C4 to RAM. We select the cell. We can see that the cell reference C4 appears at the name box. We delete the cell reference and we type the name RAM. We press Enter to confirm the change. Now we can refer to cell C4 both with the cell reference and the name RAM.
Let's see how we can name a cell area. We will name the cell area from cell F4 to cell F12 that contains the cost as cost. First, we select the cells, we click at the name box, and we type the name cost. And of course, we press Enter. The cell area is now called cost.
Let's learn of another way to name a cell or a cell area. The cell C6 will be named TFT. We select the cell C6. We navigate to the Formulas tab and locate the Defined Names group. We click the Define Name command and a new window opens so as to type the new cell name. We type the name TFT at the field name and click OK. We can see that cell C6 is now named TFT.
In order to navigate to a cell area or a cell that we have named, we need to click at the black arrow. This is where all the cell names or the area cell names appear: RAM, TFT, cost, shipping, quantity. If we pick up, for instance, quantity, Excel will select the respective area.
We can also delete a cell name or a cell area name. Let's delete, for instance, the name Shipping. We click at any cell, we navigate to the Formulas tab, and for the Defined Names group, we click at Name Manager. At the emerging window, we locate the name Shipping. We click at Delete and we confirm that we want to delete the name. The name shipping no longer appears with the rest of the names. We click at Close. The cell B1 is no longer named shipping.
Let's see another example of name creation. At Sheet 2, we can see the sales of 6 automobile companies for the 5 first months of the year. We want to name the cell area with the sales of each company with the name of the company, and the cell area of each month with the name of the month. For example, we will name the area from cell C4 to cell C9 January, the cell area from cell D4 to D9 February, etc. Also, the cell area from cell C4 to cell G4 will be named Mercedes. The cell area from C5 to G5 will be named Alfa Romeo, etc. We will learn a more time-effective way to name these areas because the one we have learned demands too much effort and time. We select the cell area from B3 to G9. We navigate to the Formulas tab, and at the Defined Names group, we select the Create from Selection command. A new window named Create Names from Selection appears. We enable the areas that we wish to use during the name creation. We select the top row to create the names January, February, etc. We select the left column to create the names Mercedes, Alfa Romeo, etc. and we click on OK.
By clicking at the black arrow on the side, we can see the names of the companies and of each month. If, for instance, we select Mercedes, Excel will select the values under the name Mercedes for the 5 months.
We can use the name of a cell or a cell area at formulas just like we did with the cell reference. The usage of names instead of cell reference is very useful because it eliminates the need of typing complicated references. Let's see another example. At the cell F13, we will insert a function that will calculate the total cost using cell references. That is to say, the sum of cells from cell F4 to cell F12. We select the cell F13 and type the formula equals sum F4 up to F12 in parentheses and press enter. We remind you that the cell area F4 up to F12 is named cost. At cell F14, we will insert the sum function again, but this time we will not use the cell references just like we did before. We will use the cell area name. We select the cell, we type equals sum, and type the word cost and press enter. The result is the same. This type of cell reference is called structured reference.
The specified names in one worksheet are available to the other worksheets of the same workbook.
Let's take a look at some incorrect names. We select the cell E9 and type the name BMW March and press enter. A warning message reminds us that this name is not valid. The name is wrong because it contains a space between the two words. We will type the same name using the underscore between the two words.
We type the name third price with an underscore, third underscore price to cell E4 and click on OK. The name is wrong again because the first character needs to be a letter, not a number.
So we have learned how to name cells and cell areas, a very useful feature of Excel.
In this lesson, we will talk about Excel tables. We will learn how to modify them, stylize them, and use them to the fullest of their potential.
But let's start with the most important step, the table creation. In the current sheet, we can see the sales of 6 employees for the first trimester of the year. We have marked the 2-star employees with an orange background. The cells are not formatted in any other way. We can easily format them manually if we want, but the creation of an Excel table will do it for us. We navigate to the Home tab of the ribbon and click on Format as Table. A list of dozens of predefined styles will appear. We choose one. A window appears that lets us choose the range we want to convert to a table. Since the selected cell was in an area that could be a candidate for a table conversion, that area is shown in the field. Of course, we can change the cell area and choose any area we want. There is a checkbox here that lets us define if the cell range we have selected includes headers. Even though in our case it does, let's see what happens if we uncheck it. The cell range has been formatted as table, and a new row was created to play the role of the headers.
Notice that the cells with the orange background, we had already pre-formatted, didn't lose their formatting. But since our data has headers already, let's undo the table creation and redo it properly. We click on Undo, then select any cell of the desired cell range, and finally from the Home tab, we select a table style. Let's say this one. We double check the cell range is the correct one and make sure the checkbox is checked. That's it. Our table is ready. And not only have we created the table, but we have also stylized it. All with a couple of clicks. Notice that the orange background of the 2 employees is still here, while the rest of the cells have been formatted to fit the style we have selected. But we have a lot more customization options when we create a table.
Besides the cell style changes, there is a couple more differences from our original data we can see. First are the arrow buttons, which help us sort and filter the table. We will talk more about them at another video. These arrows can be hidden though, as we will see in a while, and the only clue that this data have been formatted as a table will be this small corner icon in the lower right of the table. This icon shows us the edges of the table. If we hover our mouse over it, the mouse cursor changes to a diagonal double arrow. If we press the left mouse button and keep it pressed while moving our mouse, we can resize the table to include or exclude rows and columns of data. Here we have moved it upwards and removed the last row of the table. If we drag it downwards, we can include it again.
There is one more way to add rows and columns to our table. We can simply type something in the cells adjacent to the table cells and they will be added to the table. For example, suppose we want to add one more column in the table for month April. All we have to do is go to cell E1 and type April. When we press Enter, a new column will have been added. Same goes for rows as well. Let's add the employee named Smith in cell A8. A new row is automatically added to the table. Let's undo these 2 actions.
There is one more way to change the size of the table. If we click anywhere inside the table, a new tab appears in the ribbon. In the leftmost part of the tab, we have the option to give our table a name, which will be very useful when we want to use the table in our formulas, as we will see later in the video. This is why it is best to replace the default name that Excel gave to our table to something else. Let's type employees. Below the table name, there is the button Resize Table. If we click it, a new window will appear that will allow us to select the cell range that is included in our table. We select the cell range of the table and make sure we have excluded March. We press OK, and as we can see from the small corner icon, March is no longer part of our table. Let's include it again. We click on the rectangle icon and drag to include the March column.
There are more buttons in the Table Design tab though. On the right of the New tab, we can find the list of predefined table styles. We can change the table style by using any of them, or we can clear the styling altogether by clicking on the Clear option. All the formatting of the table has disappeared, but the orange background of the two employees that existed before the creation of the table remained. Let's select some other style.
We can also create a style from scratch if we want to. We click on the Style button to show all the styles, and from the bottom of the list we select a new style. A new window will appear showing a list of all the different parts of the table, such as the header row. At the top of the window we can select a name for our style. Let's say my first style. Then we select the header row part and click on the Format button below the list. The familiar Format Cells window appears, allowing to format the header cells any way we want. Let's make them bold and change the fill to yellow. And click on OK. We can see a preview of our changes in the preview image on the right of the window. Similarly, we change the other parts of the table to create our table style. The new style will be at the top of the style list.
Let's go to the courses sheet. Here we see one more table. It shows the grades of 6 students in 5 lessons. We click inside it and navigate to the Table Design tab. Next to the styles list, we can see a series of checkboxes. Each one of them enables or disables a specific table feature. We can see that in the current table there are 2 checkboxes selected, the header row and the filter button. This is why there is a header row in our table and the filter buttons are visible on it. If we click on the filter button checkbox, the filter buttons disappear. If we uncheck the header row, the header row disappears. Let's check both of them again. The first column checkbox formats the first column in a different style. We select this if our first column contains data that could be used as row labels. In our case, the name of the lessons are indeed the row headers, so we keep this checkbox selected. The total row checkbox shows a new row at the end of the table.
If we click on any of the cells in that new row, a drop-down box appears that lets us select which function we want to use on the data of that column. There are a lot of functions to choose from, and we can even select any of the hundreds of functions of Excel. The logical in this case is to use the average function, which will calculate the average grade of each student. We will skip the last column checkbox for now and check the banded rows checkbox. This adds to our table banded rows so that it will be easier to read the data, especially if there are a lot of rows of them. Banded columns does the same thing, but with columns. For our data, banded rows look better, so we can check that one.
The last column checkbox we skipped earlier works similarly to the first column checkbox, but for the last column of our table. In order to be meaningful in our table, we have to create a summary column in our table. Let's call it Average. The column has been automatically added. Now let's format it as last column. The formatting of the last column changed to make it stand out. It is now time to populate it.
We want to calculate the average, so we type equals and the function name average. We select the cell range, that's B2 up to G2. Notice that instead of B2 up to G2, our function uses the name of the table enclosed in brackets followed by the @ and the name of the columns. This means that it will use the values of the current row of the grades table and start from the column Jackson and go up to column Corner. If we click on Enter, the whole column and not just the cell will be populated with the function, which is what we would want to do anyway. Excel is smart enough to save us a step. We can also add the average for our new column in the totals row.
We will ignore all but one of the rest commands of the Table Design Tools tab, since they are rather advanced for this lesson. The one we will talk about is the Convert to Range button. This converts our table back to a normal cell range, but doesn't clear the table style that we have applied. If we click on it, a pop-up window appears that asks for confirmation. We click on OK, and the table has been converted to a regular cell range. The corner icon and the filter buttons are no longer there, but the rest of the table styling remained.
This was a long video, but tables are one of the most useful features of Excel.
In this lesson, we will learn how to use the little arrow button that appears on the headers of our tables when we create them.
In the current sheet, we can see the sales of the 6 employees for the first trimester of the year. We have marked the 2-star employees with an orange background. The data are already formatted as a table, and we can see that next to every header cell, there's a small arrow.
These arrows are the same as those displayed when we filter data which are not inside the table. Let's jump briefly to another sheet. Here we have some data which are not part of a table. If we select this data and from the Home tab of the ribbon we click on the Sort and Filter button, a list of options appears. If from this list of options we choose Filter, the familiar arrow button will appear. By clicking on it, we can see that the options we have are exactly the same as the ones in the table arrow. Keep in mind that these data are not a table, but the functionality, as far as the small arrow is concerned, remains the same. So whatever we learn here applies to this filter button as well.
Back to our original sheet. We can click on the arrow next to the employee header cell. The first 2 options are used to sort the data of the table. So, if we want to sort the table by employee name in ascending order, we use the first option. Suppose we want to sort the tables by March sales in descending order. We click on the arrow on the right of the March heading and click on the descending sorting option. Our previous sorting has been removed and the table is now sorted by the March values in descending order. But there is one more sorting option. This one, sort by color. Suppose we want to show our star employees first. We click on the sort by color and choose the color of the star employees. They are now shown first, and the rest of the employees are shown below them in their original sort order.
This could be very useful if we have our data categorized by color.
To disable our sorting, we have to go to the Data tab of the ribbon and click on the Sort button. A new window will appear. This window can help us sort our data by multiple columns, which we will talk about at another video. Here we will also find this button, the Delete Level button. By clicking on it, we remove our sorting.
Below the 3 sorting options, we can find Sheet View. This is a feature available to Office 2021 or newer. It requires for the workbook to be stored in our OneDrive, so let's open a workbook stored in our OneDrive. This is a very useful feature when you share the workbook. All collaborating users can create their own temporary sheet views and see the data using different sorting and filtering options without messing up with the original one. Let's see how. We click on the Filter button, Sheet View, and click on New Sheet View. We change the filtering and sorting options, let's say descending order here, and then click back on the default view. Excel asks us if we want to keep our view or discard it. We set a name for our view and keep it. The new view will be shown below the default view. Default view, new view. Let's go back to our locally stored sheet.
It is time to talk about filters. Our worksheet contains the grades of 70 students for 4 subjects: mathematics, physics, chemistry, and literature. We will use a filter to display the students who have achieved 18s at mathematics. We click on the small arrow next to the mathematics header. At the bottom of the list of options, we can see the list of values of the specific column, which we can use as a criterion. We only need the value 18, so we first deselect them and then select just the value 18. Excel only displays a subset which contains just the students whose mark is 18. In other words, Excel has hidden all the rest of the entries that do not satisfy this criterion. We can see that the color of the numbers of the rows which are displayed is blue, and the column Mathematics displays a little filter icon, which means that we have applied our criterion there. Filters display only the rows that fulfill the filtering criteria, hiding the rest of the rows, as opposed to sorting, which reorders the rows. In our example, 10 out of 70 students have achieved 18 at mathematics.
To remove the filter and display all the rows, we have 2 options. The first is to select a Clear Filter from Mathematics, which appeared as soon as we clicked on the arrow. As you can see, the filter has disappeared. Let's undo to see the other way. We click the arrow again and select All, and then OK. The filter has been removed again.
Next, let's assume that we want to display the top 5 grades at mathematics. We click on the arrow of the column Mathematics. We navigate to Number Filters option, and from the emerging menu we select Top 10. There we select if we want to have the greater or the smaller values, top or bottom, and we define the number of the rows. We set the number to 5. We make sure that the items is selected, otherwise we'll have a list of the top 5%. Once we're done, we click at OK. The table now displays the 8 students with the best grades.
We would expect 5 students to be displayed, however we have 8 because 3 students have the same grades. We will display all the rows again. We click on the filtered arrow and select Clear Filter from Mathematics.
Next, let's assume that we want to display all the students whose grade in physics is between 10 and 15. We click at the arrow of the column of Physics and then at Number Filters. We select Custom Filter. Here we set the range. We select is greater than or equal to and set the value 10. But we want the grades to be less than or equal to 15. For this reason, we choose the equality operator AND. we select 15 at the second field. In case 15 wasn't listed among the available options, we could have typed it. We click on OK.
35 rows are now displayed, as you can see at the status bar. We clear the filter so that every row is displayed again. The table contains a few students that haven't received any mark at the subject of chemistry. This one and this one, for example.
To find out which students do not have grade in chemistry, we do the following. We click at the chemistry arrow and deselect the Select All choice. At the end of the list, we select blanks. And now we have 3 students displayed. To display all the rows, we click at the filter arrow and then we select Clear Filter from Chemistry.
Depending on the type of data that exists in our columns, the options we have in the filter menu also change. For numbers, as you have seen, we have equal to or not equal to, greater than, less than, and many more. But if we go to a column with text, for example in the name, then the filters are different. Instead of number filters, we have text filters. Here we will find the options begins with, to include names beginning with certain letters, or ends with, for names ending in certain letters. Similarly, the contains and does not contain commands display names that contain or do not contain some specific letters respectively.
Let us select all the students whose name starts with A. We select Begins with from the filter menu and we write A. We click on OK and the filter has been applied.
The filters can be applied in combination as well. We have selected all the students whose name starts with A. Let's see how many of them got over 10 in mathematics. We click on the mathematics arrow, select number filters, greater than, and type 10. The filter is applied.
To turn the filtering off, we need to navigate to the Data tab and then click on the Filter button again so as to turn it off. As we can see, the arrows at the headers have disappeared and the filter has been turned off as well.
We can also filter by color. We go back to our first sheet. We want to filter our table to only show us the employees marked with the orange background. We click on the arrow, choose Filter by Color, and select Orange. The table now only shows us the 2 employees marked with the orange background.
Remember that all we have talked about today applies to data, not in tables as well. Excel gives us tools to sort and filter data in more advanced ways, but we can safely say that we have covered everything about simple sorting and filtering in Excel. The next feature we're going to explain is the relative, absolute, and mixed cell references. This area here displays the subjects taught by an instructor, the hours spent for every subject, and their remuneration for every lesson hour. So we'll have to calculate the cost for 18 hours of teaching windows in cell E6. As we've already mentioned, we'll start with typing equals, and then the reference of the cell containing the value 18, which is C6, multiplied by D6, cell reference. Then we press enter and Excel will display the result, which is 180. In cell E6, as we can see in the formula bar, we've typed C6 times D6. This cell here, the C6, is located 2 cells to the left of the cell E6, while D6 is the only cell to the left of E6.
Now, let's take a moment to see how Excel works. Although we have typed equals C6 times D6 in cell E6, Excel actually entered the position of cell C6 relative to E6. Cell C6 is 2 cells to the left of E6, so where we typed C6, Excel entered 2 cells to the left. Similarly, for cell D6 is 1 cell to the left of E6, so Excel, instead of entering D6, it entered 1 cell to the left.
This is how the fill handle works. If we bring the mouse pointer to the fill handle of cell E6 and holding the left mouse button down, we drag downwards, the only thing that is copied is equals 2 cells to the left multiplied by 1 cell to the left. So in cell E7, the 2 cells on the left correspond to cell C7, which is why C7 appears in the formula bar, and 1 cell on the left now corresponds to D7, which is why D7 appears here as well. The same goes for the other cells that we have filled in automatically with the fill handle. Now, let's see once more how the example worked. In cell E6, we have typed C6 times D6. As we've already mentioned, cell C6 is 2 cells to the left relative to cell E6, while cell D6 is 1 cell to the left relative to cell E6. C6 and D6 are called relative references because they are relative to cell E6. The only thing we did when using the fill handle was to copy this relative reference.
In this example, the price per hour is always €10. Therefore, we don't need to dedicate an entire column to it. So, we have removed the column, as we can see here, and typed the text price per hour in cell C20 and the text €10 in cell D20. The rest of the data remain the same.
So what we need to do is calculate the cost of 12 hours for Windows in cell D22. We're going to start with equals. Then, instead of typing 12, we type the cell reference C22. And instead of the value 10, we type the cell reference D20. We press Enter, and Excel will display the correct result.
We have already mentioned that although we have typed equals C22 times D20, Excel actually interpreted this to 1 cell to the left, because C22 is 1 cell to the left relative to cell D22, multiplied by the reference of the cell appearing 2 cells above. This is so because D20 is 2 cells above the cell where we have typed the formula in.
We're now going to use the fill handle to copy the formula to the rest of the cells. Here's the result. And it's wrong.
Let me remind you once more that the only thing the fill handle does is copy the formula. 1 cell to the left multiplied by 2 cells above, 2 cells up.
Now, let's see why these error messages have been displayed. If we click cell D23 and check the formula displayed in the formula bar, we can see the following. The C23 reference corresponds to 1 cell to the left, and this is the one we've actually wanted to type. But the problem is when Excel interprets the 2 cells up part of the formula. In this example, 2 cells up points to the cell containing the text cost, not to the cell D20, the one we've actually wanted to display.
Therefore, we have to find a way to ask Excel to lock the reference of cell D20, not allowing it to change to D21, as we see here, or D22, as we see in the cell below. This is how we're going to correct all error mistakes. C22 is a relative reference like D20. Instead of using a relative reference, we have to use an absolute reference for this cell.
In order to apply an absolute reference, we'll have to type the $sign in front of the column indication and then again in front of the row indication. We're going to click on cell D22 and in the formula bar we're going to type the absolute reference. That's the $sign, as we said. And then press enter.
Excel, on the other hand, entered in this cell the reference of one cell to the left, because the reference of cell C22 is relative, multiplied by the $sign D, the $sign 20.
We bring the mouse pointer to the fill handle and as soon as it takes the form of a black thin cross, we drag downwards. Now this produces the correct result. Let's see why.
In this cell, D23, Excel has entered the reference of one cell to the left, which is C23, and it is the correct one, multiplied by D20, that contains the price per hour. It did the same for the rest of the cells as well. Observe that the relative reference changes while the absolute reference remains the same.
Now, let's see how we can improve this formula. Remember, the first time that we used the fill handle without the absolute reference, we dragged downwards and 20 changed to 21, then to 22, then to 23, etc. Because when we drag downwards, the only thing that changes is the row number. But in this case, this didn't happen because of the $sign in front of 20. In the same way, if we moved the mouse pointer to the right, D would have become E, F, G, etc. But this is also prevented from the $sign that has been entered in front of the letter D. In this specific example though, there's no way to drag to the right, we can only drag downwards. So the $sign in front of D is redundant. Therefore, we can delete it and press enter. Then we use the fill handle to drag downwards. As we can see, both the formulas and the results are correct.
In this cell, D20 appears again as in the other cells. D $sign 20 is now a mixed reference. We have already mentioned that the D20 is a relative reference. $sign D $sign 20 is an absolute reference, and what we just typed, which is D $sign 20, is mixed reference. It is absolute only by rows. 20 does not become 21, 22, and so on. If we had typed $sign D20, it could still be a mixed reference and the column would be locked. It would be absolute by column only.
Absolute, relative, and mixed references are perhaps one of the most difficult elements of Excel to understand. We hope that with this lesson they became clearer.
You have learned how to create a beautiful worksheet with useful data, but to showcase this data in a form that is easily consumed by everybody, you need some visual assistance. That's where charts come in.
Excel offers a vast variety of chart types and styles, along with a ton of customization for each one. In the following lessons, you will learn some basic principles on chart creation, customization, and formatting.
We will also show you how to create some of these chart types, as well as how to move them around on Workbook and how to delete them if it's necessary.
It is not hard to create or modify a chart in Excel, and the results can be at least eye-catching. Let's begin.
One of the most impressive features of Excel is the ability to create charts. So let's see how we can use this feature. Our screen is displaying a worksheet that illustrates two charts. This is the first one, and this is the second one. Charts are graphical representations of data.
So these are our data. 3 companies and their sales for the first 4 months of the year. This chart here displays these 3 companies and their sales for every month, whereas this chart here displays the Dell company only and its sales for every month.
Let's see how we can create the first chart. It displays the company names and their sales per month. We select the data in the B6 to F9 cell range. Then from the Insert tab, we locate the Charts group. We click this button here, and it pops up the Chart dialog box. This is where we go to All Charts tab to see all the available chart types. That's column, line, pie, bar, etc. So we're going to select a chart type for example, column. Then on the right side of the window, we're going to select the secondary chart type. There are various column charts such as clustered column, stacked column, 100% stacked column, etc. We select the type we prefer, for example, cluster column, and then we click OK. As we can see, our chart has been created.
Now we can edit it. Our chart is currently displaying company names here and months here. If we select the Switch Row and Column command in the Chart Design tab, companies will be displayed here and months here. Let me move the chart to the side to see both charts, the old and the new. If we want to display data labels, we have to navigate to the Charts Layout group here, click the Add Chart Element button and select one of the data labels commands. This is where you can select their placement. We select it and you can see there are some values displayed above the columns.
This part of the chart is called Legend. If we want to hide it or change its location, we go to the Add Chart element and select one of the Legend commands. If we click here, it will disappear, but we can display it again at a place of our choice. From the Add Chart element again, we can also edit the title of our chart. We select the place where we want it to be displayed and type the text Sales.
All elements of the graph can also be displayed or removed using this icon to the right if we have the chart selected, here this plus icon. When we click it, a small window appears right beside the chart. If we click on the data labels, we eliminate them, and by clicking again, they reappear.
If we don't want to display the chart on the current worksheet, we right-click onto it and then click the Move Chart option. For the moment, it is displayed on the chart worksheet. We can either select another worksheet, or if we click here, we can create a new worksheet and automatically move it there. We name the new sheet New Chart and we move it there.
Note that the new sheet is not a classic Excel sheet. When we move a chart to a new sheet, then Excel creates a chart sheet that has no cells, but only the chart we have just moved.
The next chart we're going to create is this one. As we can see, this chart displays the company name and its sales per month. So what we have to select is the B6 to F7 cell range that illustrates the company sales per month. Then, from the Insert tab, we locate the Charts group. We click this button here and it pops up the Charts window. From the list displayed, on the left hand side, we select Pi. And from the list displayed on the right hand side, we select Pi again. The difference between this type and that one is that the second Pi is displayed in 3 dimensions. Then we click OK. Our chart has now been created.
Let me move it and resize it. If we go to the Charts Layouts group, we'll be able to see that many commands are not active. Here, as you can see, there are many commands that are not active. This is so because every type of chart activates only the commands it supports. The chart also contains the legend, which can be edited in the same way you have edited in the previous chart.
Now, suppose we don't want to display the chart we've just created on the current worksheet, but one of the other ones. We'll have to right-click onto it and select Move Chart. We select the Sheet 2 sheet. So to move the graph, we click the OK button. And the graph has been moved to Sheet 2.
Notice here that Sheet 2 now does not have the form of the chart sheet we saw earlier. If we move a chart to an existing sheet, then this sheet continues to have the form of an Excel sheet. Of course, moving a graph can also be done with a simple cut and paste. For example, in the graph we have just transferred, we go to the Home tab and cut it, and then go on Sheet 3 and paste it.
So this has been an introduction to learn how to create in charts. We learned how to create 2 different types of charts, how to add elements to them, and how to move them to other sheets. Next, we'll see how to delve a little deeper into charts. We'll learn how to, for example, change the type of a chart, but also how to print them. But first, let's take a look at the parts that make a graph.
This is the chart area, the empty space here. This is the title. This is the legend. This is the plot area. This is the horizontal axis. And this is the vertical axis.
Now let's try and edit some of these elements. Our chart has been selected. This is evident from the handles which appear around the chart area. We right-click onto the chart area, and from the menu that pops up, we select Format Chart Area. At this point, we can select a different color for the chart area. In the Fill Options group, we click on Solid Fill, and then we select Red color. The chart area is now displayed in red.
The color can also be changed from the ribbon. We go to the ribbon's Format tab, and from the Shape Fill button, we select another color. This one, for example.
At this point here, we right-click again and select Change Chart Type. It pops up a new window and we can select a different type of a chart. Suppose that the type we selected in the beginning is the column chart, but it's not the appropriate one. We'll select bar and then this type here, 3D clustered bar. Then we click OK. The type of the chart has changed.
We can also change the chart type from the ribbon. Go to the Chart Design tab and click on Change Chart Type. The window we saw earlier appears and we can select another chart type if we want. We do not want it for now.
To change the title of the chart, click on the current title to select it and one more to change it. We change it to Sales 2021. If we want to, we can change the colors of each series. We notice that Dell appears in this blue color. We choose this series by clicking on any of the 4 bars corresponding to the Dell series and then right-click to select Format Series. From the Fill option, we select Solid Fill and we choose a different blue color. The new color appears on all Dell bars.
The same is true as before. That is, with the series selected, we can go to the Format tab and change the fill color from the corresponding icon. But we will not do that now. We will go to the Home tab to see another way to change the fill color. We have the series selected and you can see that the commands of the font group are all disabled but one, the fill color icon. We click on it to change the fill color. Let's change it to purple.
There are 2 charts on the other worksheet. This is the first and this is the second. To select the first chart, we're going to click onto it. Handles will then be displayed, as well as some lines around the above table. These lines will indicate that this chart draws data from this cell range. If we click the second chart and select it, these lines will change, because the second chart draws data from this cell range.
Let's select the first chart again. We move the mouse pointer to this point here, and as soon as it takes the form of a double arrow, holding the left mouse button, we drag upwards. For the moment, we have selected 2 of the companies only, as you can see in the legend and in the plot area. In the same way, you can select 1 company only. We click, drag upwards, and now the sales of just Dell are displayed. And if we want, we can drag downwards and we have the sales of all 3 companies displayed again.
If we want to change the size of a chart, we'll have to select it first. So let's select it. Then we bring the mouse pointer to one of the handles and holding the left mouse button down, we drag to a direction of our choice. This way the size of our chart has changed. If we want to move it, we select the chart and then we click inside the chart area and holding the left mouse button down, we drag the chart to a new location.
If we want to delete it, we'll have to select it first and then just press the delete key.
If we want to print a chart, we'll have to select it first and then go to the Print command in the File tab. If we click Print, our chart will be printed to the default printer.
This is true when we only want to print the chart. We may want to print it as part of the rest of the sheet. If this is the case, then we do not select it and go back to File and Print, and we see the print preview of the sheet. As you can see, the chart will no longer be printed on its own, but as part of the entire sheet.
So we've learned how to change the type of a graph, how to format its various parts, how to resize it, and how to print it. I believe it is enough for now.
In this lesson, we will learn of all the different ways we can stylize our charts with just a few clicks. We will also see how we can make our charts more accessible by adding alternative text. Our workbook consists of 2 worksheets. The first has 1 chart in it, and the second has 2. Let's start with the first sheet.
We click on the chart and then navigate to the Chart Design tab that has just appeared. There we will find the Quick Layout button. This changes the overall layout of the chart. There are 11 presets to select from. If we hover our mouse over each one, a tooltip appears letting us know which elements are shown in each layout.
Also, the chart changes to temporarily show us what the layout will look like. The layout will not be applied until we click on one of the layout options. We choose one of the options and the chart changes to match our selection.
Next is the Change Colors button. This changes the color scheme of our chart.
Again, hovering over the options temporarily changes the colors of the chart to help us preview them and decide if they look okay to us. We pick one of them and our chart has changed. With just a couple of clicks, we stylized our chart.
But there is an even easier way. Let's go to the second sheet. Here we can see 1 column and 1 pie chart. We click on the column chart and navigate again to the Chart Design tab of our ribbon. A large area of the ribbon is populated by the available chart style. These are 14 predefined charts that change the overall visual style of our chart. They change the layout, the colors, and the general design of our charts.
Again, hovering over them lets us preview the changes it will make to our chart. I usually choose one of these styles since most of the times they look better than whatever I have thought of.
You can always make small changes to the design if you want anyway. For example, we have chosen a style and now we can change the layout or the color scheme, but the overall style will remain the one we have previously selected.
Of course, this applies to any type of chart. As you can see, there are similar styles for the pie chart also. This is definitely the fastest way to create visually beautiful charts.
But being beautiful is not enough. We have to consider the accessibility of our charts as well in order for them to be comprehensive for everyone. One way is to choose our color scheme carefully to help those that have any color impairment. The best way is to add a detailed alternative text for our chart. For example, for the pie chart, we right-click on the chart and select Edit Alt Text. We can then add the alternative text. A pie chart of the Dell company sale for months January to April.
We could provide even more or even less detail according to our needs. This concludes this course for the best and fastest ways to stylize our sheets and make them more accessible.
And now comes the time we know you have all been waiting for. Learning the basic features of Excel is interesting enough, but what makes Excel what it is are its functions. We will learn how to use 8 of the most common functions in Excel.
Obviously, we will start with a sum function that helps us sum cells.
And we will continue with the average and mean and max functions.
Then it is time for the count functions and its siblings, COUNTA and COUNTBLANK functions.
And we will not forget the if function. This one brings logic to our worksheets. You will love it. So let's start learning.
Next, we're going to discuss about functions, and more specifically, the sum function. Functions can provide a quick and easy way to make calculations, especially long ones. Let's see an example. Our worksheet displays some electricity, telephone, and water bill amounts. Suppose we want to display the sum of these expenses in cell D10. As we've already mentioned, we have to start with equals and then type the cell references. We'll have to type D6 instead of 50 plus the next reference, D7, plus the next reference, D8. Then we press enter so that Excel displays the result, which is €160.
This is one way, but it's not fast enough, especially if we have lots of amounts to calculate. So let's see another example. We go to the next sheet. Our worksheet here displays the sales of January, February, March, April, etc. for the year 2019. Suppose we have to calculate the sum of January sales. There are too many cells to calculate, therefore we are going to need quite a lot of time just to type them. Not to mention we will certainly make mistakes during typing. Excel provides us with a faster way of summing. This faster way is called functions.
Specifically, the function that calculates the sum, which is the sum function. Let's go to the next worksheet called sales. It displays the sales of 3 companies for the next 4 months. In cell C7, we're going to use a function that calculates the sum of January sales. In this cell here, we'll have to type equals first, as we do when typing formulas, and then we type the name of the function, sum. Then, enclosed in parentheses, the cell references or the cell range from where the function will derive data. What we want to do is calculate the sum of January sales. Therefore, the cell values we're going to need are these ones, C3 up to C5. So up to is denoted by the colon mark. So until now we've typed equals sum C3 up to C5 enclosed in parentheses, and by pressing enter, Excel will return the result, which is 30. The formula bar here will also display the function we've just typed.
Let's look at another example. Suppose we want to calculate in this cell H3 the total sales for the company Della. So we come to this cell and we select it. Instead of typing the function, we can go to the Formulas tab and from the list of options Math and Trig, which means mathematical and trigonometric functions, we can select the sum function, which is down here. Excel automatically filled in the function name and opened the window as a guide for completing the function. This method is especially useful when learning functions because at the bottom of the window it contains a brief description of the function and attributes that we need to fill in. In our example, let me move this window a bit. In our example, in the position of the first field, we will enter the cell area we are interested in. We can either enter the cell area by typing it or by selecting it with our mouse and let Excel complete it. We select the cell area C3 up to F3. We see that it has been filled in automatically in the field as well as in the formula bar. We click on OK and Excel returns the result, which is 50.
So functions work like this. We type equals in the cell we want to display the sum, and then the name of the function. After that, the cell area from where Excel will derive data enclosed in parentheses. The cell area will always form a rectangle. In the case of January, it was this one. In the case of data sales, the cell range was this one.
If we wanted to calculate the sum of sales for all 3 months and for all 3 companies, we should have selected this cell area here, C3 up to F5.
So we have learned how to use our first function, the sum function. Next, we're going to learn about 3 more very useful functions: the average function, the min function, and the max function. The student's worksheet displays Despina's, Kostas's, and Stelios's grades on physics, literature, and mathematics. Well, suppose we want to display the average of Despina's grades in cell G4. The function we're going to use is called average. Just as we've done with the sum function, we start with equals, and then we type the name of the function. And then, enclosed in parentheses, the cell range from where Excel will derive the necessary data. So we type C4 up to E4 and then press enter. Excel will return 16. 16 is the average of 15, 16 and 17. Now we'll have to do the same for Kostas and Stelios.
But we already know how to use the fill handle. Therefore, we are going to bring the mouse pointer to the fill handle, and holding the left mouse button down, we drag downwards. Excel will then display the average of Kostas's and Stelios's grades.
The next example we're going to discuss is more complicated. So let's navigate to the 2019 worksheet. It displays the sales of 2019 for every month of that year. What we want to do is display the total of January sales in cell B18. Therefore, we're going to click into the cell, type equals, the name of the function, sum, and then, enclosed in parentheses, we type the reference of the first cell in the range, this is B4, colon, and the reference of the last cell in the range, this is B15. Then we press enter, and the total of January sales is 1,315 cars.
In the next cell, we're going to type the average function to produce the average of sales. So we type equals average, which is the name of the function, and then again the cell range B4 to B15. We close the parentheses and press enter. The average is 109.58 and 33.
Now we're going to learn about 2 more functions. The one that returns the maximum and the one that calculates the minimum value within a cell range. Suppose we want to display the highest sale value in January. We select the cell, type equals, and then the name of the function, that's max. Then we simply type the cell range once again, which is the same, B4 up to B15, enclosed in parentheses, and press enter. The maximum sales value is 175 and it's displayed in this cell here. In the same way, we're going to use the next function to display the minimum value of the cell range in this cell here. Therefore, we select the cell, we type equals, and then the name of the function, min. We open a parenthesis and type the cell range, B4 up to B15. We close the parenthesis and press enter. The minimum sale is 60 and it's displayed in here.
As before, we can use the fill handle to fill in the values for the remaining months. Instead of doing it for each cell separately, we will do it for all of them at the same time. We select the cell range B18 up to B22. We click on the fill handle and drag it right up to column M. All values were completed for all months.
So we've learned how to use 3 more functions: the average, the mean, and the max functions. Let's continue our functions journey with count, COUNTA, and COUNTBLANK functions. The D4 up to D9 cell range contains 3 numbers: 12, 14, and 56. An empty cell, a date, and a cell will displays an error message.
If we click onto it, we'll be able to see that we have typed a division by 0, that's why we are receiving an error message.
The count function returns the number of cells within a cell range which contain numerical data.
There are 4 cells that contain numerical data in the cell range D4 up to D9. These are 12, 14, 56, and the date. The date is just a number as far as Excel is concerned.
Let's use the count function in cell D10 to see how it works. We type equals, the name of the function, the cell range D4 up to D9 enclosed in parentheses, and then we press enter. So Excel has returned the result. This is the number 4. That's 1, 2, 3, 4 cells containing numerical data.
For the COUNTA function now, it returns the number of cells in a cell range which contain something, anything, any kind of data.
So we're going to use the COUNTA function in cell D11. We type equals again, the name of the function, the cell range D4 up to D9, and press enter. Excel returns 5. This means that there are 5 cells in the cell range D4 up to D9 that contain some data. They aren't empty. This one, this one, this one, this one, and this one.
The cell D6 is the only empty one.
The COUNTBLANK function can help us count the empty cells within a cell range. Our screen is currently displaying a worksheet. As we can see, there are several numbers as well as empty cells in column A. The count range will be A1 up to A167, and we're going to display the total of empty cells in cell C15. Let's type equals, the name of the function, the cell range enclosed in parentheses, and then let's press enter. The result is 23. This means that there are 23 empty cells in the A1 up to A167 cell range.
If you want to use these functions from the Formula tab of the ribbon, then you will find them in the Statistics Functions group, which is here. You click on the More Functions, Statistical Functions, and there you will find Count, COUNTA, and COUNTBLANK. Although they are not used only in statistics, Excel has categorized them in there.
So, these were the 3 functions, count, COUNTA, and COUNTBLANK. Next, we'll see how the if function works. Our screen is displaying a worksheet that illustrates the name of students, their grades, and a piece of text in the result column. If the student earns the grade equal to or higher than 10, the respective cell in the result column will display the text pass. Otherwise, it will display the text fail. So Smith failed and Jones failed too. On the contrary, Black and Richards have passed because their grade was higher than 10.
However, this is a text that we have typed ourselves. What we need to do is use the if function so that Excel automatically returns the appropriate text. We're going to delete the contents in these cells and use the if function to have the same result.
Let's see how the if function works. Like all functions that we've explained so far, it starts with typing equals. Then we type the name of the function and the function arguments enclosed in parentheses. The if function requires 3 arguments. This is the first one, this is the second one, the text pass in this case, and this is the third one, the text fail. Arguments should be separated by commas.
Sometimes, depending on the localization settings of the Excel application, you may need to use semicolons instead of commas. If you are not using the proper argument separator, Excel will return an error message.
Now, let's take a few moments to understand arguments better. The first argument is to check whether a condition is satisfied or not. The condition, in our case, is whether the grade present in cell C6 is greater than 10 or not.
So this condition is our first argument. It is checking whether the value displayed in cell C6 is higher than or equal to 10. If the condition is true, Excel will return the second argument. That's the text pass. If the condition is not true, as in the case of Smith and Jones, Excel will return the third argument, fail.
We will type the if function in cell D6. So we're going to select the cell and type equals if C6 greater than or equal 10, comma, and we type the second argument. This is pass. And then we type the third one. This is fail. When the arguments are text, we have to enclose them in quotation marks. We close the quotation marks and the parentheses, and we press enter. So Excel returns the text fail.
Smith has a grade of 9. Therefore, the check is not satisfied because 9 is lower than 10. That's why Excel will return the third argument, which is fail.
The next thing we're going to see is how to use the fill handle to copy the function to the rest of the students. So, as soon as the pointer takes the form of a black thin cross, we drag downwards, holding the left mouse button down.
Excel displays the text pass for black because the condition is satisfied, 18 is higher than 10. Jones failed because his grade is lower than 10. And Richards passed because his grade is higher than 10.
We'll continue to the next sheet to see another example using the if function. Our screen is currently displaying a worksheet illustrating 2 sports teams, Real and Inter, as well as the points they have gathered during the championship. So, as we can see, Real has gathered 40 points and Inter has gathered 36 points so far. What we want to do is display the name of the team which has gathered the most points in this cell here, cell C14.
So we'll have to type equals, if, open the parentheses, type the first argument, D5 greater than D6, if D5, which corresponds to the points of Real, is greater higher than D6, which corresponds to the points of Inter, then Excel should return C5, which corresponds to the text Real. If D5 on the other hand isn't higher than D6, Excel should return C6, which corresponds to the text Inter.
So we bring the mouse pointer to the cell C14 and type equals first and the name of the function if D5 greater than D6, comma, C5, comma, C6. We close the parentheses and press enter. So the cell is now displaying real because real has gathered more points than inter.
Suppose you have made a mistake. We bring the mouse pointer in real's points and type, for example, 30. As soon as we press enter, the text displayed in cell C14 will change. Now inter has gathered more points than real. This is why the if function you have entered in cell C14 is returning the text inter.
If is probably the function you will use more often than any other. So the fact that you've just learned how to use it properly is very important.
Let's talk about the LEN function. This function calculates the length of a string. Its only parameter can either contain the string in question or contain a reference to the string.
In our sheet, we have a table with some text in the cells of its first column. In the first row, we will calculate the length using the text itself, and in the second, we will use a reference to the cell with the text. We select the cell with the first text and copy it from the formula bar. We select all of it and click on Copy. We go to the second column and type the equal sign and then the LEN function. Inside the parentheses, we add double quotes and paste the text we had copied. We hit Enter, and here's the result.
The process is even easier if we use a reference. Again, in cell B3, we type the equal sign, the name of the function, open the parentheses, and inside we select the reference of cell A3. We close the parentheses, hit on enter, and we are done. Now if we want, we can sort the table from the shortest to the longest text. We click on the column with the lengths and sort it from smallest to largest.
Let's talk about two functions that can help us generate random numbers: the rand and the RANDBETWEEN functions.
There are a lot of ways a random number generator can be used in Excel. In the current sheet, we see one such example. We had a competition with a lot of participants and we want to pick a winner. There are 20 participants, so we need a random number between 1 and 20. If we enter a number in cell D2, the name of the participant with that number will appear inside cell D6. If I type 1, for example, Lela Crawford will appear. If I type 2, Ramona Blair will appear, and so on.
But this is not what we want. To be fair, the number must be a random number. Let's see two ways to achieve this. We will begin using the function rand. Let's see what it does. We type equals and the name of the function. The rand function takes no arguments. We click on enter and we see a decimal number. Rand returns a random decimal number greater than or equal to 0 and less than 1. Since this is not an integer number between 1 and 20, there is no winner. We can multiply this by 20. Since the minimum value that rand returns is 0, 0 multiplied by 20 is 0. So the minimum number of the formula will be 0. Also, since the maximum value of rand can never be the number 1, the multiplication by 20 can never be the number 20. But we need a value between 1 and 20. we need to offset our result by 1. So we add 1 to the formula, and now we will have a random decimal number greater than or equal to 1 and less than 20.
As you can see, we still don't have a winner. This is because this returns a decimal number, but we need an integer number. Luckily, Excel has a function for this also. The function that returns only the integer part of a decimal number is called int. We enclose our formula in an int function and we have a winner, Ramona Blair.
The random number is calculated again every time the sheet is calculated. So, if we press the F9 key on our keyboard, or from the Formulas tab the Calculate Now button, this number will change.
So, in order to be fair in a live broadcast of the roll, we would have to type the function live, this function here, and keep the first result it will bring. Alternatively, you could create a macro that could type the formula for us and link it to a button on the sheet or on the ribbon, but this will be covered in another video.
The formula we have used works just fine, but Microsoft provides an easier way to achieve the same thing, the RANDBETWEEN function. Let's delete the formula we have typed in cell D2. We will replace it using RANDBETWEEN. RANDBETWEEN takes two integer numbers as arguments. The first one is the minimum integer number and the second the maximum integer number. It then returns a random number between those two. So in our case we type 1 as minimum and 20 as maximum. And once again we have a winner.
Keep in mind that every time the sheet is calculated, the random number changes and so is our winner. For example, let's say that in cell D3 I type a simple mathematical formula, 1 plus 1. The moment I hit enter, Excel calculates my formula, but it also regenerates a random number, thus changing our winner. There is, a lot of times, the need to create a list of sequential numbers. For example, in the table of the current sheet, we want to add sequential ID numbers for each student. We know that in this sheet we can see the grades of 70 students. We want to add sequential ID numbers in the form 101, 102, and so on. One way is to type in the first two rows the values 101 and 102, and then select them and use the fill handle by double-clicking it to fill all the rows with the proper ID numbers.
This works very well, but it doesn't give us any control. It automatically fills all the rows of the table with data, replacing any data already there. There is a function that does the same thing and gives us absolute control, the sequence function. Let's go to cell A4 to type it and see how exactly it works. We type the equal sign and the name of the function, sequence. The function takes 4 arguments. First is the number of rows we want our list to populate. In this case, we have 70 students, so we type 70. Next, the number of columns. We only need one column, so we type 1 or just skip this argument. Since this is an optional argument, skipping it sets the argument to the default value of 1. Next, we have 2 more optional arguments. They both will default to 1 if skipped. The first one defines the start number of our sequence. In our case, this is 101. And the last argument sets the step, the amount to increment each subsequent value in the array. We want this to be 1, so we can skip it if we want to. Hitting enter fills our column with the required values.
This function belongs to a new kind of functions added to the latest Office version. These functions spill their results to the other cells. If we click on the other cells, we can see that the value in the formula bar is grayed out. If we change this value, for example, write a number and hit enter, our list vanishes and the spill error appears in cell A4. This error means that the spill range isn't blank. If we delete the value we changed, our list appears again. Let's create a new sheet to try one more example.
In this new blank sheet, we want to create a sequential array of numbers that will populate an area 6 columns wide and 10 rows tall. This area should start in cell A1. So, we go to cell A1 and type the function name. We use 10 for rows and 6 for columns. Let's say we want to randomize our list a bit. We want it to start from a random number between 10 and 20. So we type the RANDBETWEEN function with the first argument set to 10 and the second to 20. We want to randomize it even more by selecting a random number as the step. We want the step to be a random decimal number between 0 and 1. So the rand function is the one we need. We hit enter and we have our random sequential array of numbers. Let's take a look at it. The lowest value is the one on the upper left corner of the cell area, while the greatest number is at the lower right of the area. In each row, the sequence goes from the left, which contains the smaller number of the row, to the right, which contains the largest number of the row.
Every time we calculate the sheet, either by hitting on F9 or by going to the Formulas tab of the ribbon and click one of the Calculate buttons, the Calculate Now or the Calculate Sheet, our sequence changes.
The sequence function is a very welcome new addition to Excel, and along with its other spill function siblings, they extend Excel's functionality to new levels.
Excel has provided us with several functions to help us make sense of huge pools of data. SUMIFS is one of them. In the current worksheet, you can see a small example of the data we need to handle. This is the sales of a company for the year 2015. We have the date of the sale, the salesman, the district at which the sale took place, the kind of sale, bulk or retail, the type of the product. Here we only differentiate the products by color, the units sold, the price per unit, and the gross total of the sale. Of course, at a normal working environment, this data would only be a tiny fragment of the actual data I would have to analyze. We have already calculated, using SUMIFS, the sum of the gross total of the retail sales to the Eastern District in cell J6. Without SUMIFS, such an automatic calculation would be impossible, and the manual one would require several work hours. Let's suppose now that we need to calculate the sum of the gross total of the bulk sales to the Western District in cell K6 using SUMIFS. We select the cell, we type the equals character followed by the function name, SUMIFS, and the left parenthesis. Then we enter the cell area we need to sum. In our case, the area from H2 to H43. After that, we define the cell range of our first criterion. In our example, this is the column of the kind of sale, from D2 to D43. Following is the criterion for this cell range. In our case, the criterion is that the type of sale is bulk, so we type inside double quotes equals bulk. We should note here that we can omit the equal sign if we want. Then we proceed to our next criterion. First we pick the cell range, in our case cell range C2 to C43, which is the district, and then the criterion, which is the Western district. So we type West. Take note that we chose not to use the equal sign now. Our function is ready, and if we close the parentheses and press enter, we will see the result, which is $7,000. Following the same syntax, we can use up to 127 criteria ranges and criteria in a SUMIFS function. Let's see one more example in cell L6. Here we have to calculate the sales of under 100 units of black products. So we type our function equals SUMIFS. We select the sum range as before, and then our first criterion. We select the number of units sold, and the criterion in our case is less than 100. We cannot omit the less than sign, since this is only valid for the equals sign. We proceed to our next criterion, which is the color. So we select cell range E2 to E43, and then it's time to type the black color. We type black, close the parentheses, and press enter. This is our desired result. This concludes our lesson on SUMIFS. When you're working in statistics, Excel can be a powerful ally. In statistics, there are various ways to measure the average, or more appropriate, the central tendency of a range of numbers. Excel implements 3 of them. First is the arithmetic mean measure of central tendency, which is the sum of all the numbers in the data divided by their count. This is the most commonly used in all the areas of life and science, and not just statistics. In Excel, it is represented by the well-known function average. In our sheet, we can see 2 sets of numbers, here and here. The average of these numbers is 27, as you can see in the bottom also. The average of these numbers is approximately 29. This average is calculated by summing all those numbers and dividing the sum by their count. Next is the median measure of central tendency, which calculates the value that separates the higher half from the lower half of the dataset. For an odd set of numbers, the median is the number in the middle of a sorted set. For an even set of numbers, it is the average of the two numbers in the middle. The Excel function is called median as well. In our example, the median of this set of numbers is 20. We can see that 20 has been calculated by the median function. This practically means that in this even set of numbers, there are 6 numbers on the left and 6 numbers on the right. They are sorted in ascending order, and the median is the average of the two middle numbers. When we have an odd set of numbers, as you can see on the lower part of our sheet, we have 6 numbers from one side, 6 numbers on the right side, and 1 in the middle. The median then is the middle number. Lastly is the mode function, which implements the mode measure of central tendency. It calculates the most frequent value in the dataset. We will see more about mode in the next sheet. Here we have the exam results of a student from January to December. We will calculate the average, the median, and the mode in their respective cells. In cell B9, we calculate the mean average. We use the average function, followed by the cell range we want to calculate. We close the parentheses, click on Enter, and we have the mean average. In cell B10, we will calculate the median. Equal sign, the name of the function, again our cell range, and we click on Enter. This is the median of our grades. Lastly, in cell B11, we will use the mode function to acquire the last measure of central tendency. The mode function comes in 3 variations. It's the simple mode function, which is only available for compatibility, the mode mult, that returns a vertical array of the most frequently occurring or repetitive values in an array of range of data, and the mode single, that returns the most frequently occurring value in an array or range of data. We're going to use this variation of mode since we want to return the most frequently occurring grade in our range of data. We click on Enter. Notice the difference between the first two and the last measure of tendency. If the values, the grades in our example, are not symmetrically distributed, these variations in the results are very common. The mode is here 3 because the most common grade found, as you can easily see, is 3. In such an example, the logical central tendency measure to use is average because it gives us the average grade of the student. The other two central tendency measures are used in different circumstances in statistics. Excel has provided us with several functions to help us make sense of huge pools of data. AVERAGEIFS is one of them. In the current worksheet, we can see a small example of the data we need to handle. This is the sales of the company for the year 2015. We have the date of the sale, the salesman, the district at which the sale took place, the kind of sale, bulk or retail, the type of the product. In this example, we only differentiate the product by color, the units sold, the price per unit, and the gross total of the sale. Of course, at a normal working environment, this data would only be a tiny fragment of the actual data we would have to analyze. We have already calculated, using AVERAGEIFS, the average of the gross total of the retail sales to the Eastern District in cell J6. Without AVERAGEIFS, such an automatic calculation would be impossible and the manual one would require several work hours. Let's suppose now that we need to calculate the average of the gross total of the bulk sales to the Western District in cell K6 using AVERAGEIFS. We select the cell and type the name of the function, followed by a left parenthesis. Then we enter the cell area we need to calculate, in our case H2 to H43. After that, we define the cell range for our first criterion. In our example, this is the column of the kind of sale, from D2 to D43. Following is the criterion for the cell range. The criterion is that the type of sale is bulk. So we type inside double quotes equals bulk. We should note here that we can omit the equal sign if we want. Then we proceed to our next criterion. First we pick the cell range from C2 to C43, and then the criterion, which is the Western District. Take note that we chose not to use the equal sign now. Our function is ready, and if we press enter, we will see the result, which is $1,200. Following the same syntax, we can use up to 127 criteria ranges and criteria in an AVERAGEIFS function. Let's see one more example in cell L6. Here we have to calculate the average of the gross total of the small sales of products with color name starting with the letter B. As small sales, we consider all sales under 100 units. We type our function, as before, the average range, and our first criterion range. In this example, it is cells F2 to F43, 43, sorry. We type the criterion, which is less than 100. We cannot omit the less than sign, of course, since this is only valid for the equal sign. We proceed to our next criterion, which is the color, cell E2 to E43. Let's note here that we have to use wildcards to our criterion. We use B, followed by the asterisk, which includes both colors blue and black in our current example. close the parentheses, we press Enter, and we have our result. This concludes our lesson on AVERAGEIFS. Excel has provided us with several functions to help us make sense of huge pools of data. COUNTIFS is one of them. In the current worksheet, you can see a small example of the data we need to handle. This is the sales of a company for the year 2015. We have the date of the sale, the salesman, the district at which the sale took place, the kind of sale, bulk or retail, the type of the product, we differentiate the products only by color, the units sold, and the gross total of the sale. Of course, at a normal working environment, this data would only be a tiny fragment of the actual data we would have to analyze. We have already calculated, using COUNTIFS, the count of the gross total of the retail sales to the Eastern District in cell J6. Without COUNTIFS, such an automatic calculation would be impossible and the manual one would require several work hours. Let's suppose now that we need to calculate the count of the gross total of the bulk sales to the Western District in cell K6 using COUNTIFS. We select the cell and type the equals character followed by our function, COUNTIFS, and the left parenthesis. We define the cell range of our first criterion. In our example, this is the column of the kind of sale, from D2 to D43. Following is the criterion for this cell range. The criterion is that the type of sale is bulk, so we type inside double quotes equals bulk. We should note here that we can omit the equal sign if we want. We proceed to our next criterion. We pick the cell range C2 to C43, and then the criterion, which is the Western District. We type West. Take note that we chose not to use the equal sign now. Our function is ready, and if we close the parentheses and press Enter, we will see the result, which is 6. Following the same syntax, we can use up to 127 criteria ranges and criteria in a COUNTIFS function. Let's see one more example in cell L6. Here we have to calculate the number of small sales, under 100 units, of black products. We type our function followed by a left parenthesis, and our first criterion range. In this example, a cell range from F2 to F43. Then we type the criterion, which is less than 100. We cannot omit the less than sign, of course, since this is only valid for the equal sign. And then, as before, we proceed to our second criterion. Let's note here that we can use wildcards to our criteria. For example, we could, instead of black color, need the count of all the products with color starting with the letter B. Let's suppose that this is the case. We select cell range C2 to E43 for color, and then we type B followed by an asterisk. This would select all colors starting with B. But this is not what we need in our current example. So we type black instead, close the parentheses, and press enter. The result is 14. This concludes our COUNTIFS lesson. The need to determine the maximum and the minimum values of a range of cells is common to almost all types of Excel projects. But in statistics, the min and max functions are not enough. We need to calculate, for example, the third largest or smallest value of a range of cells. Luckily, Excel provides with functions to do just that. In our current sheet, we can see a list of products with their prices. We have already calculated the third smallest value and the third largest value using the small and large functions of Excel respectively. The large function returns the kth largest value from an array of numeric values, and the small function returns the kth smallest value from an array of numeric values. Their syntax is straightforward. Let's calculate the 10th largest value in this cell. We type the name of the function, the array of our data, which is the array of prices, and k is the index of the largest value we need to calculate. In our case, we want the 10th value, so we type 10. The 10th largest value is 340. In our previous example, we used 3 because we wanted the third largest value, and the number was 878. Let's calculate the smallest value. In the first example we have already calculated, we type the name of the function, the array of data as before, and 3 as k, which is the index of the smallest value we want. We go to calculate the 10th smallest value. Again, the name of the function, the array of our prices, and k, 10. We click on enter, and we have the result. We should make sure that all the numbers in the cell range are numeric values and not text presentations of numbers. If this is the case, the functions might produce the wrong result since they ignore text values. They might even throw an error if there are no numeric values or the actual numeric values are less than the index supplied. For example, we wanted the 10th largest value. If all of these numbers were text values, there wouldn't be a 10th largest value since text numbers are ignored and an error would be thrown. We can see in this cell this error. It informs us that this cell is formatted as text, which means our functions ignored it. Let's correct the formatting to number. And convert text to number. We can see that the largest values we have previously computed have changed. Pretty easy, isn't it? In statistics, the quartiles of a ranked set of data values are the 3 points that divide the set into 4 equal groups. Each group constitutes a quarter of the data. The first quartile is the middle value, or the median, between the smallest number and the middle number of the dataset. The second is the middle number of the whole dataset, and the third is the middle value between the middle number and the highest number of the dataset. So, the first quartile is at the 25% of our population of numbers, the second at the 50%, and the third at the 75%. Excel, since its 2010 version, implements 2 methods of calculating quartiles: the quartile inclusive and the quartile exclusive. Let's try to explain the difference between them. In this example, we have a group of 12 numbers in ascending order. Here, 12, and the same 12 here. The inclusive function uses the n-1 method to calculate the quartile's position. N is the total numbers we have, which is 12 in our example. So n-1 equals 11. If we multiply 11 by 0.25, we find the position of the first quartile, which is 2.75, which means that the first quartile is in the position 2.75. Here we have the interpolation basis where we can see the position of each number. 2.5 is somewhere around here. Notice that the inclusive quartile, we start the position numbering from position 0, while in the exclusive quartile we start from position 1. Using the same technique, we can calculate the second and the third quartile. n-1, 11, multiplied with 0.5 gives us 5.5, 5.5. This is the position of the middle quartile. Same for the third quartile. n-1, 11, multiplied to 0.75, it gives us 8.25, somewhere around here. Using simple mathematics, we can calculate the number in each position, 11 for the first quartile, 19.5 for the second, and 49.25 for the third. How exactly we did this? Let's calculate the first one. Our starting position, the end of position 2, is 8. To find the number in this position, we have to add a number to 8. This number is calculated by the difference of the two numbers, 12 of the two positions, 12 minus 8, multiplied by the percentage of the quartile position between them. Since the position is 2.75, the quartile position is 0.75 between them. So we multiply this by 0.75, we click on Enter, and we see that it provides us with 11. The same for the other numbers. The exclusive version now uses the n+1 method to calculate the quartile's position. So since n is 12, n+1 is 13. We multiply this to 0.25 or 0.5 or 0.75 to get its position. As we have said before, all the numbers are shifted one place to the right. This places the first quartile between numbers 8 and 12, as before, but a different relative position between them, at 0.25, instead of 0.75 we saw before. That is why the number in this position is 9 instead of 11. The same applies to the rest of the quartiles. The exclusive version of quartile does the heavy lifting and calculates the quartiles using this method. Let us try to use these functions in the following example. In this sheet, we can see all the grades for all the lessons of a student from January to December. Suppose we want to calculate the third quartile for all the grades of all the lessons in the table. This means that if our dataset were all the grades of the student, we want to calculate the number in this line. Let us try the inclusive quartile first. We type the name of the function, the array of our data, and 3 for the third quartile. We click on Enter, and we have the number we're looking for. We repeat the same procedure using the exclusive version. We type the name of the function, the array of our data, and the third quartile, as before. We click on Enter. We notice the difference of the results is small, but there is a difference. For compatibility reasons, the older quartile function is still supported at the 2016 version of Office. Let us see what number this function will produce. The array and the third quartile. We click on Enter. We can see that the old quartile function gives us the same result as the inclusive version of its function. We mentioned before that the quartiles reside at the 25, 50, and 75% of our population of numbers. What if we want to calculate the point of the 90% of our dataset? In this case, we use the percentile function. It too offers an inclusive and an exclusive version. It works similar to the quartile function. The inclusive version follows the n-1 rule and the exclusive the n+1 rule. We use the same dataset as in our previous example, and we have marked the 90% line for both the versions of the function. How exactly does it work? The inclusive version of the function uses the n-1 rule, as we have said before, and multiplies it by the percentage we are looking for. So, n-1 is 11, since n is 12, multiplied by 90% gives us 9.9. This is position 9, this is position 10, 9.9 is somewhere here, as we have marked. And we can see that we have used the percentile inclusive method to calculate exactly what number resides here, similar than the math we have used in the previous example. Same for the exclusive version. It follows the n+1 rule multiplied by the same percentage. So n is 12 plus 1 13 multiplied to 90%, it gives us 11.7. So the position is somewhere between 11 and 12, exactly here as we have marked. Again, using the percentile exclusive version, we have calculated the number that resides here. Let's see a more practical example. In this sheet, we have again the grades of a student for all lessons from January to December. We want to calculate the 70% percentile for this dataset. First, we will use the inclusive version. The array and the number k, which is the percentage we want the percentile for. So we type 70%. We click on enter and we see the 70% percentile. Now we will try the exclusive version. Again, the same array of data and the same k. We can either type 70% or 0.7. It is the same. We click on enter. 7.32. We notice that the difference in the results is small, as in the quartile functions. For compatibility reasons, the old percentile function is still supported in Office 2016. Let's see what result this function will give us. We can see again that the function offers similar result to the inclusive function of percentile. It is preferable to avoid using the old functions, both percentile and quartile, because they might not be supported in future versions of Excel and could cause compatibility issues to your spreadsheets. There are close to 10 different methods of calculating quartiles and percentiles, which provide most of the time different results, as we have seen in our examples. There is no agreed standard way for calculating them, but the exclusive method, seen here, is the most commonly implemented and used. One of the most useful measures in statistics is that of standard deviation. It is a measure that is used to quantify the amount of variation or dispersion of a set of data values. I'll try to explain what this means with an example. In our current sheet, we can see the exam results of a student for all exams he has taken during this year. These numbers are our population of numbers. The average of these numbers, of these grades, is 6.5. We have used the average function. And the standard deviation is 1.5. Let's assume that the student in question has to take one more test tomorrow and we have to guess what its grade will be. it would be safe to say that he would be graded somewhere around his average grade. This is where standard deviation kicks in. It defines approximately how much around the average value we would expect the new value to be. So, in our example, the expected grade is more probable to be between the range of 5, which is produced by 6.5 minus the standard deviation, and 8, which is derived by adding the standard deviation to our mean average. When we have only a sample of the data from population, then the standard deviation calculated is called sample standard deviation. So if we only had the grades for January and February, then our standard deviation would be called a sample standard deviation. But since we have all the grades for all the months of the year, our standard deviation is called population standard deviation because we have the whole population of data. Excel has 6 functions to calculate standard deviation. 3 of them calculate the sample standard deviation, and 3 the population standard deviation. Although STDEV and STDEV.P can still be used in Office 2016 for compatibility reasons, they have been replaced by STDEV.S and STDEV.P, respectively, and should be avoided, since they might not be supported in future versions of Excel. STDEV.S calculates the sample standard deviation and the STDEV.P the population standard deviation. The above 2 functions also calculate sample and population standard deviation, respectively, but their difference to the previous function is to the way they treat logical values and text when they are part of our population. STDEV.S and .P ignore text and logical values, while STDEV.A and STDEV.PA count text as value 0 and logical values as 1 for true and 0 for false. Let's see an example. In this example, we still have the grades of a student for all his exams from January to December, but we have some small differences. In one of the exams, the cell where the grade was supposed to be, we have a sick value, which is text and is put there to inform us that the student was sick at the day of the exam. And the other one is the logical false value, where false means absence, that the student did not come there or called in sick. In cell B9 we have our mean average, and in cell B10 we will now calculate the population standard deviation. Since we have all the grades for all the months, we can easily calculate the population standard deviation. In cell B10 we will use the STDEV.P function, and in cell B11 the STDEV.PA function. We type the name of the function and select the dataset. We should note here that the values of sick and false, which are text and logical values, are ignored using STDEV.P function. We click on Enter, and we have the standard deviation of 1.5. We repeat the same procedure with our next function. We select our dataset and we click on Enter. You see we have a different number here, since this function calculates the values seek and false as 0. Seek because all text values are considered as 0 for this function, and false because the logical value false is considered again as 0 for this function. If there were no such values in our table of grades, these two functions would produce the same result. Let's assume, for the sake of this example, that we only had the exam grades for months from August to December. That means we would only have a sample of the whole population. So in cells B12 and B13, we will calculate the sample standard deviation for August to December using the STDEV.S function and its counterpart STDEV.A. In cell B12, we type the name of the function, point S, since we have only the sample of the data, August to December, and we click on Enter. We do the same in cell B13 with the other function. The same dataset, a sample of all the population, and we click on Enter. We notice again the difference. Again, if these two cells did not exist, these two functions will return the same result. We can also notice the difference between the two sets of functions, the sample ones and the population ones. Of course, the most accurate are the population ones, which have a larger pool of data. If this was a real-life statistical problem, we should choose to use the functions that consider the absence of the students as 0 graded instead of ignoring them. So we should go with STDEVP-A or STDEV.A. One of the most useful measures in statistics is that of variance. It is a measure that is used to quantify the amount of variation or dispersion of a set of data values. I'll try to explain this with an example. Let's assume this population of numbers. These numbers are the exam grades for a student for months January to December for all the lessons he has taken. The average of these grades, the mean average, is 6.5 and the variance is approximately 2.3. Variance and the mean average are not expressed in the same unit of measurement. To have a comparable measure in the same unit, we have to calculate the square root of the variance. This provides us with a standard deviation. So, if we calculate here the square of the standard deviation using function power, we can see that it provides us with the same number as the variance function. When we have only a sample of the data from a population, then the variance we calculate is called sample variance, and when the data from the whole population is available, then it is called population variance. In our example, since we have all the population of data, we used the population variance version of the function. Here we can see all the 6 functions that Excel has to calculate variance. 2 of them exist only for compatibility reasons and can still be used in Office 2016. They should be avoided though, since they might not be supported in future versions of Excel. The other 4 functions are 2 for calculating sample variance and 2 for calculating population variance. In these 2 first versions of the function, text and logical values are ignored. And in these 2, text is counted as 0 and the logical true value is counted as 1 and logical false as 0. Let's see an example. This example has mostly the same data with some minor differences. We can see the differences here. One exam is marked as sick because the student called in sick and didn't show up, and the other is marked as false, which is another way to say that the student did not show up. We have calculated the mean average, and we want to calculate the variance. Since we have the entire pool of data, our variance is a population variance. So in cell B10, we will calculate the population variance using the VAR.P version of the function. This function ignores text and logical values. Select our pool of data and click on Enter. This is our variance. Pretty straightforward. In cell B11, we will calculate the population variance using the VARP function, which does not ignore text and logical values. We can notice the difference. This difference is due to calculating the text variable as 0 and the logical false as 0 as well. Let's assume, for the sake of this example, that we only had the exam results for months August to December. This means we would have only a sample of the whole population. If this was the case, we would have to calculate the sample variance for August to December. So here, in cell B12 and 13, we will do just that. We type the name of the function, .s, and select the cell range I3 to M6. We click on Enter, and we have the sample variance. Same for the other function. The same cell range. And we click on Enter. Notice the difference. Again, if these 2 cells had numeric values, these 2 functions would return the same result. Notice the difference between the functions that provide the sample variance with the ones that provide the population variance. If this was a real-life statistical problem, we should choose to use the functions that consider the absences of the student as 0 graded instead of ignoring them. So we should go with the VARA and VARP functions. In statistics, covariance and correlation are measures of how much two random variables change together. A positive number would indicate a positive linear relationship between the variables, and a negative number would indicate the opposite. A common, simple example to better understand covariance and correlation is that with a balloon. As a balloon inflates, it gets larger and all its dimensions get larger respectively. The height, the width, and the depth of the balloon increase. This means that in sets of two, these dimensions have a positive linear relationship. So when a balloon inflates, both width and height increase. When we have finished filling the balloon with air, we seal its open end. While sealed, we squash the balloon with our hands in one dimension. Let's assume the width, as shown here. We notice that while the width is decreased, the height of the balloon increases to manage the extra volume of air. This means that when you squash a balloon, the width and the height variables have a negative linear relationship. Correlation, in addition to telling us whether variables are positively or negatively related, also tells us the degree to which the variables tend to move together. Its value can be from -1 to 1. Excel provides us with 3 functions to calculate covariance and 1 for correlation. The COVAR function is still present in Excel 2016 for compatibility reasons. It has been replaced by COVARIANCE.P, and you should avoid using it since its support could cease in future versions of Excel. The COVARIANCE.P is used when the supplied data are the whole population of data, and the COVARIANCE.S is used when we only have a sample of the entire population. To calculate correlation, Excel provides us with the CORREL function. Now that we have a general idea of what covariance and correlation mean and what functions to use, we can go on and put our knowledge to a test. In this sheet, we can see all the exam results of a student for the current year. In cell B8, we will calculate the covariance between physics and mathematics, assuming that our data consists the entire population. We type the name of the function, the first set of data, physics, and the second set of data, mathematics. We click on Enter. We have a positive result, which means that physics and mathematics have a positive linear relationship. When one result is better, chances are that the second one will be better too. Let's assume we only had the data displayed with yellow background, which are only a sample of the entire population, and we need to calculate the covariance between physics and history in cell B9. We will use the COVARIANCE.S function because we only have a sample of our data, and as before, we will enter our 2 datasets, physics and history. We click on Enter. We notice here the result is a negative one, which means that as the exam results of physics and mathematics, as we have seen before, are getting better, the exams in history are getting a lot worse. For your information, if we try to calculate the covariance of physics with itself, select physics twice to calculate the covariance with itself, and then calculate the variance of physics we have seen in the previous lecture. We will see that they are identical. So the covariance between two identical sets is the same as the variance of this set. To compute the correlation coefficient between physics and mathematics in cell B15, we use the CORREL function, providing the two relevant cell ranges. We type the name of the function and the two cell ranges. We click on Enter, and we notice that the correlation between physics and mathematics is a positive number, as it was for the covariance. Next, we will calculate the correlation of physics and history. And you will notice that, as before, this is a negative number. If you calculate the correlation of physics with itself, we will notice that the correlation is 1. So this means that the closer the correlation of one pool of data to another is to 1, the closest the relationship is. There is a lot of math behind covariance and correlation, which surpasses the objective of this lecture. But we have an idea of how to use the functions and what exactly covariance and correlation mean.
Microsoft has released a few new functions for the version 2021 of Excel. These functions have one thing in common. They spill the results to adjacent cells. One such function is the sort function.
In our sheet, we see a table of students. We want this table sorted by the grade in mathematics in descending order. But we don't want to change the current table. We want to copy it in the cell area E1 to G25 and apply the sorting there. We can select all the table, click on Copy, and then go to E1 and click on Paste. Next, we select a cell in column G and click on the Sort and Filter button of the ribbon. There, we select descending order, largest to smallest.
But what happens if we change the grade in the initial table? For example, the grade of Kimberly was mistyped. It should be 7, not 17. This means that now we have to change it in both tables. Luckily, we now have a faster way. Let's delete the values of the secondary table. We will use the sort function. In E2, we type the name of the function. The first argument is our data, the cell range A2 up to C25. Next, we have to select the number of the column we want our data to be sorted by. We want to sort them by the grade in mathematics, which is the third column, so we type 3. Next, we want to select the sort order. Ascending order is designated with the number 1, while descending order is designated with the number -1. We type -1 since we want descending sorting. The next option defines whether we want to sort by column or not. We want to sort by row, so we select false. We click on Enter and our table is sorted, just like before. Let's change the grade of Kimberly to 20. The sorting of the second table was immediately refreshed and Kimberly appeared at the first place.
This function belongs to a new kind of functions which spill their results to adjacent cells. If we click on the other cells, we can see that the value in the formula bar is grayed out. If we change this value, for example, change Kimberly's mathematics grade to 7, then a spill error appears in cell E2 and our table vanishes. This error means that the spill range isn't blank. If we delete the value we had just typed, the table comes back to life. Let's go to the next sheet to try one more example.
In this sheet, we have the grades of 6 students to 5 lessons. We want the students column to be sorted in ascending order by student name. We want the new sorting option to be visible in a copy of the table in cells A8 to G13. We have the headings of the rows already copied there. We select cell B8 and start typing the sort function. The source cell area is B1 up to G6. We want to sort by the first row, which contains the names, so we type 1. We want ascending order, so we type 1 again. For the last argument, we select true, since we want to sort by column. And there it is. Our table has been sorted by column in ascending order.
These are simple examples of how to use the function. But the potential of the sort function, especially in dashboard creation, is limited only by your imagination.
In older versions of Excel, the only way to get the unique values of a table was to either use an advanced filter or remove all the duplicate values. Since Excel 2021, Microsoft has added a new function that helps us get the unique values from a cell area. This is the unique function.
In the current sheet, we have added a list of files along with their sizes. Unfortunately, we have plenty of duplicate entries. We want to extract the unique entries of our table in column D. We don't want to alter or lose any of the original data.
The unique function makes such a task extremely easy. We click on cell D1 and type equals and the name of the function, unique. Enclosed in parentheses, we type the arguments of the function. The first argument is the cell area. We want to search for unique values. We select all our table.
Then we have two more arguments. The first one, let us choose if we want to return unique columns or unique rows. We want unique rows, so we select false. The last argument lets us select if we want to return items that appear exactly once or return every distinct item. We want every distinct item, so we click on false again. We close the parentheses and click on the Enter icon. Our 16 unique values appeared.
This function belongs to the family of functions which spill the results to adjacent cells. If we click on the other cells, we can see that the value in the formula bar is grayed out. If we change this value, all of our table vanishes and a spill error appears in cell D1. This error means that the spill range isn't blank. If we delete the value we have changed, our list appears again.
That was it. An easy and fast way to extract the unique values from a cell range. In Excel, the manipulation and management of data is not limited to complex calculation. It is certain that at some point, everybody needs to alter the form and layout of their data in order for them to be more readable or answer to some specific visual requirements. The ability to transpose our data is such a need. In our example, we can see two tables. These tables are filled with the exact same data. Their only difference is that the rightmost table was produced by the vertical arrangement of the leftmost one. There are two ways to achieve this. Let's go to the next worksheet, which shows the monthly grades of a student for the school year 2014-2015. The data consists of a 12 columns and 7 rows table. Suppose we need the months to be row headers and the courses to be column headers. So we need the table to be 7 columns wide and 12 rows tall. We select an area that fills this criteria. In our example, we will use cell area from N1 to T12. We then type the equal sign and the transpose function. We select the source array enclosed in parentheses, but do not press enter. Let's select the source array and close the parentheses. Transpose can only be used in array formulas. Array formulas is a subject for another lesson, but their common characteristic is that to finish an array formula, you don't press enter, but you press Ctrl plus Shift plus enter at the same time. By pressing this key combination, we see this result. The arrangement of the table has changed. If we alter a grade at the leftmost table, for example the physics grade for September, let's set it to 7 and press enter, we observe that at the same time the same change happens to the rightmost table. These two tables are linked, which is the main advantage of the transpose function. With a closer look at our new table, we can see that it did not inherit the formatting and the style of its parent table. For example, the column color and the row color. This means we will have to stylize the new table from scratch, which in some cases could prove to be a really time-consuming job, especially if we had the formatting rules and the conditions already applied to the parent table. Let's go to the next sheet. Here we will choose a different approach. We select the table and copy it to the clipboard. Then we select cell N1 and from the Paste submenus we select the Transpose option. We can see that all formatting has been preserved. But if we change the grade of physics for September in the leftmost table, for example, let's set it to 7 as before, we will notice that the respective cell in the rightmost table remains unchanged. We have to change the grade manually. So, as you can see, this method makes a copy of the parent array arranged vertically, and the two tables are not linked in any way. This concludes our course on transpose. Probably the easiest to understand lookup function is the choose function. It returns a value from an array of values that corresponds to a specific position in that array. Choose can have up to 254 value arguments. Suppose you want to know the name of student with number 2 and you decide to use choose in cell B9. We type the function name following the equal sign. Then we type the index number, which in our case is number 2, and then we type the values, which in our case are the names of all 3 students. Cells B3, B4, and B5. We close the parentheses and press Enter. Choose will return the second value from the supplied array, which is Mary. I know what you are going to think. Not impressive at all. You are right. Choose shines by helping other functions. By itself is not that impressive, but with a little imagination and the help of some more functions, it can be a powerful ally to your battle with numbers. The main reason for this is that its value arguments can be cell ranges and its return value can be cell reference or a cell range reference as well. Suppose we need the average grade of a student to be calculated simply by providing their identification number, the average grade, and the identification numbers. Choose can help us do that. Let us see how in cell C9. The number of the student we want to calculate the average for is found in cell I2. We have pre-entered the value in I2. In real-world circumstances, this value could be calculated by other parts of our workbook or selected from a drop-down control. Since we need the average, we type the name of the function. Average. And then the cell range of values we want to calculate the average from. We need the average of student 3, so we could just select the cell range C5 to F5, but every time the value in cell I2 changes, we would have to manually recalculate the whole thing. So instead, we will use choose. We type the name of the function and the index number, which in our case is the value of cell I2, and then we type the reference to the cell area of the grades of the first student, the second student, and the third. The first student, the second student, and the third. We close the parentheses and press Enter. We have our result. Now, by simply changing the value in I2, we have a different average. We can improve our sheet more by making sure the name of the selected student is shown in cell B9. In the function we previously typed in cell B9, instead of number 2, we select cell I2. Now, every time the value in I2 changes, the cells B9 and C9 show the name and the average score of the related student. Of course, there are plenty of ways to do the exact same thing in Excel that are probably more productive, but this was just an example for you to see how combination can completely change the role of a function and its usability. One of the most interesting uses of choose is the ability to add extra functionality to the VLOOKUP function. We will show this on the lesson about the best lookup function to use. There are plenty interesting uses of choose that one can find with a little search, and even more with a lot of imagination. The index function is one of the most interesting functions in Excel. It can be combined with many other functions to help you out of some difficult situations. Let's start with the basics. It comes in two formats, an array format and a range format. The array format looks up a reference to a cell within a single cell range. Suppose you want, in our example, to calculate in cell C9 the grade of student 2, Mary, to lesson 3, chemistry. We type the name of the function equals index. Notice the two different formats of the function. Select the cell range that shows the grades and then the row number, in our case 2, and the column number, in our case 3, for chemistry. We close the parentheses and we have the grade for Mary in chemistry. If one of the row or column numbers are set to 0, then index returns the whole column or row respectively. Suppose that we want to calculate the average grade of Mary using index. We alter our formula by setting the column number to 0. Thus making index to return to us the whole second row of data. We enclose all this in an average function like this and press enter. The average grade of Mary. We should note here that we can't set both row and column number to 0 because it would result in an error. It looks rather easy till now and not that interesting. Let's see now the range format of the function. In our next sheet, we can see the grades of the students for all trimesters. Using the range format, we can add to our index function the cell ranges with the grades for each trimester. We will calculate the average grade of Mary for the first trimester in cell C17. We type the average function and inside it we will enclose an index function. For the first attribute of the index function, we have to provide the range. Our range originates from 3 different cell ranges, so we open a parenthesis and provide the 3 different cell areas divided by commas and then close the parenthesis. The first trimester cell range, the second trimester cell range, and finally the third trimester cell range. We close the parenthesis. Then we type the row number, which is 2 for Mary, the column number, which is 0 since we want the whole row, and then, as you can see from the autocomplete, we are required to enter an area number. The area number refers to the cell areas we entered before and is relative to the order we entered them. So, for the first trimester, we enter 1 since we entered it first. The area number is optional, and if skipped, it defaults to 1. So in this case, we could have skipped it. We close the parentheses, and we have the result. The average grade for Mary in the first trimester is 5. If you want to see the average of another trimester, we just change the area number to its respective one. So for the second trimester, we can enter 2, 6.75, so it did better in the second trimester, and for the third trimester, we type 3, 6.5. I told you at the beginning that index is one of the most interesting functions in Excel, and I am sure that you might feel a bit disappointed. Bear with me for a few more lessons. You will then find out that index combined with match make up the best lookup formulas there are, and probably the ones you are going to use every time. I know I do. We have already mentioned in the previous lesson the match function. There is no way to create a powerful and versatile lookup formula without using at least once the match function. Let us see exactly how it works. The match function lookups information from an array of data, just like the choose function we saw in previous lesson. The difference is that the match function returns the position of the lookup value in the array of data. It also allows us to choose if it will return an exact match of the requested value or the closest match above or below the requested value. Let us see how it works. In this sheet, we have a table of fuel consumption per miles. We need to find the position, row number, of the table where the cost is $13 and show it in cell D15. So in this cell, we use the match function. We type the function. For the first attribute, we type the value 13, which is our lookup value. And as a lookup array, we provide the cell range of the cost, which is D5 to D12. Since we need the exact match of this cost, we then select 0 for exact match. We close the parentheses and press enter. The result is 3, which means that the value we're looking up lies on row 3 of the data. In such a small pool of data, we could have easily seen the result ourselves without using the match function. If instead of $13 we searched for 15, the function would produce an error since it is looking for an exact match. Let us see that. In this case, we can change the final attribute of the function to either 1 less than or -1 greater than. If we change it to 1, then the function returns the closest match below or equal to the lookup value. For this to work, the array must be sorted in ascending order. If we set the attribute to -1, then the function will return the closest match above or equal to the lookup value. The array in this case should be sorted in descending order. So we sort the array in descending order. And you see the result is 5, and it represents the closest match above 15, which is 19.5 in the 5th row. Let's see how good match works when searching for a text. We go to our next sheet. We have a list of our colleagues and their birthdays. We want to find the birthday of a friend whose name begins with the letters Y and V and has a double N somewhere inside it, but we don't remember it exactly. Match can help us. In cell E10, we type the function followed by the text we remembered. Y, V. Then type the asterisk character, because we are using wildcards, and then double N, and asterisk again. This is what we remember of the name of our colleague. It starts with Y and V, and somewhere inside there is a double N. Then we select the array of first name, which is the cell range B2 to B37. And for the last attribute, we type 0 since we want the exact match. By pressing enter, we see that the result is 11, and if we go at the 11th row, we will see that our colleague's name is Yvonne, and there is her birthday. Match by itself is a function that a lot of us might think we will never actually use, but in combination with other functions, it is a tool we simply cannot ignore, as we will see on the following lessons. One more very useful Excel function is offset. It returns a range of cells which corresponds to a specified number of rows and columns starting at a given distance from a reference cell. Sounds complicated, but only until you see it in action. In this sheet, we have a table with the sales of a company for the year 2015. Suppose that every day we want to calculate the sum of the 10 largest sales, the ones which produce the greatest income. Sounds easy, we just sum the 10 last values of the total column of our table since it is sorted in ascending order by that same column. Well, that is correct, but it also means that each day when new sales will be added, we will have to do the same thing again. Offset can give us a solution since it can give us the last 10 rows of the total column if we provide it with a total number of rows of data. Since the data changes every day, to know what the last row is requires the use of one more function, the COUNTA function. The COUNTA function counts the numbers on a specified range. So if we use it for a column H, it will return us the count of numbers in that column, thus the total number of rows of data. Let's see this in action. Let's go to cell K2, type COUNTA, and select column H. Press enter, and this is the total number of rows. We keep this number on this cell, and we will use a reference to it on our offset formula for simplicity. Now it's time for the magic. In cell J2, we will use the offset formula to calculate the sum of the 10 largest sales. First, we type the sum function and nested inside it the offset formula. We now have to type a reference cell. This could be any cell in our sheet, but usually you select the first cell of our table, which is A1. Then we type the offset of the first row of our required data range. This is calculated by the value we found before in cell K2, minus 10, since we want the last 10 rows of data. Minus 10. Then we type the offset column. Since we are currently on column 1, the A1 cell, and the data range we need is on column 8, the total column, the offset is 7. 1 plus 7 equals column 8. So we type 7. We have successfully directed our offset function to the beginning of our data range, which is cell H34. Now you only have to set the height to 10. Remember, we need the 10 largest cells, and the width to 1, since we only need the total column. We close the parentheses, both of them, and press Enter. This cell now calculates dynamically the 10 largest sales of our company. Excel provides us with a lot more ways to do exactly the same thing, either with tables or with the index function, but offset has its uses. Even if we decide to use another function for the given example, no one can deny the usefulness of offset, which in combination with other functions can provide elegant solutions to complex problems. We will see on later lessons a very efficient way to look up values with the help of offset. We will continue with the VLOOKUP function. In cell area B4 to D12, we can see the fuel consumption and the cost in dollars for certain distances calculated in miles. For example, for a 75-mile journey, we need 10 liters of gasoline, which cost $13. Let's suppose we want to look up the consumption in liters for a 100-mile journey and show it in cell H14. In such a small pool of data, it is relatively easy to find the proper value and manually type it in the proper cell. Imagine if your data spanned to thousands of rows and columns. Finding out the needed value then could be impossible. This is where Excel's lookup functions provide us with a solution. So, in cell H14, we will use the VLOOKUP function to get the value we need. The VLOOKUP function searches the data of the first column on the left of the cell area B4 to D12 for a value. In our case, it's 100 miles, and returns the value of the cell that can be found at the same row and at the given column of the cell area. In our case, the column is the second one, and so the value is 15. We select the cell and navigate to the Formulas tab. We click at Insert Function and set the category to Lookup and Reference. We locate the VLOOKUP function there and click OK. We can, of course, just type the name of the function after the equal sign. At the Arguments window, we set the values that we are looking for at the lookup value. We select the cell F14, which refers to the distance that we are looking for, the 100 miles. At the field Table Array, we need to define the cell area where Excel will perform the search. This is the cell area B4 to D12. At the argument call_index_num, we define the column number where the liters are displayed. In our case, this is the second column, so we type the value 2. The last field contains only two options, true or false. We can type the number 1 or 0 respectively. If we type the number 0, Excel will only look for an exact match. In case there is no such value, Excel will display an error message. If we type number 1 and there is not an exact match, Excel will find the lower closest match in the first column. In our case, it will be 75. We need to note that in order to use this function with the last attribute set to 1, the cell area needs to be sorted in ascending order by the column, miles, in which you want to look for the value. Since we now need an exact match, we type 0 and click on OK. As a result, the value 15 will be shown, which corresponds to 100 miles, as you can see in our example. If we change the value of the cell F14 to 110 miles, we can see that an error message appears because there aren't any values available for 110 miles. In this case, we should change the last attribute in the formula bar to 1. This will still return us 15 because the lower closest match to 110 is 100. The letter V at VLOOKUP stands for vertical, so VLOOKUP looks for a value, in our case 100, at the first column of a cell area, in our case this cell area, and when it finds it, it returns the value that is found at a cell with the same vertical position and on the right of the first column. In our example, we have asked for the second column. That's why we had the result 15. In case we had asked for the third column, we would have the result $19.5. We will continue with the HLOOKUP function. In cell area B5 to J7, we can see the gas consumption and the cost in dollars for certain distances calculated in miles. For example, for a 75-mile journey, we need 10 liters of gasoline, which cost $13. Let's suppose we want to look up the consumption in liters for a 100-mile journey and show it in cell I11. In such a small pool of data, it is relatively easy to find the proper value and manually type it in the proper cell. Imagine if your data spanned to thousands of rows and columns. Finding out the needed value then would be impossible. This is where Excel's lookup functions provide us with a solution. So, in cell I11, we will use the HLOOKUP function to get the value we need. The HLOOKUP function searches the data of the first row of the cell area B5 to J7 for a value, in our case it is 100, and returns the value of the cell that can be found at the same column and at a given row of the cell area. In our case, the column is the second one and the value is 15. We select a cell and navigate to the Formulas tab. We click at Insert function and set the category to Lookup and Reference, as we have already. We locate the HLOOKUP function and click OK. We can of course just type the name of the function after the equal sign. This is what I usually do. At the arguments window, we set the value that we are looking for, the lookup value. This value is shown in cell G11. At the field Table Array, we need to define the cell area where Excel will perform the search. This is our table B5 to J7. Let's get this out of the way. In the row index num, we define the row number where HLOOKUP will look for the result of the function. In our case, we want the second row, since we want the liters, so we type 2. The last field contains only two options, true or false. We can type either the number 1 or number 0. If we type the number 0, Excel will only look for an exact match. In case there is no such value, Excel will display an error message. If we type number 1 and there is not an exact match, Excel will find the lower closest match in the first column. In our case, it would be 75. Since we want an exact match, we type 0 and click at OK. As a result, the value is 15, as we had expected. If we change the value of the G11 cell to 110 miles and press Enter, we can see that HLOOKUP returns an error, because there aren't any values available for 110 miles. If we change the last attribute to 1, as we explained before, it should return us the lower closest match. In our case, the 100 miles. As it did. Since there are no 110 miles value in our table, it returned the lower closest match, which is 100, and the liters for that, row 2, is 15. The letter H at HLOOKUP stands for horizontal. So HLOOKUP looks for a value, in our case 100, at the top row of a cell area, and when it finds it, it returns the value that is found at a cell with the same horizontal position, which is another cell at the same column of our data area. In our example, we have asked for the second row, that's why we had the result 15. In case we had searched for the third row, we would have the result $19.5. We will continue with the lookup function. The lookup function has two forms, the vector form and the array form. Microsoft proposes not to use the array form, and they use their two other lookup functions instead, VLOOKUP and HLOOKUP. But in truth, although it is a powerful function, lookup is hardly used at all. In cell area B4 to D12, we can see the fuel consumption and the cost in dollars for certain distances calculated in miles. For example, for a 75-mile journey, the liter consumption is 10, and the cost for these liters is $13. Let's suppose we want to look up the consumption in liters for a 100-mile journey, and show it in cell H14. In such a small pool of data, it is relatively easy to find the proper value and manually type it in the proper cell. For 100 miles, 15 liters. Imagine if your data spanned to thousands of rows and columns. Finding out the needed value then could be impossible. This is where Excel's lookup functions provide us with a solution. In order for the lookup function to work properly in either of its forms, the column with the data we will be searching, in our case miles, must be sorted in ascending order as it currently is. Also, the value we need to search cannot be lower than the lower value of this column, or an error will occur. The 100 miles we want to search is not the lowest value in this column. If we type a value of less than 10 miles, an error would occur. The lookup function searches the data of the first column on the left of the cell area before B12 for a value. In our case, it is 100, and returns the value of the cell that can be found at the same row and at a given column. In our case, the column is column C, and so the value is 15. So, in cell H14, we will use the vector form of the function to get the value we need. We select the cell and navigate to the Formulas tab. Click on Insert Function, set the category to Lookup and Reference, and locate the lookup function. There it is. We click on OK. We decide to use the vector form of the function. Now, at the arguments window, we set the value that we are looking for at the lookup value. This is found in cell F14. At the field lookup vector, we need to define the cell area where Excel will perform the search. This is the cell area before to B12. In the final argument, results vector, we define the column where the letters are displayed. In our case, it is column C of the table. Letters. We click on OK. The result is 15, as you would have expected. If we repeat the function in cell H15 for the value in F15, we choose lookup again, the same form, lookup value now is F15, lookup vector remains the same, and the result vector remains the same. And click on OK. We see that the result is still 15. Because if an exact match is not found, the lookup function will match the closest value below the lookup value. So since 110 miles are not in our list, lookup searches the lower one, which is 100. And returns, of course, again 15. The array form of the function is a bit more complicated. It takes two attributes. The first is the lookup value, and the second is a table of data containing values to be searched in the first row or column and values to be returned in its last row or column. Suppose we want to approximately calculate the cost of fuel for our monthly trips, which are shown here in miles, and we want to calculate it in cells K5 to K12. We select the cell range, and then we type the equal sign, followed by the name of the function. We will use the second form of the function. The first attribute is the lookup values, which in our case is the cell range B5 to B12. We said that this form of lookup chooses its results from the last column of the given array. So since we want to show the cost for the given mileages, the last column of the given array should be column D. So we select B5 to D12 for our second attribute. Close the parentheses. Since we will use this as an array formula, we have to remember to press Ctrl, Shift and Enter at the same time instead of just enter. So we do just that. I click on Control, Shift, and enter at the same time. We see that our table is populated with the cost, with the approximate cost for each trip. If instead of cost we need to show the liter consumption, let's suppose we do that on these cells, we type again the function name, we select our lookup array, but since we now want to calculate the liter consumption, we only select for the second attribute cells B5 to C12, since we want this column to be the last. Close the parentheses. Remember to press Ctrl, Shift and Enter at the same time. And of course this should not, they're just numbers. This concludes the lesson on lookup. We will begin a quest to find the best lookup function. All the internal functions of Excel have limitations which we will try to overcome. In this and the following lessons, the knowledge of the simple syntax of the functions mentioned is considered a requirement. The basic limitation of VLOOKUP and HLOOKUP is that they are single-dimensional. They only search vertically or horizontally. The most obvious way to overcome this is by combining the two of them in a single formula. In short, we will try to make VLOOKUP search in a matrix both vertical and horizontally. To do this, we will use a VLOOKUP function with a nested HLOOKUP to provide us with a column number attribute of the VLOOKUP. In our current sheet, we can see the sales of a company for the year 2015. We have the date of the sale, the salesman, the district, the kind of sale, either bulk or retail, the color of the product, the unit sold, their price, and the total. We can notice here that we have added one more row. We will talk about it in a while. In cell J3, we will look for the number of units sold on January 20, 2015. The row we have added gives us the number of each column. We type our function VLOOKUP and we use the value in J2 as lookup value. And the cell area A3 to H44 as our table array. For the number of column now, we will use the nested HLOOKUP function. We type the name of the function. As lookup value we set cell J1, and as lookup array the cell area A1 to H2. We need the value in the second row of this cell area, which will give us the column number, so we type the number 2. And we need an exact match, so 0. This will give us the column number for the column units. We need an exact match for VLOOKUP as well, so we type 0 here as well. click on Enter to submit our function, and you can see we have the required result. And this was a matrix lookup formula using VLOOKUP and HLOOKUP. Although this combination works, it needs us to create a new row with the column numbers. We can easily avoid that by using the match function instead of HLOOKUP to look for the column number. We go to our next sheet and we reached our next combination of functions, VLOOKUP and match. In this sheet you see the same data as before minus the extra row. We are going to try to achieve the same thing as before. So in cell J3 we type our function with lookup value J2 as before. As table array we use cell area A2 to H43. Now instead of HLOOKUP, to provide us with a column number, we will use the match function. Lookup value is J1, which is the column name, and lookup array is cell area A1 to H1, which has all the column names. We need an exact match, so we type 0, and for VLOOKUP also we type 0 since we need an exact match. Click on Enter, and we have the same result as before, using VLOOKUP and match combination. A lot more elegant, don't you think? One other limitation of VLOOKUP is that it can only search for values to the right of the first column of each lookup array. So, if we wanted to search for the date that the units sold were 500, it would be impossible since the date column is on the left of the units column. Choose gives us a kind of complicated way to achieve just that. We will stay on the current sheet and in cell J20. We type the VLOOKUP function as before. 500 is the unit sold we are looking for, so we type it as lookup value. And to define the table array, we will use choose. This syntax of choose uses as first attribute an array with values 1 and 2. This is our array. This means that we want to choose to select from the array variables all those with index in the given array in the first attribute, which in simpler words means that we want to choose to select both values 1 and 2 that we will now enter. The array variables given are the two columns. In our case, the units column and the dates column. So choose provides VLOOKUP with an array of two columns. Take note here that we use the units column as the first value in our choose function. This way, choose function returns a table with the units column first and the date column second. So, as far as VLOOKUP is concerned, it still searches from left to right, since the date column is now on the right of the units column. The column number in this case is 2, since the table that choose returns is a two-column table with the second column the date column, and we are looking for an exact match, so 0. We enter our function, And as we can see, we have the required result. This adds extra functionality to VLOOKUP. It can now search both ways. We might be able to accomplish this for a matrix lookup as well, but I wouldn't even try it. There are a lot better ways to achieve this, and we will talk about them in our next lectures. We will continue our quest for the best lookup formula with another combination. We will use an offset and two match functions to do a matrix lookup. Unfortunately, this formula also only searches from the right column to the left and from the top to the bottom, but it is very easy to understand and use. I have to repeat here that in this and the following lesson, the knowledge of the simple syntax of the functions mentioned is considered a requirement. In this sheet, we can see the sales of a company for the year 2015. We have the date of the sales, the salesman, the district at which the sale took place, the kind of sale, either bulk or retail, the color of the product, the units sold, the price they were sold at, and the total. We are trying to find the number of units sold on January 20 of 2015. In cell J3, we type the offset function with reference cell the first cell of our table, which is A1. As we have mentioned in the offset lecture, this is what we usually use, the first cell of our table. We will use the first match function to find the row number and the second to find the column number. We type the first match function. The lookup value is in cell J2. And the lookup array are the date cells A2 to A43. We are looking for an exact match, so we type 0. We continue to our next match function, which will give us the column number. We type the function, and as lookup value we set cell J1, which shows the name of the column. The lookup array in this case is A1 to H1. And again we are looking for an exact match. Take note here that to calculate the right column number, we have to subtract 1 from the result of the match function, since the reference cell of the offset function is part of the match lookup array. Next two attributes of offset can be ignored since we are looking for a single cell. Press on Enter, and we have the required result, which is 40. The combination seems a lot easier to understand and use from the ones we have seen so far, at least to me, but it has its limitations. First, we have to remember to subtract the number 1 from our match function if the reference cell of the offset function is part of the lookup array of the match function. And second, we cannot look up from right to left. We cannot look, for example, at what date we had a sale of 500 units. Not without needlessly complicating our formula at least. Luckily, there is another way that removes all limitations and complications and seems, at least to me, a lot easier to understand. In the following lesson, we will see the end of our quest for the best lookup function, where we will explain how index and match can be combined to the best lookup formula in Excel. We have reached the end of our quest for the best lookup function, where we will talk about the combination of index and match. In the current lesson, we will use index with dual match functions to achieve a matrix lookup functionality. But you can easily skip one of the two match functions and replace it with a static value if you are not interested in a matrix lookup. The knowledge of the simple syntax of the functions mentioned is considered a requirement. In this sheet, we can see the sales of a company for the year 2015. We have the date of the sales, the salesman, the district at which the sale took place, the kind of sale, either bulk or retail, the color of the product, the units sold, the price they were sold at, and the total. We are trying to find the number of units sold on January 20, 2015. In J3, we type the name of the function, index, and the cell area of our data, which is A2 to H43. For the row number, we will use our first match function. We type match and set cell J2 as a lookup value and the data of the first column as the lookup array. So A2 to A43. We are looking for the exact match, so we type 0. This will return the row number for our index function. We continue to find the column number. We write our next match function. As lookup value, we use cell J1, and as lookup array, the row with the column names A1 to H1. Again, we need an exact match. This match function gives us the column number in the index function. We close the parentheses and press enter. We have the required result. Kind of easy, isn't it? The limitation of all the other formulas for lookup is that there is no easy way to do a right to left search. Fortunately, this combination doesn't suffer from the same disability. Right to left search can be done as easily as left to right. Suppose you want to find the date when we sold 500 units. We can easily find it in such a small pool of data, but let's use index and match. In cell J16, we will use the same syntax as before. First, our index function, our array is the array of data A2 to A43. For row number, our first match function with a lookup value of 500 and lookup array, the column of units. A2, F2 to F43. We are looking for an exact match, so we type 0. And now we have our row number. We use our next match function as before to find the column number. As lookup value, we use the name of the column, and as lookup array as before, the row with the column names A1 to H1. Again, exact match. We close the parentheses, click on Enter, and as expected, we have the required result. One index, two match functions. Until Microsoft creates a built-in function that matches or surpasses the versatility of index and match combination, I believe they are the best choice for any lookup scenario. This concludes the chapter for lookup functionality in Excel, and I hope it was helpful to you. Stick around for equally interesting stuff. Excel provides us with a lot of tools to calculate the depreciation of assets. Suppose the assets of a newly constructed lab are the lab itself, the building, and the equipment in it. The actual value of these assets declines as the years pass, as you can see on the three graphs. The lab's initial value was $100,000, with a lifespan of 10 years, through which it can be operational and useful. At the end of those years, its value, the money we can salvage from it, is $90,800. We have calculated the depreciation of this asset using various methodologies. We calculated, for example, the straight line depreciation and the fixed declining balance for the second year. Let's try to calculate the depreciation for the lab equipment. In E column, we need the straight line depreciation. This method assumes that depreciation of the value is the same for every year. That is why, as we see in the first chart, the value depreciates towards the salvage in a straight line. So we go to E5 and we use the function SLN, which is an abbreviation for straight line. The attributes are pretty straightforward: cost, salvage, and the useful life of the asset. We click on Enter, and we have the straight line depreciation. Then we need the depreciation of the second year using the sum of years digit depreciation method. The method is more appropriate than the more commonly used straight line depreciation if an asset has greater production capacity in the earlier years than it does as it ages. Which, in our case, the lab equipment, it is kind of true. Any equipment, as the years pass and it ages, its production capacity declines. The total amount of depreciation is the same for both methods. The only thing altered is the timing of depreciation recognition. The Excel function that provides us with the appropriate value is the SYD function. Which is an abbreviation for sum of years depreciation. The attributes are cost, salvage, and useful life as before, with the addition of the period argument, which is the year for which you want to calculate the depreciation. In our case, it is the second year, so we type 2. We click on Enter and have the second year depreciation. The next method is the fixed declining balance method. This method computes depreciation at a fixed rate, which Excel uses a complex internal formula to calculate. The function name is dB, from declining balance, and it mostly uses the same arguments as the previous functions: cost, salvage, life, period, second year in our case, and lastly, an optional parameter which Excel calls month. This argument represents the number of months in the first year. Since the lab was constructed in April, the number of months left in the first year are 9, from April to December. So we type 9 and click on Enter. This is the second year depreciation with the fixed declining balance method. Notice the difference. The next method is using the double declining balance method. DDB is the function of Excel from double declining balance. This method uses mostly the same arguments with the addition of a new optional one called factor. So, cost, salvage, life, period, 2, as before, since it is second year, and factor. Factor represents the rate at which the balance declines. If factor is omitted, it is assumed to be 2, double declining balance method, as the name of the method. In our example, we will use factor of 1.7. Close the parenthesis, click on Enter. This is the second year depreciation using double declining balance method with a factor of 1.7. In the last column, we want to calculate the depreciation for a certain period of time, which in our example is the second half of the second year, and we want to use the double declining balance method. Excel has a function to do that, which is VDB. We type the name of the function, the cost, the salvage, the useful life, the start period. Since we want the second half of the second year, this attribute is 1.5, which is the start period. The first and the half year is the start period of the second half of the second year. The end period is 2, the second year. Our factor is 1.6, as you can see in the instructions. We close the parenthesis and click on Enter. This is the result. VDB has one more optional argument, the no switch argument. This is by default false. When it is false, Excel checks the sequence of depreciation amounts assuming declining balance and compares it to the sequence assuming straight line depreciation. If the depreciation for the period using straight line for the remainder of the asset's life is greater than the declining balance depreciation for the same period, then VDB uses the straight line calculation. If it is true, it never uses the straight line calculation. Let's see what will happen if we select True. We see that the result is significantly different. In the current worksheet, we see all the information about a personal loan. Mr. Han has taken a loan of $120,000 with an annual interest of 5.3%. The installments of this loan are to be paid at the beginning of each month for a period of 11 years. All the other data on this sheet originate from this information. We can calculate the installment amount and we can produce a list of all our payments. We can even derive the amount of each installment that pays the interest of our loan and the amount that pays the actual principal for each month, as shown in these two columns. The three Excel functions we have used here are the PMT function, the IPMT function, and the PPMT function. These functions can be used for both loans and investments. For this reason, there is a cash flow convention. Outgoing payments, the payment Mr. Han has to make, are represented by a negative number, and incoming payments, the payments the bank has to make, for example, the original loan amount, are represented by positive numbers. Let's go to the next sheet. We can see again the details of a loan to Mr. Han. This time he has two options. The differences between the first and the second option are that payments are due at the end of the month instead of the beginning, and he has to be able to repay an extra $3,000 at the end of the last month. Why does it matter if the payment is due at the beginning or at the end of a month? At the beginning of the month, the lender is getting the money earlier, thus monthly payments are less than the end of the month case. More so because $3,000 of the loan is not being paid with monthly payments, it makes sense that the monthly payments are less. So let's calculate our installment amount. We select cell B9 and type the equal sign and the function PMT. The first argument is the rate, which you can derive from cell B3. In cell B3 we have the annual interest, but the installments are once per month since there are 12 installments in 1 year. So the rate you should type in the function is B3 divided by B6, which are the installment per year. And this will give us the monthly interest rate. Next, we have to type the total count of payments we have to make. The duration of the loan is 11 years and the installments per year are 12, so the payments are B5, duration in years, multiplied by B6, installments per year. And this will give us the total number of installments for the duration of the loan. Next is the present value, which means the amount of the loan in cell B2. After that is the future value, which is the extra amount paid at the last month. So it is cell B7. And finally, we type 1, which means that the payments are due at the beginning of the month, as shown in cell B4. We press Enter, and we have our result. This is the monthly installment of the loan for option 1. Notice the red color in the number, which means this is a negative value. And as we said before, it is negative because it is the money we have to give to the bank. We do exactly the same for option 2. We type equals PMT, the rate divided by the installments per year, the number of periods, which is duration, multiplied by installments per year, the present value, which is $120,000, and the future value, which in this case is $3,000. The type of payment here is 0 since the installments are paid at the end of the month. We press enter, and as expected, the installment amount is a bit smaller. Let us go to the next sheet. At the leftmost table we see Mr. Han's loan information, and on the rightmost a list of all his due payments. We can see the payment number, the date it is due, and the installment amount. We will now complete the rest of the table. The next column should show the amount of the installment used for paying the interest and the last one used to pay the principal. IPMT is a function which the initials stand for interest payment and PPMT for principal payment. So in cell J2 we type equals IPMT, the rate, which as we have seen before is annual interest divided by installments per year. The next attribute is the payment period, the number of payment to be more precise, which in our case resides in cell D2. Then the number of periods, which as we've seen before is the duration in years multiplied to installments per year, the present value $120,000, the future value 0, and the type, which is paid at the beginning of the month, so it is 1. Pressing enter, we see that for interest we pay $0 at the first month, and for principal we will calculate now. We type the function PPMT, as before, rate divided by installments per year, the number of period, the number of periods, as before, duration multiplied by installments, present value $120,000, future value 0, and the type, as before, 1. So we see that in the first month we pay $0 for interest and all of our installment is going to paying off the principal. In order to autofill the table with this function, we have to make some small adjustments. These have to be absolute references. We are making them all absolute references. All the references to the cells in the leftmost table, which has all the attributes of Mr. Han's loan. We do the same with this function. We do not give absolute reference to cell D2, since this should be relative for each row of our table. Having done this, select the two cells and autofill. So now column G shows the amount paid for interest and column H the amount paid for principal. The functions we are going to see now belong to the group of functions Excel provides us to calculate loans and investments. Mr. Han is interested in investing some money and he had in his mind 4 possible scenarios. In the first one, he had decided for every detail of the investment except of the amount of the initial investment. Excel provided that number with the help of the function PV, which stands for present value. In the second scenario, he wanted to know how much the future value of his investment would be, which practically means how much money he would take at the end of his 11-year investment. Function FV, which means future value, helped him with this. In scenario number 3, he had everything figured out except the duration of his investment. Excel's NPER, which means number of periods, help here. Finally, in the last scenario, he only had to calculate the annual interest of the investment. Excel's function rate, which provides the rate for each payment of the investment, is what he used. Before we see how exactly he did all this, we have to explain the cash flow convention for these functions. Outgoing payments, the payment Mr. Han has to make, which are shown as the initial investment, are represented by negative numbers, and incoming payments, the money Mr. Han is to receive, for example, the future value, or here the payment amounts, are represented by positive numbers. Let's go to the next sheet. This sheet is missing some fields, the ones with a yellow background, which we will have to calculate ourselves. Let's start with the first investment plan. We have the annual interest, the duration of the investment, the frequency of payments per year, and the future value of the investment, which, as we said before, is the money Mr. Han expects to receive at the end of the investment. In this plan, we can see that the payments amount is a positive number, which means that each month Mr. Han will receive $1,000, while in plan 4, for example, Mr. Han will have to give $1,000 each month. We will calculate the missing field with the use of PV, present value. We select cell B2 and type equals PV. The first attribute is the rate. We have in cell B3 the annual interest. To have the monthly rate, though we have to divide this with the yearly payments, which are 12 per year. So with cell B6. Next is the number of periods. The loan has a duration of 11 years, and each year has 12 payments in it. So the number of periods is 11 years multiplied to 12. Then we have to input the payment amount, which we have in cell B9. And next, the future value of the investment, which resides in cell B7. Finally, we have the type of the investment, which is when are the installments paid, at the beginning or at the end of the month. We select 1 because, as we see in cell B4, the installments are paid at the beginning of the month. We click on Enter, and we have our present value. This present value is the initial investment required for the rest of the investment fields to be true. On the second example, we will use the FV function to calculate in cell E7 the future value of the investment. We select cell E7, type the name of the function, and the appropriate attributes as before. The rate divided by the payments per year, the number of periods as before, by multiplying duration and payments, the monthly payments. PV stands for present value, which in our case is $60,000, and the type, it's now at the end of the month, as we can see, so we type 0. We click on Enter. We can see that at the end of the 11 years, Mr. Han is going to receive approximately $16,000. Now we go to the third plan, in which we do not have the duration in months. Here we will use the function nPer. We type the function, and as before, the appropriate attributes: annual interest divided by payments per year. PMT stands for the payment amount, which is $1,000. Present value is $280,000, and future value is $300. The type, as we can see in cell B15, should be 0, end of the period. By clicking on Enter, we have the total duration in months. If you wanted to see the duration in years, we would have to divide this amount to the payments per year, which would give us 7 years. Notice that B17 cell changed to reflect this duration. This happened with the use of the date function. Finally, we go to plan 4 to see how we can calculate the annual interest of an investment using the function rate. The rate function gives us the rate per payment period, in our case, a month. So, whatever result it gives us, we will have to multiply by 12 to get the annual interest. In cell E14, we type the function number of periods is as before duration in years multiplied by payments per year. Next the payment amount, then the present value, the future value, and the type, which in our case is at the beginning of the month. There is an optional parameter for rate called guess, which is an initial estimate at what the rate will be. From that estimate, Excel starts an iterative procedure to converge to the correct rate. This could have meaning in a huge pool of data because it could speed up the results. Otherwise, it can be omitted and the default value of 10% will be used. We omit it. We click on Enter. We see that the rate is rather low. That is because we haven't yet multiplied it by the payments per year field. Clicking on Enter now shows the correct rate, the correct annual interest, which is 5.11%. The functions we are going to see now belong to the group of functions Excel provides us with to calculate loans and investments. Mr. Han is interested in investing some money and he had in his mind two possible scenarios, Scenario 1 and Scenario 2. In both cases, the investment capital is $120,000 and the annual interest is 4.3%. In the first scenario, the duration of the investment is 11 years with monthly periodical payments to Mr. Han, while the second plan has a duration of 5 years with 120 non-periodical payments to Mr. Han. But how to decide which one is more advantageous for him? Excel's functions NPV and XNPV helped him by calculating the net present value for each investment, the first one and the second one. NPV calculates the net present value for a series of periodic cash flows, while XNPV the net present value for non-periodic cash flows. What does net present value means? It is the value of an investment in today's money considering the value of money over time. It does that with the help of the annual discount rate, which is the rate at which our money loses its value for various reasons. For an investment to be valid, the net present value should be higher than the initial investment. An investment is more profitable the higher its net present value is. So, to our example, the most profitable investment is the second one, but both of these investments have lower value than their initial investment, which makes them bad choices for Mr. Han. The first plan has a net present value of something less than $120,000, while the present value, the money invested by Mr. Han, is $120,000, and so is the second. It is less than the initial investment. When Mr. Han realized that, he asked the bank for a reviewed proposal. So the bank sent two other options. In the next sheet, we can see here that the net present value has not yet been calculated. Let's do that for Mr. Han and help him out. First, we select cell A11. We type the name of the function and we chose NPV since the payments are periodical. The first attribute is the rate, the discount rate, which is the discount rate per payment period. In our case, it is 1 month, so we have to divide this with 12 in order to have the monthly discount rate. Next, we select the payments from cells E3 to E134. We close the parentheses and click on Enter. We see that the net present value is now higher than the initial investment, which is certain more profitable for Mr. Han than the previous proposals. Let's see what the second proposal offers to Mr. Han. We will use the XNPV function since the next plan is a 5-year plan of 120 non-periodical payments, which means we cannot use NPV. This function considers rate to be the discount rate per year since there are no constant payment periods now. So the first argument is cell H16 as it is. Next, we select the values from cell L3 to L122, which are the payments. And finally, the dates of the payments, which is the leftmost column. Cells K3 to K122. We close the parentheses and click on Enter. This plan's net present value is also higher than the initial investment, but it is lower than the first plan's net present value. So from these two investment plans we can see that most profitable is the first plan since its net present value is higher. If Mr. Han had to choose one of them, this should be it. In this lesson, we will learn how to calculate the internal rate of return of an investment. The internal rate of return is the actual profit percentage an investment returns. It is fairly obvious that if this rate is less than 0, it means the investment returns a loss, and that the higher the rate, the more profitable the investment is. In the two plans of our example, we have calculated the internal rate of return, and we can see in cells A10 and G10, respectively, that the first plan seems more advantageous since it has higher internal rate of return. In the first example, we used the IRR function, which provides the internal rate of return for periodic payments. It works under the assumption that all income of the investment is being reinvested with the same finance rate as our initial investment. In the second example, we used the XIRR function, which works exactly like IRR but for non-periodic payments. For the first plan, we calculated one more rate, the modified internal rate of return. As we said before, IRR assumes that reinvestment rate is the same as the finance rate of the investment. In most of the cases, this is not so. This is why Excel introduced one more function, the MIRR. MIR calculates the internal rate of return if their investment rate is different. In this case, it is, and the internal rate of return is calculated at a lower value, thus making the second plan better. We asked for better rates from the bank, and they sent it to us. So, we have to calculate the internal rate of return again. We select cell A10 and type the name of the function, IRR. Since this investment consists of periodic payments, for the first attribute we select the list of all the payments from cells E2 to E133. The rate IRR returns is the rate per payment period, so we have to multiply it by the payments per year to get an annual rate of return. So we multiply it by cell B5, which are the payments per year. We click on Enter, and here is our internal rate of return. Let's calculate the modified version of internal rate of return. Select cell A14 and type the name of the function, MIR. The range of the payments, as before, cells E2 to E133, then the finance rate, which is annual, so we have to divide it to the payments per year, and the reinvest rate, which is also annual, have to be divided by the payments per year. We have to multiply this rate with the payments per year in order for it to give us the annual modified internal rate of return. We click on Enter, and we have 4.55%, significantly less than the internal rate of return. It is time to calculate the internal rate of return for the other investment plan. We select cell G10 and type the name of the function, XIRR, since the payments here are not periodical. Then we select the values from K2 to K182, and the dates from the adjustment column, cells J2 to J122. We click on Enter, and we have the internal rate of return. We notice that even though IRR function provided us with a higher rate than the second investment plan, the MIRR function provided us with the lowest of the three rates. Which one do you choose? IRR assumes that the reinvestment rate is the same as the finance rate, which is not true in our case. So the second result is the one we should consider. This drives us to the conclusion that the second plan is more profitable from the two. There is an optional parameter for IRR and XIRR functions called guess, which is an initial estimate at what the rate will be. This attribute. From that estimate, Excel starts an iterative procedure to converge to the correct rate. This could have meaning in a huge pool of data because it could speed up the results. Otherwise, as happened in our case, it can be omitted and the default value of 10% will be used. The Excel $FR and $DE functions are designed for working with security prices which are often quoted as fractional values. For example, the decimal value of $12.5 is quoted as $12.5 if you consider that the fraction of the fractional value is 2. In this sheet, we have 3 decimal values and their fractional values equivalent. Let's see how we do it. In the next sheet, we can see 3 numbers in decimal format. We will first convert them to fractional format and then back to decimal. The fraction we're going to use is 5. Select cell B2 and type the function $FR, which stands for $fractional. The cell we want to convert is cell A2 and the fraction is 5. We click on Enter. This is the fractional representation of this decimal number with a fraction of 5. Let's convert this now back to decimal. We will use the $D function, which stands for $decimal. The first argument is the fractional dollar, which we have just calculated, and the next is the fraction in cell C7. We click on Enter, and we have converted the fractional value back to the decimal, as you can easily see. We select cell B2 and change the reference to cell C7 to absolute. And we do the same in cell C2. Now all we have to do is select both of the cells and autofill. We can see that each decimal value is being converted into fractional and then back to decimal. Decimal, fractional, decimal. Excel provides us with numerous functions to calculate and manage securities. Let's start with the functions that calculate the yield of a security. These are yield, yield mat, and yield disk. We can see here the details of a security. We have calculated 3 types of yield in our example. It's a yield for a security that pays periodic interest, the yield of a security that pays interest only at maturity, and the yield for a discounted security. This way, we can decide which kind of security is more profitable to us as investors. In the current scenario, the yield seems better if we decide to be paid at maturity. Let's see another example. Here, the yield is yet to be calculated. The issue date is the date the security was issued. The settlement date is the date after the issue date when the security is traded to the buyer. The maturity date is the date when the security expires. Let's calculate the yield in cell B10. We type equals with the name of the function, yield. Then the settlement date, the maturity date, the annual coupon rate, cell B6, the price per $100 of face value, cell B9, the redemption value per $100,000 of face value, cell B8, the frequency, which is the number of coupon payments per year, in our example, cell B7. The last argument, basis, is optional and it helps us choose the type of day count to use. Since we will always use the default 0 value, we can omit it. We close the parentheses and click on Enter. This is our yield. In cell B11, we will calculate the yield for a security that pays at maturity. Thus, we will use the yield.mat function. Again, we enter the proper arguments, settlement date, maturity date, issue date, the annual coupon rate, and the security's price per $100 of face value. Again, we will omit the basis optional argument and click on Enter. This is a yield for a security that pays at maturity. Last, we will calculate the yield for a discounted security in cell B12. We will use the yield disk function. Again, we enter the proper arguments, settlement date, maturity date, security's price per $100 of face value, and the redemption price. The basis option is omitted. We click on Enter. In this scenario, as the previous one, the yield is better if the security pays at maturity. In this lecture, we will see 3 more functions for security calculations. The disk function, which gives us the discount rate of undiscounted security, the received function, which gives us the amount received at maturity for a fully invested security, and finally, the interest rate for a fully invested security using the int rate function. These values have already been calculated in this example. So let's dive into another example and do the work ourselves. Here the security details are different and we haven't calculated yet the discount, the received amount at maturity and the interest rate. Let's do just that. Select cell B8 to calculate the discount of the security. We enter the name of the function, the security's settlement date, the security's maturity date, the security's price per $100 of face value, and the redemption value per $100 face value, cell B6. The last argument, basis, is optional and it helps us choose the type of day count to use. Since we will always use the default 0 value, we can omit it. We click on Enter, and we have our discount rate. We have calculated the discount, and now we will try to find out what is the amount we will receive at maturity in cell B9. We type the name of the function and, as before, the settlement date, the maturity date, the investment amount, which is cell B2, and the discount we have just calculated. We click on Enter, and we have the amount we will receive at maturity. Now that we have the amount received at maturity, we will calculate the interest rate of our security investment. In cell B10, we type the function int rate, we select the settlement date, maturity date, our investment, and finally an argument called redemption. The name redemption is being used in lots of Excel functions, and in most cases, as we saw with the disk function, it represents the redemption value per $100 of face value. But in the int rate function, it represents the amount received at maturity, which you can find in cell B9. Close the parentheses, we click on Enter, and we have our interest rate. In order to be able to calculate the price per $100 of face value we pay for an investment, Excel provides us with three tools: the functions price, price mat, and price disk. In the current worksheet, you can see the details of a security. We have our initial investment, the issue date, which is the date the security was issued, the settlement date is the date after the issue date when the security is traded to the buyer, and the maturity date is the date when the security expires. We can see we have already calculated the prices in cell B13 to B15. We have calculated the price for three scenarios: for a security that pays periodic interest, for a security that pays at maturity, and for a discounted security. We see that at the discounted security we pay less money for each $100 of face value. This doesn't necessarily mean it's the most profitable choice. To determine which scenario is the most profitable, we have to look at the yield values. In this case, it happens that the discounted security is the way to go since it has higher yield. It's time to see how these functions work. In this worksheet, we have a different investment plan. In this plan, we have to calculate the price for each of the different three scenarios. We again have our initial investment, our issue, settlement date, and maturity date, and the other security details we are going to need. The first scenario assumes that the security pays periodic interest. So in cell B13, we type the function price. First attribute is the settlement date, second the maturity date, the annual coupon rate is the third attribute, cell B6, the yield resides in cell B9, the redemption value per $100 of face value is in cell B8 and is the redemption attribute we see here on the function. And the frequency is the number of coupon payments per year. We have one payment per year, so the frequency is 1. The last argument, basis, is optional and it helps us choose the type of day count to use. Since we will always use the default 0 value, we can omit it. Close the parenthesis and click on Enter. Our securities price per $100 of face value is approximately $94. Next, we will calculate the price for the scenario that assumes that the security pays at maturity. We type in cell B14 the function followed by the settlement date, as we're going to see, then by the maturity date. Issue stands for the issue date. The rate is the security's annual coupon rate as before. The yield of a security that pays at maturity is now in cell B10, and we omit the last optional attribute and click on Enter. We can see that the securities price per $100 face value for a security that pays at maturity is a bit higher than the one we have previously calculated. Lastly, we will find out what the price per $100 of face value is if the security is a discounted one. We type in cell B15 the function, which is price disc for discounted price, the settlement date, the maturity date, followed by the discount rate in cell B12, and the redemption value per $100 of face value. Close the parenthesis and we click on Enter. Take note that here we used the discount rate in cell B12 instead of the yield for the discounted security, which is in cell B11. Excel provides us with two functions for calculating accrued interest, accrued and accrued M. But what exactly is accrued interest? Accrued interest is the interest that has been earned but not yet been paid by the bond issuer since the last coupon payment. Because the security hasn't expired or the next payment is not yet due, the owner hasn't officially received the money. If he or she sells the security, accrued interest should be added to the sale price. So, in our example, we see all the information on the bond we bought. The previous coupon payment was a few months earlier. We have two scenarios for this bond. One that pays periodically and one that pays at maturity. We have calculated the price in both of them using the price function. Take note here that the price functions returns the per $100 value, so we multiply the result by 100 to have the per $10,000 value, which is our initial investment. Our initial investment is also called par value of investment or principal of an investment. In cells B14 and C14, we have calculated the clean price, which is the price without the accrued interest. Below them, we calculated the accrued interest and then the dirty price, which is the total price of the bond, including accrued interest. We have used both of the accrued interest functions to achieve this. One for the bond that pays periodically, and the other for the bond that pays at maturity. To see how exactly we did this, let's go to the next sheet where we have another bond for sale. As you can see, the accrued interest is yet to be calculated. Thus, the dirty price is still equal to the clean price. All the other details we have seen in the previous sheet are here, but with slight differences. For example, our initial investment is $1,000 instead of $10. We go to cell B15 to find out what the accrued interest for the bond that pays periodically is. We type the name of the function, followed by the issue date in cell B4, and the first interest date in cell B5. This is where we have to mold the function to our demands. The accrued function of Excel calculates the amount of interest that has been earned since the day that bond was issued. This would not be correct or fair to the buyer, since we would calculate in the accrued interest money we had already received up to the date of the settlement. In our example, we want to sell the bond in February of 2016, cell B7, which means that we have already received all the coupon payments previous to that date, so the accrued interest should be calculated from the date of the previous coupon payment, which is the last we have received in January of 2016, up to the date of the settlement, February 5 of 2016. To mislead Excel into doing our bidding, we set as both issue date and first interest date of the bond the date of the previous coupon payment. So, to correct our function, we will set the two first arguments to cell B6, which is the previous coupon payment. Then the date of settlement, which is the date our sale is going to take place, as we said before, February 5 of 2016. The rate in cell B9, the par value of the investment in cell B3, and the frequency of payments from cell B10. The next argument, basis, is optional and it helps us choose the type of day count to use. We will always use the default 0 value. And then the last value, calc method, which is optional as well, is a logical value that specifies the way to calculate the total accrued interest when the date of settlement is later than the date of the first interest. A value of true returns the total accrued interest from issue to settlement. A value of false returns the accrued interest from first interest to settlement. If you do not enter the argument, it defaults to true. In our case, both methods provide us with the same result since our issue date and the first interest date are the same. So we can omit both of the optional attributes and click on Enter. We have calculated the accrued interest, and you can notice that the total price, the dirty price, has changed accordingly. Then we have to calculate in cell C15 the accrued interest for a bond that pays at maturity. We use the appropriate function accrued_M, followed by its arguments. Here we don't need to trick Excel, so we use the proper issue date from cell B4. And then the settlement date. The rate, and the par value. We omit the optional basis argument. We click on Enter, and we have our result. The total sale price has changed also here, and we have the total price for both our scenarios. Most investments pay some money to the investor in regular periods. These payments are called coupons. In our example, we can see the details of a bond. The settlement date can be in any date between the issue and maturity date. This means it could be between coupon dates, which in turn means that the interest paid to the investor for the first coupon should be less, since the days of ownership of the bond are less than the coupon duration. Excel provides us with plenty of functions to calculate this. In our example, the settlement date is the 5th of March of 2015. We have calculated the previous coupon date from the settlement. We can see that it is a few days before, 4, as the next cell denotes. By adding 4 to the previous coupon date, we should have the settlement date, as we do. We can also calculate the days in the coupon that contain the settlement date and the number of coupons between settlement date and maturity, which actually means how many times you will get paid from the investment. This is the number of coupons between settlement date and maturity date, and this is the number of days in a coupon period that contain the settlement date. The interesting part is found in cells B10 and B11. There, we calculate the days from settlement to next coupon date and the next coupon date. By subtracting B10 from B11, we should have the settlement date, which, as you can see, is not the case. The reason to this is the basis argument we use in the functions, which is the default, 0, as you have seen in the previous lectures. This is the default for US and European Union financial dealings and assumes a 30 days month and a 360 days year. This assumption gives us this number of days, which in turn gives us the wrong settlement date. Let's see all this in more detail in the next sheet. The details of this bond are different, and we still haven't calculated all these yellow cells. Let's start at cell B7. We want to calculate the previous coupon date from the settlement date. You select the cell and type the name of the function, which is previous coupon date, PCD. and then to select the settlement date, the maturity date, which is in cell B5, the frequency of payments in a year, which resides in cell B6, and for the basis value, we will use the default 0, as we said before, and we'll omit it. We click on Enter. This is the previous coupon date. We go in cell B8. We want to calculate the days from previous coupon date to the settlement date. The name of the function is COUP days before settlement, BS. We select the settlement date, again, the maturity date, the frequency, just as before, and we omit the basis attribute. We click on Enter, and these are the days from previous coupon date to the settlement date. Adding these two values, as you can see down here in the sum, provides us with a settlement date. We go in cell B9, where I want to calculate the number of days in a coupon period that contains the settlement date. The function is COUPDAYS, and again the attributes are the settlement date, the maturity date, and the frequency. We click on Enter, and you have the required result. We go to cell B10 to calculate the days from settlement date to next coupon date. The function here is COUPDAYS next coupon NC. Again, the same attributes, settlement date, maturity date, and frequency. We omit the basis again, and click on Enter, just one day. In cell B11, we will calculate the exact date of the next coupon from the settlement. The function is COUP next coupon date NCD, and again the same attributes as before, maturity and frequency. We click on Enter. Here, if we subtract 1 from this date, we can easily see that we have the settlement date. Finally, in cell B12, we want to calculate the number of coupons between settlement date and maturity date, and we use the function COUPNUM with the same attributes, maturity and frequency, and we have the desired result. As you have also noticed in the previous sheet, we do not use the actual dates, but rather a commonly used financial assumption that considers a year to be 360 days and the month to be 30 days. If we want these functions to provide us with the actual dates and number of days, we should use a different basis argument. This would be the basis value 1, which refers to actual numbers of days in months and actual number of days in years. In the current sheet, we have the details of a security, and we have calculated the Macaulay duration and the modified Macaulay duration. The Macaulay duration, named after Frederick Macaulay, and its modified version is a measure of a bond's sensitivity to interest rate changes. Technically, duration is the weighted average number of years the investor must hold a bond until the present value of the bond's cash flows equals the amount paid for the bond. Bonds with a higher duration will carry more risk and hence have a greater volatility in prices when compared to bonds with lower durations. Excel gives us two functions to calculate both versions of Macaulay duration: the duration and the M duration for the modified version. As we said before, we have already calculated these values. Let's try to calculate them again using a different security investment with different security details. We will calculate the Macaulay duration. We type the name of the function, the settlement date that you can find in cell B4, the maturity date which resides in cell B5, the coupon rate which resides in cell B6, the yield, which is in cell B8, and the frequency found in cell B7. The last argument, basis, is optional and it helps us choose the type of day count to use. Since we will always use the default 0 value, we can omit it. We click on Enter, and here is the Macaulay duration in years. In cell B10, we will use the mDuration function to calculate the modified version of the Macaulay duration. Again, as before, settlement date, maturity date, annual coupon rate, yield, and frequency. We click on Enter, and we have the modified version of the Macaulay duration. In this lesson, we will talk about the treasury bill functions of Excel. These are T-bill.EQ, T-bill price, and T-bill yield. Treasury bill are short-term obligations backed by a government with a maturity date of equal to or less than 1 year after the settlement date. The settlement date is the date the duration of the bill starts and maturity date when it ends. They are offered at a discount rate of their market value. At the end of their duration, the investor gets back the full market value of the bill, thus earning the difference. As interest of a treasury bill is the discount rate, so it is calculated as a percentage of its final value. In our example, for every $100 of a treasury bill, we paid $95.75. We had a discount rate of 8.5% and a total yield of 8.88%. Let's see our other example. A 3-month treasury bill which we bought for $10,000 at a discount rate of 10%. Thus, we paid $9,000. But any other bond or security calculate the interest rate of an investment as percentage of the initial investment, in our case, the $9,000. The need to compare other bonds to the bills gave birth to these three Excel functions. One function was needed to calculate the yield of the bill as a percentage of the initial investment. One to provide us with a price per $100, face value of a bill. This means the price we paid for each $100 of the bill, and one to calculate the bond equivalent yield of the bill. Let's learn how we can use these three functions ourselves. On this sheet we have the information of a 3-month treasury bill, the settlement date, the maturity date, and the discount rate. We will calculate first the price per $100 of the bill. We select cell B5 and type the name of the function. Which is T-bill price, which stands for Treasury Bill Price, and enclosed in parentheses, settlement date, maturity date, and discount. We close the parentheses and click on Enter. This is the price per $100, which means we bought $100 bill but paid for it $97.5. The yield of this investment will be calculated in cell B6. We click on B6, we type the name of the function, which is T-bill yield, Treasury bill yield, the same attributes, settlement, maturity. The last value is a bit different, that PR stands for price per $100, the value we have just calculated. Close the parentheses. The yield of our bill is 10.26%. If we need to compare this bill to a bond investment, we have to calculate the bond equivalent yield of our treasury bill. So in cell B7, we type the function T-bill.EQ, which stands for treasury bill equivalent, with the proper arguments, which are settlement date, maturity date, and discount. We click on Enter, and we see that the bond equivalent yield is 10.4%. Pivot tables might as well be Excel's most powerful feature. A pivot table helps you to summarize and analyze your data, thus extracting the significant information from a large and detailed dataset. For this example, we will use a rather small dataset to better understand the concept of pivot tables and how they work. In this sheet, we can see the sales of a company for year 2016. Suppose we want to review the sales per salesman. Excel provides a fast way to do that. We click inside our table and then on the Insert tab and to the Pivot Table button. We select the cell range we want the pivot table for. Since our selected cell was inside the table, we see that the table is already selected. and to decide if we want the pivot table to appear in a new worksheet or in an existing worksheet. We choose this sheet for this example and specifically cell G1. We click on OK. A new pane appeared on the right of our cells. Here we can select the rows, the columns, and the values of our pivot table. Since we want to review the sales per salesman, let's put the salesman field on the rows area and the quantity field on the values. By default, the pivot table generator chose to show us the sum of quantity, which is exactly what we need. But if we want, we have a lot more choices. We can show the count, the average, the max, the mean, the product, and a lot more. But we will go with the sum. As you can see, we have easily summarized the sales of each salesman for 2016. There's an even faster way. On the Insert tab, there is a button called Recommended Pivot Tables. If we click on this, Excel shows us a list of recommended pivot tables. Most of the times, the pivot table we need can be found here. A variation of the table we have just created exists here. Let's click on it and press OK. A new sheet was created with a generated pivot table. This table has an extra field in the rows section, the date field. This means that by clicking the plus sign on the left of the salesman name, we can see the sales he or she did each day. The versatility of the tool can be understood by adding one column to the mix. Let's add the product field to the column section. In addition to all the previous information, we can now see the sales per salesman, per date, and per product. Let's play with it a bit more and add the color field to the filters section. This provides us with a filtering mechanism for our table. We can see here that now we have all the colors selected. Let's filter our results to show us the brown products only. Click on brown and OK. If we need to select more than one values for our filter, we just click on the Select Multiple Items checkbox. For now, we are OK with the brown. We can see that the same filter button exists on both the rows and column labels. By clicking on them, we can further filter our results for certain salesmen or types of products. Let's filter the results to show us only Salesman Simpson. And for products, only the shoes. So, we now know that Simpson sold 3 brown shoes in total. Imagine the time we would need to produce such analytical reports and summarizations by hand, especially if we had a massive amount of data to analyze. Impressive, isn't it? In this lecture, we will try to explain and use a very useful feature of pivot tables: the creation of calculated fields and items. In the current sheet, we have the sales of a company for the year 2016. Let's start by creating a pivot table. Select our data and insert a pivot table. We add the product field in the columns, the salesman in the rows. We want to show income in dollars that each salesman produced per product and in total. This is where we have a small problem. To have the data we want on the pivot table, we need to add a field in its values, which shows the income produced per sale. Unfortunately, we don't have such field. We now face two options. We either create a new column in our original table to calculate the income per sale, to multiply quantity to price per item, and then add this column to our pivot table, or we create a calculated field. You guessed right, we will choose the latter. We click on our pivot table, and from the Analyze tab, we click on the Field Items and Sets button. We choose Calculated Field from the drop-down menu, and as name for the field, we choose Income per Sale. In the formula text box, we insert the field Quantity, multiplied by the field Price per Item, and then click on Add. A new field has just been added to our field list. By clicking OK, the new field was added in our values, which was exactly what we wanted. We used a simple multiplication as formula for our field, but we can use any Excel function as complex as we want for the calculation of the field. Having a closer look at our table, we see that we have two products, shoes and boots, which we would prefer to calculate together. The options now are to change our original table and rename all boots and shoes records to boots and shoes, which we cannot do since their price is different and because it would be very time consuming. And the other option is to create a calculated item, which it seems to be the only viable choice. So a calculated item is a way to summarize two different sets of data. We click on the product headers of our pivot table, and from the Fields and Items and Sets button as before, we now choose Calculated Item. We clicked on the product headers because it is for the product field we need a new item. As name, we type shoes and boots. And as a formula, we select the shoes item, add it to the boots item. In the formula field, you can use any Excel formula as long as the items you use are part of the product field. We then click on Add. A new column just appeared with the name Shoes and Boots and the needed values depicted. We can even use these items to filter our table and show just the income for the sale of shoes and boots. There is a disadvantage though. If we disable the filter and notice the total columns, before and after the item insertion, we would realize that the totals have changed since the shoes and boots data are calculated twice, one for their original column and one for the new item we have just added. This can be corrected by filtering out the shoes and boots column when we want to have the real total values, or by removing the new item altogether. To do that, we go to the same drop-down menu item choice as before, select the shoes and boots from the drop-down menu, and click on Delete. The totals have been corrected. We can do the same to remove the new field we created as well. Click on Calculated field, select the income per sale field we have created before, and then click on Delete. We can see that the field has disappeared. Analyzing data can be fun, right? Pivot charts in Excel are the visual representation of pivot tables. They are connected to each other, and every change on the table affects the chart and vice versa. They have all the basic functionality of a standard Excel chart, plus some extra features. In our current sheet, we can see the sales of a company for the year 2016. There are two ways to create a pivot chart. The first is to create a pivot table and then insert the pivot chart based on that table, and the other is to insert them together. To access both ways, we have to click on the Insert tab and on the Pivot Chart button. From there, we can select one or the other. We select to insert both to save us some time. We either choose a cell to insert them or insert them into a new sheet. We will choose to insert them in a new worksheet. Then we set the product field as legend, the salesman as axis, and the sum of quantity as values. We can see that the legend area and the axis area are a different name for the columns and rows areas respectively if you have the pivot table selected. The visual differences from a regular chart are these three gray areas. We can use the product and salesman fields to filter the results of the pivot table and the chart, and the sum of quantity field to change its properties. For example, let's change the value field to depict the count instead of the sum of the sales. Both the chart and the table have changed to reflect our new settings. Let's filter the chart now to show Mr. Simpson and the sales for search. We select Search as filter for the products and Mr. Simpson for the salesman. Again, the table and the chart change together. The same filters can be applied to the table and be depicted on the chart instantly. Let's revert our chart to its original state using the pivot table filters and options. First, we clear the filter from the salesman and then clear the filter from the product. and with right-clicking the filter count of questions in the chart, we will change it back to sum. Every functionality that exists on a regular chart is present here as well. We can change the type of the chart, the style, the colors, and pretty much anything we like on the design of the chart. For example, we can change the chart type to 3D cluster column. We can change the style to this one, the layout to this one, and the colors to these. Since Excel 2010, a new and very interesting feature was added. Slicers. At first glance, they might seem like a beautified way to filter a pivot table, but they can be a lot more than that. In the current sheet, we can see the sales of a company for the year 2016. We have also created a pivot table that shows the sales per salesman and product. Below the table is a chart depicting the same data. Let's add some slicers. First, you click on either the pivot table or the pivot chart and select the Analyze tab on the ribbon. There are two types of slicers. A general one, suitable for all forms of data, and the timeline one, which was introduced in Excel 2013. Let's add a simple slicer for the product field and a timeline for the date field. We select the product field, and here is our slicer. And now let's add one timeline for the date field, which is our only option anyway. Let's make this a little bigger. We can now use them to filter our pivot table and chart. We select to show only data for months April to August. April to August. And not to show data for shoes and socks. We click on the multi-select and unselect shoes and socks. There is an obvious advantage on the filtering provided by slicers over the built-in filtering of the pivot table. We can instantly see the filters currently in effect. The timeline slicer has a drop-down menu to choose how the dates are shown. We can either show years, quarters, months, or days. We will stick with the choice of months for now. By clicking on the timeline slicer, a new tab appeared in our ribbon, named Options. Clicking on it, we have access to various commands. We can change the caption and the style of the timeline. We can even change its size and alignment. And of course, we can enable or disable various of its features. For example, the selection label, the header, the time label. For now, since we want the months to be shown, we can do without the time level. But the button called Report Connections is probably the most interesting. Before we click on it, let's create one more pivot table based on our original table. it will show the quantity of sales per color and per product. We will have to add this table to the data model as well. Quantity of sales per color and per product. Now let's go to that button we talked about before. We click on the slicer, Options, Report Connections. By clicking on it, we see a list of all the pivot tables currently on the data model. The first pivot table is already selected. By selecting the second as well, the slicer will be capable of filtering the two pivot tables simultaneously. We repeat the process for our product slicer. We go to its Options, Report Connections, the new pivot table. Notice how the tables and the chart change by altering the slicers. The general slicers are packed with some more features. We can access them via the slicer setting in the Options tab. There are options to sort the slicer data, either in ascending or descending order, or keep the data source order. We can also hide those with no associated information or to flag them. There's the option to change the caption, as we saw in the timeline slicer, or to change the name. In summary, the slicers are a very welcome addition to the Excel arsenal and are here to stay and evolve. Although pivot tables are very powerful, in the professional editions of Excel there is one optional add-in more powerful and versatile than any other. It is called Power Pivot, and in order to use it, you have to first enable it. Let's do just that. We go on the File tab of the ribbon and then on Options. We then select Add-ins, and from the drop-down control we choose COM Add-ins. We click on Go, and we are presented with a list. If Power Pivot exists in our version of Office, we should see the Microsoft Power Pivot for Excel on that list. Right here. We select it and click OK. A new tab appeared in our ribbon. We click on it. To be able to use Power Pivot, we have to add some data to the data model. Data model is a group of tables from a lot of different sources that can be combined by creating relationships. So let's add some data to our data model. In the current sheet, we have two different tables. In the first table, we see the sales of a company for year 2006, and in the other table, we see the price per item for each product. We select the first table, and in the Power Pivot tab, we click on the Add to Data Model button. Power Pivot opens, showing it to us. Nothing impressive till now. Let's jump back to Excel. We select the second table, and as before, we add it to the data model. The second table appears in Power Pivot, and you can see that the previous table is on the other tab. The first table, the second table. We should note here that we can add tables from different workbooks and different sources to our model. For simplicity reasons, in this example we have both our data sources on the same sheet. we click on the button Diagram View. We see a diagram of our two tables. Let's create our first relationship. Relationships between tables means that one field from one table is related with one field from another. Thus, the records with the same value on that field on each table are joined to each other. The common fields here, and so the most likely to relate, are the product fields. Product column here, product column here. We drag the product field from table sales to the product field from table sales 2. The relationship is created. We can create a relationship without using the diagram view through a button of the Design tab called Create Relationship. We go to the Design tab. This is the button. Let's remove the relationship first. We right-click on the line and delete the relationship. We now click on the Create Relationship button. In the first drop-down menu, we select Table Sales. In the second, Table Sales 2. We select Columns Product for both tables and click on OK. The relationship is back here. The button Manage Relationships shows us a list of all of our relationships and gives us the ability to edit or delete them. As you can see here, we only have one relationship in our current data model. But what is the practical use of all this? We click on the Home tab and then on the Pivot Table button. We have various choices. Let's choose the first one, Pivot Table. The pop-up asks us where to place our pivot table. We choose the same sheet we can now see the familiar environment from pivot tables, with a small addition. The field list now consists of the fields in both our tables. We select the price per item to columns and the product field for rows from table 2. The sum of quantity from table 1 as values. And the pivot table is ready. As far as pivot tables are concerned, this is not a so useful one. We used it for simplicity to show the steps needed in creating it. The important thing here is that in our pivot table, we depicted data from two different sources. By following the same steps, we can create a pivot table that gets data from numerous data sources related between them in various ways. Power Pivot truly has no limits other than our own imagination and the amount of data we feed in it. We will dig in a little deeper on the next lecture. Let us take the next step in Power Pivot tables. We will talk about hierarchies in Power Pivot and will show a bit more of its functions. In our current sheet, we have two tables. They are already added in the data model. In the first table, we can see the sales of a company for the year 2016, and in the other table, we can see the price per item for each product. We go to the Power Pivot tab and click on Manage. We can see that we have already added the two tables, as we said before. We toggle the diagram view and we notice the relationship between them. Before we talk about hierarchy, let's click on the Design tab and create a date table. We'll go to the Design tab, Date table, New. A new table has been created, which is basically a table of all the dates in the year. We will create a relationship between our date field of the first table and the date field of the new table. If you notice on the calendar, there is a field called Date Hierarchy. The hierarchy field is a collection of columns that we can create as child levels nested under the first in their order. In this case, the hierarchy field will show us the year and nested under it as child levels of a tree-like form the month and the date column. Let's create a hierarchy of our own in the second table. We right-click on the product field and select Create Hierarchy. We will use the name Product and Price. We need to add the price per item field in it. We can either right-click on the field and add it to the hierarchy, or we can simply drag and drop it in the required order. If we right-click on the hierarchy field, we have a number of choices. We can move it up or down, which can also be accomplished with drag and drop, or we can also rename it. We will go to the date column field and do just that. We will rename it to Date of Sale. We will then right-click on it and hide the source column name from all hierarchy fields to avoid mixing them up with other similarly named fields in our model. Now it's time to see how these all affect our pivot tables. We create a new pivot table in a new sheet to have more room in a new worksheet. We can now see that we have 3 tables in our field list. We set the quantity as values, the date hierarchy as columns, and the product and price hierarchy as rows. We can see that in the column section only one column exists, the year 2016. This is the first field in the date hierarchy. By clicking on the plus sign, we can see that a lot more columns appeared, showing the months that at least one sale took place. This is the second field of our hierarchy. So if we click on the plus sign of February, we see the third field, Date of Sale, appear under it. It is very convenient to have a flexible way to review our data. In this example, we can see the dates of sale from February only without having to see all the columns of all the dates of sales. Something like this could make our data unreadable. In the rows hierarchy field, the nested field provides us with some extra information about the parent field, which is the price in this example. The price for coats or jeans. Reviewing our table, we decide that the date of sale field is useless for our current analysis. So we go back to Power Pivot and remove it. Date of sale, remove from hierarchy. We save our changes. This is the final layout of our pivot table. Some of the most useful features in Excel are hidden under the Data Ribbon button, What If Analysis. In this lesson, we will try to explain and use the Goal Seek feature. This tool allows us to see how one data item in a formula impacts another. In our example, we are planning on buying a new car, and we have our eyes on a certain model with a cost of $20,000. Unfortunately, we don't have the money and have to turn to a bank for a loan. The initial offer from a banker is shown in the current spreadsheet. The rate is 6% per year for 5 years of monthly payments, which leads to 60 payments in total. As you can see, the monthly payment needed to fill the requirement is approximately $386. This happens to be over our budget and we want to explore more possibilities. We feel that we can pay more than $300 per month, but we can handle a bigger duration of the loan. Here is where a goal seek kicks in. We choose from the data ribbon the What If Analysis button and then the Goal Seek tool. In Set Cell, we choose the cell we want to set to a new value. In our case, cell E7, which is the monthly payment. We send the value target, which in our case is minus 300. It is minus because it is money we give to the bank. And the cell we want to change is the number of monthly payments, cell C7. We press OK, and the result is a bit more than 81 months. That sounds a lot. We click on OK to keep the result and decide that 80 months in total are the top of the duration we can accept. We change the term to 80 and the payment increases to approximately $304. We click on Goal Seek again, but this time the goal is to alter the annual rate of the loan in order to achieve the required value, which is the minus $300, by changing the cell B7, which contains the annual rate. We press on OK. So, if we can find a bank that can provide a 5.6% annual rate for our loan for an 80-month period, and for the $20,000 we need, we are within our goals. Now we can be off to the banks and negotiate a loan, having a more precise idea of what to expect and what to ask for. Although Excel's Goal Seek is a powerful tool, it has one basic limitation. It allows only one variable to be changed to help us achieve our goal. Excel provides an even more powerful tool that bypasses this limitation, the solver. The solver is in the form of an add-in, which must be enabled before you can use it. Let's see how to do that first. We click on the File tab of the ribbon and then on Options. Then select Add-ins, and from the drop-down list we select Excel Add-ins and click on Go. A pop-up window appears which contains a list of all the add-ins. We tick the box next to the Solver Addin and click on OK. If we go to the Data tab of the ribbon, we will see that a new button has been added. Let's test it. In our example, we are planning on buying a new car and we have set our eyes on a model with a cost of $20,000. Unfortunately, we don't have the money and have to turn to a bank for a loan. The initial offer from a banker is shown in the current spreadsheet. The rate is 6% per year for a 5-year duration of monthly payments, which leads to 60 payments in total. As you can see, the monthly payment needed to fill the requirements is about $386. This happens to be over our budget and we want to explore more possibilities. We feel that we cannot pay more than $300 per month, but we can handle a bigger duration of the loan, but only up to 80 months. Also, the interest should not exceed the 6% rate we have already found. In such a small-scale example, we could have used the goal seek multiple times. With Solver, we are a lot more flexible. We click on our newly added button. In the Set Objectives field, we set cell E7. By changing variable cells field, we provide the cells that can be changed to achieve our objectives. These are cells B7 to C7. Now we can add our required restrictions. First, the required monthly payment. Cell reference E7 should be equal minus 300. It is minus 300 because we have to give this money to the bank. Then cell reference B7 for the annual rate, which has to be less than or equal to 6%. 6%. And finally, we add the number of months, cell C7, less than or equal to 80, which is our top limit. Click on OK. Here we have all our restrictions. Before we click on Solve, let's have a small tour of the interface. Below the Add button we have just used are the buttons to change or delete one of the added constraints. Then is the button to reset all constraints, followed by the button to load or save a set of constraints for future use. By clicking on the Options button, we have access to various options of the Solver Addin. Let's review some of them. The Constraint Precision, which defines the steps of the values of each constraint in order to reach our objective. A smaller number increases the precision of our calculation, but in larger scale projects can vastly increase the time of execution. The Show Iteration Results is the option to use if we need to access all the evaluation steps of the Solver Addin. Automatic Scaling makes sure that extreme values are not used for the solution of the solver. For example, one monthly installment of $20,000 with zero interest. So we select it, it is already selected, and press OK. Since our problem is a non-linear problem, we will choose the non-linear method and click on Solve. A new window appears. On the left we have the option to keep the solution or revert to the original values, with a checkbox just below to return us to the Solver window. On the right, there are a number of reports the Solver Addin can produce and store on separate worksheets. Since we are satisfied with the supplied solution, we press OK. We can see that with a 5.6% annual interest and 80 months of monthly installments, we will have to pay $300, exactly as much as we need it. The Solver Addin has a vast array of applications. We cannot cover all this in this lesson, but hopefully you learned enough to be able to use and eventually master it.
We hope you enjoyed our course and now you feel confident enough to use Excel for every aspect of your life, either for creating a home budget or for creating a sales chart for your boss.
Of course, we have barely scratched the surface of what Excel has to offer.
If you have any questions or comments, don't hesitate to contact us.
From Anita,
And from Cornelius,
keep excelling in everything you do.
see you!
See you!